Hello, I am Varun Joshi and I welcome you to Cloud with Varjosh, where we talk about cloud, DevOps, and everything in between. What you are about to watch is a fully consolidated Argo CD masterclass. 10 structured lectures, 12 hands on demos, and over 9.5 hours of production focused GitOps learning brought together into a single continuous experience. This video is for engineers who prefer depth in one focused flow instead of jumping across fragmented tutorials. For completeness, I have retained the original lecture transitions so you can map sections back to the detailed GitHub notes easily. Before we begin, I want to thank the community. The feedback on the CKA and CI/CD courses has been overwhelming. Hearing that you cleared interviews or understood production CI/CD by following along end to end genuinely motivates me to build deeper, more structured courses like this one. After CI/CD, the natural next step is GitOps. If CI/CD pushes artifacts, GitOps governs environments. As systems scale across clusters, teams, and services, GitOps becomes essential. And that's exactly what this masterclass focuses on. Before starting, you should already have basic understanding of Kubernetes, basic understanding of Docker, basic understanding of CI/CD concepts. We are not covering Kubernetes or Docker fundamentals here. Everything you need as a foundation is already available on this channel through curated playlists. Once your fundamentals are clear, this masterclass takes you into production grade GitOps design using Argo CD. This is not a UI walkthrough. It is not about clicking buttons inside Argo CD. This masterclass is about understanding how GitOps operates in real production systems. We won't just install Argo CD and deploy a demo app. We will design deployment strategies. We will understand reconciliation behavior. We will configure guardrails and access control. We will explore scaling patterns across clusters and environments. You will learn how teams manage multi environment deployments, multi cluster GitOps setups, microservice orchestration, RBAC, and project guardrails, safe and scalable GitOps patterns. The goal is not to make you comfortable using Argo CD, the goal is to make you confident designing GitOps systems. This consolidated masterclass includes 10 focused lectures, 12 hands on demos, 9.5 hours of structured learning. We begin with GitOps fundamentals and Argo CD architecture. From there, we move into applications, reconciliation, pruning, and self healing. We implement Argo CD projects and RBAC for production guardrails. We cover sync phases, hooks, and sync waves for controlled orchestration. We integrate Helm, we implement the app patterns, and finally we scale across clusters and environments using Argo CD application sets. By the end, you won't just deploy applications, you will understand how to architect GitOps platforms. Do not just watch this passively. Pause the video, clone the repository, apply the YAMLs, experiment intentionally. Ask yourself what happens if this sync fails? What if the order changes? What if a cluster becomes unavailable? Production grade engineers don't memorize commands, they understand system behavior. If you complete this masterclass hands on, your perspective on deployment systems will change. Alongside this video, you have a structured GitHub repository. It contains all the YAMLs used in the demos, organized notes, clean explanations, reference patterns. Keep it open while learning, and if you find it helpful, consider giving it a star so others can benefit as well. If this masterclass helps you in interviews, production, or real world projects, let me know. And if something can be improved, tell me that too. Your feedback shapes future courses. By the end of this course, you won't just know Argo CD, you will understand how GitOps works in production and how to design it with confidence. If this adds value, like the video, subscribe, and leave a comment. It helps the channel reach more serious learners. And if you would like to support the work further, you can join as a channel member. Nothing is locked behind paywalls. Membership simply supports the continued creation of structured, in depth DevOps courses. So let's get started. Hi, I am Varun Joshi and welcome to the first lecture of our Argo CD Basics to Production course. Before we jump into tools like Argo CD, it is important to first understand what GitOps actually is and why it exists. GitOps is not just another deployment tool or a CI/CD pattern, so to speak. It is an operating model that changes how applications and infrastructure are managed using Git as the single source of truth. In this lecture, we will understand why GitOps was needed, the problems teams faced before GitOps, and how concepts like pull based deployments, continuous reconciliation, and repository ownership solve those problems. We will also separate application pipelines from configuration pipelines, which is foundational for everything that follows. This lecture sets the mental model for rest of the course. So let's get started. Why GitOps? Now, firstly, before discussing anything, let's sort one thing clearly. When I talk about your application code is properly version controlled and it adheres to the Git discipline. So, for example, you see app1 repo here, and there are developers who will be pushing and pulling based on their needs, and then it follows the hierarchy as well. For example, if someone wants to work on a feature, he or she will be creating a feature branch, and then on that feature branch all the changes will be performed, and then a PR will be raised to the main branch if you are adhering to trunk based workflows, or to an environment specific branch if you are adhering to Git flow based branching strategy. Again, in production implementations, your environment branches and your main branches will be protected. So you will not be able to push directly onto those branches. You will be pushing onto feature branches and then raising pull request for the merge to happen. Again, we have discussed these concepts thoroughly in our CI/CD series. If you want, you can refresh your memory. We discussed that there are two branching strategies. There is Git flow based and there is trunk based. Git flow will have environment specific branches, and trunk based will only have main, which will be the single source of truth. And then both of these have feature branches which developers or DevOps engineers will be creating based on their requirements. Now let's go back to GitOps. So application code was properly version controlled. So how things looked: application code managed in Git with branching, PRs, reviews, and tests. Infrastructure, although it was defined as infrastructure as code, but it was applied manually. Understand what we are saying here. We are saying we are using IAC, maybe you are using Terraform, but those configuration templates, those Terraform templates are not version controlled. They are lying in someone's laptop or scattered across DevOps teams. What I am trying to convey here is the infrastructure template or your Kubernetes manifests or your Ansible playbooks or your chef recipes or your Puppet manifests or your customized templates or your Helm charts all were scattered in DevOps folks workstations or into their jump hosts, which is not what we want. We want the infrastructure templates to also adhere to the same strategy that application code uses. And what is that strategy? That strategy is we want everything that is supporting the application to run properly be also version controlled. Hence, we want both infrastructure and configuration level things to also adhere to the same principles of Git, which is branching, PRs, reviews, and test. So as of now, things did not look like this, at least for infrastructure and configuration files. And when I say infrastructure, I imply your Kubernetes cluster itself or your traditional virtual machines or anything else on which your application runs. Then configuration is essentially your Kubernetes manifest and op config. Now op configs, as in, you can think of these as Ansible playbooks, chef recipes, Puppet manifests, and so on. So both of these were outside of Git flow. What we are saying is we want these also to be version controlled. Now, what are the challenges if there is not a unified model? First is no single source of truth. Now, if you are not using Git for your infrastructure and configuration, then of course there is no single source of truth. Second is desired versus current state mismatch. Now understand, there is a Kubernetes cluster, let's say, and then there is a Git repository. For this example, let's say you have version controlled your Kubernetes manifest. So what you have done is you have defined the desired state of your Kubernetes workloads in your Git repository. So let's say you have defined you want 5 replicas for app 1, and then there is a cluster which has deployed your resources. So what is running in the cluster is the current state. What is defined in Git is desired state. Now someone walks up and changes the current state, that is, someone went and edited the deployment to have 3 replicas, but what you defined was 5 replica. And always what you have defined in your configuration is your desired state, not what you have applied or what you have edited in your cluster. And this not just implies for Kubernetes, this implies for Terraform as well. What you have defined in your Terraform template is the source of truth. If someone changes the infrastructure manually, then there is a drift. Similarly, if I have defined 5 replicas in my Git repository for my deployment related to application 1 and someone manually changes that in the Kubernetes cluster manually, then there is a mismatch. The desired state does not match the current state. This is a problem for me. Now understand, there are 2 challenges we are discussing here. I want you to pay clear attention. First is, we are saying the infrastructure and configuration files were not version controlled. That is challenge number 1. Challenge number 2 is, even if they are version controlled, there is nothing which would take care or ensure that the desired state matches the current state, because once you have applied that configuration file onto your Kubernetes cluster which warranted 5 replicas, and there is the current state which only has 3 replicas, there is no one who could sense that something has changed and something is not in line with what is defined in Git. We do not have that definition. So these are the two clear challenges. First is infrastructure and configuration files were not version controlled. Secondly, if they were version controlled, there was no one who could check that whether the desired state matches the current state. And again, desired state is defined in Git and current state is what is running in your cluster. The next point is weak audit and rollbacks. And this is true. If you are not version controlling anything, then how do you track that, okay, this application resulted or this Kubernetes deployment resulted from this commit ID? If you do not know, then your auditing becomes really weak, and rollbacks are another challenge. If you have changed something manually, how will you roll back? You have to have manual methods to roll back. And firstly, you should know that someone has changed something to roll back. And that feature is not available because there is nothing that is comparing the desired state with the current state or the current state with the desired state. And then rollback is not just this. If you are not version controlling your config files, you do not know where to roll back because there could be 10 DevOps engineers and you do not know whose configuration file to trust, who is holding the configuration that that application demands. So rollback is a challenge in both the scenarios. If you are not version controlling thing, then also rollback is a challenge. If the desired state is not matching the current state, then also rollback is a challenge. Difficult to trace changes and revert safely. Then you have environment drift. So you have created manifest files for dev environment, stage environment, prod environment, and after repeated manual changes, all these are running different things. You do not know what was the initial state or what is the state in which the application is now running fine. All of these things are manual, and trust me guys, I have been there. If your configuration files, Kubernetes manifests are not version controlled, sooner or later it will come to you, and no one will hear when you say this was not done by me, this was done by someone who has left the organization now. These things will not be catered. So from now itself, if you are not version controlling your Terraform templates or your Kubernetes manifests, start doing that. Then you have security risk. Now let's say you have version controlled your infrastructure and configuration files, right? You have done that. But when your CI like Jenkins would want to deploy onto your, let's say, Amazon EKS cluster, you will have to configure your CI, your Jenkins, to have access to your Amazon EKS cluster for the CD to take place, for the deployment to take place. And this is a security risk. Why would I want to provide my CI server access to my Amazon EKS cluster? And often when you are deploying things, you would want to give the deploy access, and maybe as part of your pipeline you are also deleting something, and in that scenario you would also have to give that delete access. And this looks okay if your environment is governed properly, but what if there is a leak? What if there is a pipeline triggered which should not have been triggered? So what we want is, we first want to have principle of least privilege in place. So that is all right. But we also want that our CI server should not have access to my Amazon EKS cluster. I would want something that can be done within my Kubernetes cluster to ensure that I don't give access to my cluster to my CI server or to even humans. I don't want anyone to have deploy or delete rights in my Kubernetes cluster apart from the automation that I purposefully built for it. And we will see what that automation is in a little while. I hope you understand what all are the problems. So again, I'm repeating, there were two main problems. First is infrastructure and configuration files were not version controlled. Second was, even if they were version controlled, there was no controller which could check the current state matches the desired state. Now, with this understanding, let's go to the next section, which is what is GitOps by CNCF. Now, there is Open GitOps. Open GitOps is a project which is catered by CNCF. It falls under the CNCF umbrella. So what I have done is I'm giving you the definition of GitOps as given by them. It is an operating model. Again, GitOps is not a tool which you can buy. It's a methodology. It is an operating model. It is like DevOps, DevSecOps, all of these things. These are cultures, these are methodologies, these are operating models. These are not tools which you can buy. You cannot touch them. These are logical concepts. So it is an operating model where the desired state of applications and infrastructure is declared in Git. So Git will be the single source of truth, and software agents continuously reconcile the running system to match that state. So understand, like I said, there were two challenges in the previous screen. First challenge was infrastructure and configuration files were not version controlled. So GitOps says, firstly, both of these should be version controlled. And second, it says that there must be a software agent that should be continuously looking at reconciling the running system. And what does reconciling mean? Reconciling means that software agent should be ensuring that what is running in your Kubernetes cluster right now matches what is defined in Git. And now I would also want to go to my browser and show you these principles. So GitOps principles, and this is the official website, opengitops.dev. It says declarative, versioned and immutable, pulled automatically. This is important. So if there is a change in your Git, your Kubernetes cluster should know that I have to pull those changes. That should work automatically. And we will see how all of these things happen slowly and steadily as we move along with this lecture. Last one is continuously reconciled, and this is important. The current state continues to match the desired state. Now let's go back to our draw.io and let's see benefits of the GitOps model. Single source of truth, we already know. Drift detection, we already know. If someone manually changes something in my Kubernetes cluster, I have a software agent running in my cluster which is continuously checking with Git whether my current state matches the desired state. So drift detection. Improved security. Now this is an important piece. Previously, if you have seen my DevSecOps mega demo, you know that we had to provide Jenkins user access to my Kubernetes cluster to deploy resources. But when you are using GitOps, you do not have to provide your CI/CD pipeline or your CI/CD orchestrator like Jenkins, GitLab, or your GitHub Actions access to your cluster, because there is an agent already running in your cluster which is directly checking your Git repositories to see if there has been a change. If there has been a change, those changes are automatically rolled into your cluster, and we will see this workflow in a little while. Audit and rollback. Since everything is governed by Git, we can say that it is auditable by default. And rollback. This made me the happiest. I'll tell you why. Let's say you rolled out some change, you changed something in your Git, and your configuration resulted in your cluster breaking. Maybe your application didn't work properly. Now, what you can just do to roll back is you can just run git revert, and your software agent, which is continuously scanning your git repo, sees that and does a rollback. So no extra terminals, no extra jump hosts, just one command git revert, and you are back to your happy state, which is so cool in my opinion. And then the next one is clear ownership. Shared application build responsibilities. DevOps manages platforms and infrastructure. And I will zoom in into this clear ownership part in the next slide. So let's not discuss this here. Next is consistency at scale. Same model across teams and environment, and this will make your life so much easier. When I first learned about GitOps, I will tell you that I was dealing with multiple projects at that point of time, and I introduced this GitOps in every project. So no access to your CI systems, your software agents, which are also called GitOps controllers, will ensure whatever is defined in Git is reflected in your Kubernetes cluster, because we know GitOps is a methodology where changes are pulled automatically and are continuously reconciled. And I want to plant a term in your head right now, because we'll be discussing that later. Previously, when we were using, let's say, a CI CD orchestrator, what we were doing is we were pushing the deployments. And how we were pushing the deployments? We were running commands like kubectl apply, or running Helm or customize specific commands to deploy resources onto our Kubernetes cluster. We were pushing things. But here we are pulling things, because there is something in our Git which our software agent is pulling and deploying onto the Kubernetes cluster. So understanding this at this stage will ease the next part. So let's go back to our diagrams, and we have understood clearly what is GitOps and what are the benefits of GitOps. Now let's see what I want to discuss next. Now understand, I said that everything must be version controlled, be it your application code or be it your configuration files that are supporting your application. So for example, I will have two repositories, and this is a best practice. You can have a single repository, folks, but the best practice, the recommended approach is to have two separate repos. One repo is often called application repository. This will of course hold the source code at large, and then there is application configuration repository. So configuration is the keyword. So configuration is something on which your application will depend. So for example, Terraform templates, Ansible scripts, and all of these things, if they are not there, then there will essentially be no infrastructure for application to run, which is why this is called application repo, which makes sense. And this one is called application configuration repo. I hope this distinction is clear. I want to plant another concept in your head right now. You will have two different pipelines. One pipeline will cater to application repo, and another pipeline will cater to the application configuration repository. So now with that mental understanding, let's deep dive into both of these concepts. So purpose: build, test, and package application code into a versioned deployable artifact. So we are discussing GitOps, so I will talk in terms of GitOps. So here the points that I have mentioned, they can apply to application repository. Some points will apply to application repository, and some points will apply to application repository pipeline. Understand, we are segregating repositories into two bifurcations. So one would only hold application code, and there are other files that will be there, and we'll discuss about them. And then there is the application configuration repository, which will hold the configurations that will help your application run properly. We understand this, but also know there must be an orchestrator that is dealing with what to do with whatever is there in the application repository. And there must also be a pipeline, essentially an orchestrator, and there you will be creating a pipeline which will decide what to do with the files that are available in the application configuration repository. Now, application repository, the pipeline that you would be creating for application repository will be responsible for building, testing, and packaging application code. And we have seen this a million times in our CI/CD series. Again, purpose is to create a deployable artifact. We are not talking about deployment itself. We are just talking about an artifact which can be deployed somewhere. We are not deploying anything in our application repository pipeline. Engrave this thing in your mind at this stage itself. Then contains application source code, which is understandable. It will also be doing tests. If you have your pipeline, it will be doing tests. For example, for compiled languages, you would be using build tools which will be helping you with these tests. And also for interpreted languages, you have tests like PyTest, npm test, and so on. So you will be testing. You will have Docker file. This is important. So contains application code and tests. So both of these things will be defined by developers, your application teams. But there are also things that will be defined or catered by you as DevOps engineers. So what are those things? Docker file. Now, the primary ownership of Docker file is mostly with application teams, but do not think that these are solely their responsibility. You may also be consulted to refine the Docker file, just giving you that basic understanding. But 99% of the times it is application teams who will be handling the Docker file. Then CI pipeline definitions. Now, what are these? Your Jenkins file. If you are using GitHub Actions, it will have its own YAML file. If you have GitLab, it will have its own YAML file. If you are using AWS, it will also have buildspec.yaml. So your pipeline definitions will also be stored here, because pipeline definitions are something that your orchestrator will be using to decide what to do with this code. And that thing is defined in the pipeline definitions. An example is Jenkins file, and other tools will have their own respective YAML files. And build test scripts. Of course, you will be defining your SonarQube tests, your SAST, your DAST, your SBOM, your image scanning. All of these will be defined in these pipelines itself, or they could be defined separately as well. So this repository will contain all these things. Now, we have not discussed Kubernetes manifests or Terraform templates or Ansible playbooks or Chef Puppet, anything. We are not discussing those. Here we have the application code, Docker file, CI pipeline definitions. Then comes the ownership. Now understand, this repository will have mixed ownership, shared ownership, but the primary owner will of course be application team. But you as DevOps folk will be raising PRs, because it is often that you will be changing your Jenkins file or your CI pipeline definitions, or you are defining new tests within your build tool or something of that sort. So you will have ownership, but your ownership will be secondary. Primary will be your developers or your application teams. Now let's discuss application configuration repository, app config repo, and we'll also be discussing application configuration repository pipeline, a pipeline that will taking care of the files that reside in this repository. Purpose: define and control how approved artifacts run across environments. Understand, here the purpose was to generate the artifact, correct? And here that artifact definition must be available for your software agent to pick. Understand, I'll give you an example here. Let's say here a container image was created. Here is your Kubernetes manifest file, let's say. Now, Kubernetes manifest file must have the version of that image, correct? And that version is defined here, because here you have your Kubernetes manifest, Helm charts, customized bases and overlays, Terraform CloudFormation templates, and configuration management definition, Ansible, Chef, Puppet, etc. Ownership is primarily with DevOps, and in most scenarios, 99.99% of the times, you will be the sole owner of this repository and this pipeline. Even this pipeline will be owned by DevOps, but when I talk about repository, the repository ownership will be with developer. Here the repository ownership will be with DevOps. Now there could be certain gray areas in your project, but at large you understand what is the purpose of these repositories and the pipelines that are associated with these repositories. If there is some confusion at this stage, it is all right. Next, I have a detailed architectural diagram which will help solidify your concepts. So let's see what I want to discuss next. GitOps workflow from code to continuous reconciliation. CNCF GitOps perspective. So let's first see what is happening in this diagram. We have two pipelines. One pipeline is this, and this pipeline is associated with application repo. And one pipeline is this. This pipeline is associated with your application config repo. This part is understood. And we already know application pipelines publish artifacts, generate artifact, and then publish. They are not deploying. This is a key concept here. Second is Git declares the desired state. We know that application repo holds the desired state for the application, and application config repo holds the desired state of your infrastructure and configuration files, primarily your Kubernetes manifest. Now, at this point of time, I want to tell you one thing straight away. When I talk about Kubernetes, if your destination for deployment is Kubernetes, there is a GitOps controller, and these GitOps controllers are Argo CD and you have Flux CD. But these are limited to Kubernetes. Understand? Because you will also have Terraform templates, you will also have Ansible playbooks. Now, who is ensuring that the state of the Ansible that you have defined in your Git repo matches the configuration that your application is running? So here for Ansible, we are not saying that we have a tool right now that supports this reconciliation. You can of course have them committed in your Git repo, and that you should. All your infrastructure, be it Terraform, be it Kubernetes, be it Ansible, Chef, Puppet, all of these must be version controlled. But the second point that is extremely important is this one, what we discussed here: pulled automatically, continuously reconciled. Both of these things are right now only mature for Kubernetes. These both are not mature enough for your infrastructure or for your other configuration components. For Kubernetes, we do have. So there is also, someone is saying, Varun, there is crossplane for infrastructure, right? But crossplane is not true GitOps. So what crossplane would do is it can, create resources or manage resources across cloud providers, because it uses Kubernetes CRDs as the source of truth. Okay, if you change something in your Kubernetes custom resource definitions associated with crossplane, it will make that change in your infrastructure. But their Git is not the source of truth for crossplane. It is what you are defining in those CRDs. That is the source of truth. So if I have to tell you that is it GitOps, it is not true GitOps, because we know what GitOps methodology says. It says everything must be versioned and immutable, declarative, and then all these things must be pulled automatically or continuously reconciled. So for Kubernetes, we have a true GitOps controller in form of Argo CD and Flux CD, and there could be more tools. But for other components, there is no true GitOps controller at this point of time. Now, you might be thinking, but Varun, why is there a tool for Kubernetes? Why can't we create different tools? And understand, if you're dealing with Terraform, you still have to run Terraform plan to see whether your current state matches the desired state. So desired state is what you have defined in your templates, and current state is what is running in your infrastructure. There is a way, but there is no controller who is continuously monitoring that. Of course, when you manually run Terraform plan or Terraform apply, it will tell you that the state is not matching. Of course, manually it is there. But when I talk about a controller who is there just to ensure that the state matches, that thing is not there. So why it is there for Kubernetes? Now understand, Kubernetes already has different controllers. Hello, you have seen deployment controller, right? Deployment controller and replica set controller, these are already ensuring that if someone has defined 5 replicas are already running. So it is easier to integrate GitOps controllers with Kubernetes than other tools that are available in the market. So in essence, it is easiest and most natural on Kubernetes because Kubernetes itself is built around reconciliation. That is the reason. So let's now get back to that diagram. Application repo pipeline developer change. So let's say there is a developer who modifies the application code. Okay. Now we know as a best practice that once this code is modified, this will be pushed onto a feature branch because your main or your environment branches are protected. So you cannot push directly to those branches. Now in the feature branch is there to isolate changes in feature branches, and then a pull request is created. So once the developer is happy with the code in the feature branch, developer will create a PR. Now for this PR to merge in production pipelines, there will be several checks, and those checks are orchestrated by your CI/CD orchestrator, which is typically your Jenkins, your GitHub Actions, GitLab CI, and so on. So in this example, I have taken Jenkins as an example. So as soon as the PR is raised, a webhook will run the Jenkins pipeline, and Jenkins pipeline will be building the code if it is for compiled languages, and then the testing will be performed, the scanning of artifacts would be performed. So all these things, SAST, DAST, all of these things will be orchestrated by your Jenkins, your CI server. And then you will also have build tools here who will be helping you with your compiled languages. Now, if these terms are alien to you, again, I would recommend you to watch my CI/CD series where we have discussed this Git flow, trunk flow, and all of these things in extreme detail. So if I look at this lecture, the day one, we discussed about what are interpreted, what are compiled languages, how SDLC looks like. So it is imperative that you have this understanding before attempting GitOps. Because what is GitOps? GitOps assumes that you have a pipeline, you have a Git repo, and all of these things already set up so that you can leverage the methodologies, the principles that are defined under GitOps by open GitOps community. So let's take this further. So this will do, and once these tests, once this pipeline succeeds, only then the code will be merged with main or your environment branches. Again, you could also have a manual approval stage here, which I have not shown. And let's, for this example, say the merge happens without this manual approval. So once it is here, PR approved and merged, artifact marked approved but not deployed. So this is the key distinction. So we have the artifact with us now, and we must publish that artifact somewhere, and that somewhere is typically your image registry if I'm talking about containerized workloads. And since we said that true GitOps is only applicable when the destination is Kubernetes cluster, we can be assured that you will be using Argo CD or a GitOps controller, proper GitOps controller, at least at this point of time, only when your destination is Kubernetes. So here what we are saying, we have published the artifact, we have published the container image onto an image registry like Amazon ECR, Docker Hub, and so on. No Kubernetes cluster changes yet. Push image to artifact image registry. This pipeline has done its job up till here. That was to publish the artifact. Now, the interesting part. Someone is thinking, Varun, this is fine, but how do I trigger my next pipeline? And my next pipeline is application config repo, because we know our configuration files for Kubernetes, the manifest files, live here. So what we want to now do is, here would be a file for my deployment, and there I want to change the image version to whatever I have defined here. And understand, in production implementations, you would be changing not the tag but the image digest. So there are two ways. In lower environments, in development, you could use tags, and which we have been using thus far in this course. But in production implementations, you would not see tags being used. What you use is image digest. So if I go to my browser here, I have opened an image here. So this is my repo name, app2flask, and this is the tag. But when I want to pull this image, I won't be using this tag because tags are often mutable. What I want is image digest, manifest digest, which is truly immutable. If you change one bit in your image, this digest will change. Here with this tag, human errors are possible, but with this image digest, human errors are not possible, which is why in production implementations, always the image digest is used to pull the image. Now let's say we have published the artifact. Now in this repository, we want to make change in the configuration file, in the Kubernetes manifest of that deployment. How do I make that change? Because once I do that change, only then the new version, whatever I have defined here, whatever I have created here, will be deployed onto my Kubernetes cluster. But how do I do that? Now, let's take this everything out for now. If I were to change something manually here, what I would do, first I will make the modifications. I will change the repo tag or repo image digest, and then I will push the changes onto a feature branch, right? And once my changes are pushed to a feature branch, I will be raising a PR. As soon as I raise a PR, here there will be no build. Understand, we are not building a software. We have these static files here. We don't have to build those static files, right? The static file just needs to be updated with the correct version information. So as soon as I raise a PR, what will happen is, because we have to do some sort of validation, right? We cannot just merge the change onto main or environment branch. What happens is, as soon as you raise a pull request, there is an ephemeral environment created. Now, do not think of an ephemeral environment as an entire Kubernetes cluster. This ephemeral environment could just be a temporary namespace, and in that temporary namespace, you deploy your application and you see whether your application works fine. So here is the point where you will be configuring all those beautiful things, your readiness probes, your liveness probes, your startup probes. And when all of these things are successful, and maybe you are performing a quick smoke test of the application, whether the application is accessible or not, or whether it is performing its primary function or not. And then once this testing is performed, only then the code is merged. Only then the version is updated in the main branch or your environment branches. And once that is done, that ephemeral environment is decommissioned. So that's how the validation is performed. And once the code is merged, hello, there is someone like Argo CD controller or your Flux controller, which are essentially GitOps controller, is continuously watching your Git repository, and as soon as it sees there's a new version of the application, it gets to work. And that is what we discussed here. We said it pulls changes automatically, and here it is pulling those changes. Another thing is, if someone changes something manually in your Kubernetes cluster, for that deployment file that is already being tracked by your GitOps controller, that Git repository is already being tracked by your GitOps controller, it detects runtime drifts, auto revert cluster to Git. So whatever is defined in Git is the single source of truth. This part I'm sure 100% everyone has understood. But the question then becomes the primary question, the handoff. This was, we defined what will happen if we do this manually. But the question is, how will this inform this pipeline to trigger? How will that happen? And my friends, that is where your CI will be doing this. What your CI will do, once this artifact is published, you will configure your CI to clone this repository, correct? Make the changes, push the changes onto a feature branch, and then create a PR request. And upon creation of that PR request, whatever we discussed before happens in the same sequence. So the only thing in manual versus pipeline getting triggered because of this is, here it is done by a DevOps engineer, manual changes are performed by a DevOps engineer, and here the handoff happens by, let's say, a Git user or a Jenkins user who will be doing all these things what a human would do in an automated fashion, which is why I have this point here. App config repo pipeline is triggered by two things: developer driven pull request, which we saw here if developer made a change. And understand one more thing, in this pipeline and in this repo, primarily from a DevOps perspective, only the image tag will change, nothing else. I mean, of course, there could be exceptions, but when you upgrade an application or make changes in that application, all those changes are contained in your container image, and that container image has a tag or an image digest. So essentially, whenever application teams or application repo will have change, they will be just changing the image tag. So this, when this happens, developer driven pull request, application code changes, and it is only the tag that will change, nothing else. And that is understandable. But DevOps driven pushes, if I am a DevOps engineer, I will not be catering anything here because I want to make changes in something. And what could those changes be? I could be changing maybe the requests and limits. Maybe I am, creating a new namespace. Maybe I'm creating a deployment. Who knows? Whatever I, DevOps engineer, want to be there in my Kubernetes cluster, I'm doing those changes. Maybe I'm creating a network policy. Maybe I am creating a config map, and the list goes on and on. In that scenario, if DevOps person wants to make a change, he or she won't be adhering to this hierarchy. He will just make the change here, and then in the feature branch, she will push the change, and then validation will happen and the change will be deployed onto your Kubernetes cluster. So that is how this will work. So understand two flows. One is developer driven, which we discussed. So all of these things will happen. And one is DevOps driven, where only this will happen. I hope this makes sense. Now with this understanding, I want to discuss two methodologies which I discussed initially as well. Deployment models. There is push based and then there is pull based. And we have been dealing with push based since the inception of our CI CD course, and that is very traditional. You handle both CI and the deployment part in your CI CD pipeline. And in our mega project as well, we did that. We deployed our Kubernetes manifest onto our Kubernetes cluster, and that required Jenkins to have access to our cluster. So deployment occurs via CI CD pipelines, pushing changes to environment used when traditionally or GitOps is not adopted. Again, push based, pull based. Pull based is GitOps and push based is traditional CI CD. Key trait event driven one time execution. And we know that. So if my pipeline has deployed something, it is not monitoring that. It has done its job and it will rest until and unless someone re-triggers the pipeline. Key trait, that's why event driven. So if there is a change in the repository, then the pipeline will trigger and deploy again. But there is no one who is constantly monitoring the Git repo. There is no GitOps controller here. So one-time execution. Security model, CI holds environment credentials that we have already discussed. So Jenkins will need credentials to your Amazon EKS cluster if you're deploying to Amazon EKS via Jenkins CI. And similarly, GitLab and GitHub Actions would also require the same. Failure recovery. And this is where GitOps shines. I told you, just hit git revert and you are done. Here, you would make the configuration change again in Git repo, and that will result in rerunning of the pipeline. So manual redeploy or pipeline rerun required. So this is what we have seen a million times. Then there is pull based. That is the new one that we have seen thus far. So we have just seen the architecture, folks. Do not worry, we will have detailed demo where we'll be discussing whatever we have discussed in the workflow in the demo as well. I strongly believe that your foundations must be strong, and foundations will only be strong if you can envision what you are deploying, and you can only envision what you are deploying when you have done walkthroughs like this. So you can imagine in your head, okay, I have done this, now I should be doing this, and so on. So pull based is GitOps. Deployment occurs via GitOps controllers, pulling desired state from Git. And here is where your Argo CD controllers, your Flux CD controllers shine, used for runtime and environment state enforcement. And this is the key word here, enforcement. So it ensures, it enforces what is there in the Git is also there in the cluster. So no Varun can walk in your Kubernetes cluster and make some changes which are not defined in Git. Even if he does do any change, those changes will be auto reverted. Then key trait, continuous reconciliation and drift correction. We have seen this. Detection and correction both will happen at same time. Security model, no external system pushes into the cluster. It is your cluster which is pulling something. And we will see how this happens when we discuss Argo CD in detail. Failure recovery, automatic self-healing to last known good state. And this is so awesome. Just one command, git revert, and you are good. I hope you have a strong sense of what is GitOps. That brings us to the end of the first lecture in our Argo CD Basics to Production course. You now understand why GitOps exists, what problem it solves, and how it differs from traditional CI/CD driven deployments. More importantly, you should be clear that GitOps is an operating model, not a tool, and that tool like Argo CD exists to implement and enforce this model. Argo CD in itself, it is not GitOps. It is something that helps you ensure GitOps principles are adhered to. In the next lecture, we will start building on this foundation and see how GitOps is implemented in Kubernetes and where Argo CD fits into the picture. If you have any questions, feel free to drop them in the comments and I will be happy to respond. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi and welcome to second lecture in our Argo CD Basics to Production course. In this lecture, we will start by clearly answering what Argo CD is and why it exists in a GitOps based Kubernetes architecture. We will then dive into Argo CD's architecture, understanding how it follows the Kubernetes control plane pattern and how it connects Git, Kubernetes, DevOps engineers, and CI systems. After that, we will move into hands-on lab where we will install Argo CD on a local Kubernetes cluster using Kind and Helm, verify the installation and access the Argo CD UI. This will prepare our environment for working with application CRDs and real GitOps deployments in the next lecture. This lecture focuses on building a solid mental model of Argo CD and getting it up and running. Now, before you get started, may I request you to please click on the hype button that YouTube shows you. This helps me by spreading my channel across people who like this sort of content. So I would really appreciate if you could do that for me. So let's get started. Now, before I walk you through this diagram on what is Argo CD, what I want to do is I want to quickly revise what we learned in the previous lecture. We said that GitOps is an operating model. Hence, GitOps is not equal to Argo CD or GitOps is not equal to Flux CD. These are just tools that fit in the GitOps umbrella and helps you achieve GitOps like system. And again, I would like to mention that is the reason Argo CD or Flux CD, these are often called GitOps controllers because these are helping you achieve a culture that is called GitOps or an operating model that is GitOps. So it is an operating model where the desired state of the applications and infrastructure, and we know application will be stored in a repository and infrastructure will be stored in a separate repository which is often called application config repository. We have learned these things in the previous lecture. So both application and infrastructure is defined in Git, and software agents continuously reconcile the running system to match that state. So whatever you have defined in Git becomes the single source of truth, be it for the application or be it for the infrastructure. And let's now see what were the principles of GitOps that we learned. First is declarative. I told you whatever you are doing, you should not be doing them imperatively. If you do that imperatively, there will be no history. Who will know what was applied and what was used to apply that? Hence, you should have configuration files when it comes to your Kubernetes manifest. Now, since GitOps is primarily right now only truly available for Kubernetes, which is why I will talk about Kubernetes manifests only. But as you already know, there are Terraform templates, other Ansible configuration files, playbooks, runbooks, scripts. All of these should also be version controlled so that you can go back in time and see how that script or how that code matured over time. And not just that, if you mess up something, then you can always go back in time and bring the file or bring the configuration that worked properly for your environment. So first point is declarative. All your Kubernetes manifests must be declared in YAML files or JSON and must be version controlled. And we are saying immutable. Immutable does not mean that you cannot change those configuration files. Immutable here implies if something goes wrong, then you can always go back in time and restore the working state for your cluster, for your application. Third is pulled automatically. So whatever is there in Git, your GitOps controller like Argo CD will pull that automatically. And the last point is continuously reconciled. Even if someone changes something manually, these GitOps controllers are intelligent enough to detect that and then revert your cluster to match the state what you have defined in your Git repository, which is the single source of truth for us. Now, with this quick revision, let's quickly start with the discussion on what exactly is Argo CD. It is a Kubernetes native. I want to stop here. What is Kubernetes native? Kubernetes native is something which can be deployed in the cluster itself. So Argo CD is not an alien to the cluster, although it looks like an alien, but it is not alien to the Kubernetes cluster or the Kubernetes ecosystem. I say that because whenever you hear the word Kubernetes native, understand that Kubernetes is an extensible system. It is a modular architecture, which is why anyone who wants to integrate with the cluster can integrate as long as the standards set by the Kubernetes community are adhered. And Kubernetes community says as long as you can define custom resource definitions, which are CRDs, and you can create custom resources based on those defined CRDs, you can integrate your system with Kubernetes. So that is what Argo CD community did. Argo CD community designed Argo CD to be Kubernetes native, which is why when we will deploy Argo CD, you would see that it uses custom resource definitions, custom resources, and of course, a controller that continuously monitors those custom resources. And if there are any gaps in this understanding, I would humbly request you to watch the custom resource and custom resource definitions lecture in my CKA playlist. I will link that up here. And having said that, we will also discuss this in a little more detail in our next lecture. So what is Argo CD? It is a Kubernetes native continuous delivery tool that implements the GitOps operating model. It implements it. It is not GitOps in its own. It acts as an automated reconciler, which we know it reconciles the running state with the desired state, ensuring that the live state of the cluster always matches the desired state declared in Git. Now, someone may call it live state, someone may call it running state, or someone may call it current state. They all mean the same thing. The motto of Argo CD is to ensure the desired state matches the current state. Now let's see what is happening in this diagram. So you have a Kubernetes cluster here and you have Git repositories, and we adhere to the best practices, which is why we have separated the application code and the configuration repositories. I also want to highlight in this diagram, we are dealing with two applications, application 1 and application 2. Both of these applications are monitored by Argo CD, are reconciled by Argo CD, and hence the respective repositories for these application, respective configuration repositories for these applications are connected with Argo CD. Now, how these are connected is a separate story which we will be dissecting in the next lecture. But for now, understand Argo CD is continuously in interaction or is continuously watching this app config repositories, and based on the changes that you have applied or your CI system has initiated, you as a DevOps engineer or the CI, and we learned this in our previous lecture, the whole flow we learned. Based on that, it will reconcile both of these applications. Now, I want you to notice one more thing. What I have done is I have just shown application 1 and application 2. We do not see any other applications, but understand in a cluster, it is possible that not all applications are watched by Argo CD. Maybe the maturity of some of your applications is not as much as you would like. So they are not compatible or they are planned for migration to Argo CD at a later stage. It is possible there could be application 3, application 4, which are not yet managed by Argo CD, for which the deployments, the implementations are done via our traditional method that we have seen in our CI/CD series. The continuous deployment or delivery for those apps are done by a CI system like Jenkins. So the deployment is taken care by the CI system or the CI/CD orchestrator. But any applications that are onboarded onto Argo CD will not have deployment part of your CI/CD orchestrator. Deployment will always be done by Argo CD, and we know Argo CD will be pulling whatever has changed, or if there is a drift, it will ensure that what I have running matches what is defined in the Git repositories. In real cluster, not all applications are managed by Argo CD. GitOps adoption is often selective and incremental. With that understanding, let's see what I have written here. Kubernetes native GitOps controller. You will see as we progress with this lecture, we'll be installing Argo CD, and you will be seeing Argo CD when installed will also result in some of the custom resources, and we will be seeing how they look like in the CLI. Purpose is continuously reconcile cluster state with Git. Model is pull based. We have seen this. Security, CI has no direct cluster credentials. We know that Argo CD is pulling whatever is needed from the Git repository, and if it is pulling from a private Git repository, then Argo CD must be configured to have credentials to access those repositories. And we will see in our architectural session which is the component that deals with that. The scope is manages only applications explicitly configured. This is an important piece. You could have 10 applications and only managing 50% of them using Argo CD. Behavior detects drift and enforces declared desired state. Role is enforces GitOps, does not build or deploy. So this is Argo CD for you. Stressing on the word only. In a true GitOps model, the CI servers will perform your build, test, scan, and only publish artifacts. They won't be deploying artifacts anywhere. With that understanding, let's go to the next section, which is architecture of Argo CD. Argo CD architecture. Pull based GitOps control plane for Kubernetes. So let's familiarize ourselves with what is happening on this screen. On the right, you have a Git repository. For simplicity, what I have done is I have not shown the app repository, I have just shown the app config repository. We all know that we should also be version controlling our Terraform templates, our Ansible playbooks, and so on. But for simplicity, I have just shown a few Kubernetes manifests. Then at the center, you have our Kubernetes cluster, and that cluster has application1 namespace, and this application1 namespace is using a few Kubernetes objects. It is using deployments, config maps, service accounts, PVCs, and SVCs. Now, do not take this as the only objects that an application could be using. An application could be using many more objects. I have just shown these 5, which is why you see in the Git repository as well, I have the manifest for these 5, because we know Argo CD will be pulling, or will be seeing, will be watching what is there in the Git repository, and then will be deploying resources based on what is defined. Hence, whatever YAMLs that you have defined will be deployed by Argo CD by default. Then here I have shown Argo CD control plane components. Now these are the main components of Argo CD. There are 3 more, but they serve a secondary purpose and do not directly participate in reconciliation. So which is why I have just shown 3 main components here, and rest of them we'll discuss later. It's API server, repository server, and application server. Do not miss the heart here, because application controller is literally the heart of Argo CD, and we'll see why that is. Then you have a DevOps engineer here and an orchestrator here. Now, for some of you, this might be surprising that Varun, you said that Jenkins will not be accessing your Kubernetes cluster. Then why is Jenkins accessing my Kubernetes cluster? I want you to understand one distinction right now. Let's say you have a virtual machine. You have deployed an application onto that virtual machine. When you are accessing that application, let's say you access that application via your browser. You are accessing that application and it works fine, and suddenly it stops working. So to access the application, you do not need to access the virtual machine. The application has its own access mechanism. And if there is a problem with the application, you reach out to the administrator and tells that this application is not accessible. Can I access the virtual machine? Can I SSH into the virtual machine and troubleshoot my application? So there are 2 types of users. One is the admin user that will have access to the virtual machine, and there is a second user that just accesses the application. And in certain scenarios, both of these users are the same. And that is what happens with Argo CD. With Argo CD, DevOps engineer also accesses the Argo CD application, and to access the Argo CD application, the access to Kubernetes cluster is not needed. Although if your Argo CD admin and Kubernetes admin are same, then of course they will have access to both. But in true terms, access to Kubernetes cluster with respect to Argo CD will only be needed when you want to troubleshoot if something is not working with Argo CD. Maybe you want to check the pods, restart, take a rolling restart, or something of that sort. So understand, DevOps engineers who are only Argo CD admins will not require access to the Kubernetes cluster. They will just need access to Argo CD as an installation. And we have seen that if I want to access my SonarQube, I don't need access to the virtual machine that is running SonarQube once SonarQube is deployed, correct? And that is true for most of the tools that we DevOps folk use. Now, so one thing is clear. If my Argo CD admin wants to access Argo CD, I can just provide access to Argo CD and not the Kubernetes cluster. If something goes wrong with Argo CD, then that engineer might need access to the cluster as well. Now let's see the scenario that I am discussing here. But Varun, why would my CI need access to Argo CD? Your CI is not seeking access to deploy anything. It is seeking that access to check the status, and this access is optional. But I want you to know, in certain environments, when Argo CD has done the deployment part, the implementation part, there could be a CI server that is checking with Argo CD whether everything is working fine or not. With For that, I have shown this communication, but you may not always see this communication happening in your specific environment. I wanted you to know that there could be a scenario where your CI is interacting with the Argo CD. Understand, when CI is interacting with Argo CD, it will not need access to the Kubernetes cluster itself. It will just need access to the application, and that application is Argo CD that is running onto our Kubernetes cluster. So understand this point. There could be multiple applications deployed onto your cluster. Users accessing those applications will just need to access those applications, not the cluster itself. Let's now understand what is happening here. First is the API server. API server is the Argo CD's entry point. It is like Kubernetes API server. So if you have seen the Kubernetes architecture lesson, you understand that whenever you want to access your Kubernetes cluster, you go in via the API server. Similarly, when you want to access your Argo CD implementation, you enter your Argo CD installation via the API server, entry point for UI and CLI. And even if your CI is interacting with your Argo CD installation, then it will typically be using REST. And what is REST? It is human readable HTTP based APIs which are commonly used for this purpose. Now, what is gRPC? gRPC is a high performance protocol which is used for service to service interaction. So when a CI would be interacting with your Argo CD, it will typically be using REST, not gRPC. But internal components within Argo CD could be using gRPC. And we don't want to know that level of details as well. Second is handles REST and gRPC requests. And we know why REST access may be required by some of the tools. Last one is coordinates with internal components, and that is right. When you are accessing a web tier, the web tier will bring the information you requested to you, and in turn it may communicate with the application tier, and application tier may in turn communicate with database. But what web tier's responsibility is to show you what you asked for. Similarly, when a DevOps engineer, let's say, is accessing Argo CD using UI, that DevOps engineer, if wants to check status, then it is responsibility of API server to poll whatever components are needed to show that status. So coordinates with internal components. So this is the API server for you. Then let's talk about the repository server. Authenticates and fetches desired state. Like I told you, it is the repository server that fetches the desired state from your Git repository, and repository server must be configured with the credentials. So you configure the Argo CD, but indirectly you are configuring the repository server component to use these credentials when you want to access my private application configuration repository. Second is renders manifest from Git sources. Now, this is an important piece. Understand that here I have just shown you plain YAMLs, but your application could be using Helm charts, values file. It could be using customize overlays, bases, and so on. I want someone to translate those things into plain YAML, because my cluster Kubernetes API directly understands those YAMLs. It does not understand Helm templates directly. They want some sort of engine for that. And that is where this repository server comes into play. It renders manifest from Git sources in a format that Kubernetes understands, and that is plain raw YAMLs. Last is does not interact with Kubernetes API. So repository server is interacting with an external component, that is your Git repository, but it does not interact with your Kubernetes API. That part is done by the heart, which we are going to discuss next, which is the application controller. Watches application custom resources. Now, this is not your application. This is application in terms of Argo CD, and we'll see that in the next lecture. There are application custom resources. Their kind in Kubernetes is application, which is why we are calling it like this here. Watches application custom resources, compares desired and live state. Now understand, when I say watches application custom resource, where do I tell my Argo CD installation that this is the source Git repository and this is the destination cluster which you have to deal with? We tell that using the application custom resource, and we'll be zooming in into this in the next lecture. But someone is thinking, Varun, why do I have to tell this application custom resource that this is the destination cluster you have to deal with? Isn't Argo CD already installed there? You are right to think that, but you can, with one Argo CD installation in one of the Kubernetes cluster, manage other 10 Kubernetes cluster as well. So understand, if you are working in a project which deals with, let's say, 10-15 Kubernetes clusters and all those have a single cost center, then there are chances that you would be installing Argo CD in just one of the clusters, and that Argo CD implementation will be also deploying resources onto your other clusters. But a key point to understand, a lot of security and compliance industries may not like this, because you will have to give access to Argo CD to all those clusters as well. So from compliance standpoint, I will let you decide whether your project could leverage this feature or not. But with one Argo CD implementation, you can manage multiple clusters. But of course, that one installation must be done on a Kubernetes cluster. That is what Argo CD supports. Compares desired and live state. So it is the application controller who checks whether the current state matches the desired state. And who tells the application controller about the desired state? We all say in unison, it is the repository server, because repository server is the one that is pulling the desired state. So repository server and application controller are in touch to know what is the desired state, and based on the feedback given by the repository server, application controller can make changes or sit idle when it comes to application one. So application controller is the one that reconciles drift continuously. Application one namespace contains live Kubernetes resources managed and reconciled by Argo CD. We all know that. Git repository, desired state declaration, GitOps boundary. We also understand that. And at the very bottom, what we see, neither DevOps engineers nor CI system deploy workloads directly to Kubernetes. And we know that DevOps engineers or your orchestrators, these are not deploying resources onto your clusters. It is Argo CD that is doing that. Git is the handoff point and Argo CD is the enforcer. And you might be thinking, Varun, why you have shown CI accessing your app config repository? And if you have been through the past lecture, you won't be asking that question, because we know it is the CI who will make changes here when the application pipeline is triggered by developer driven pull requests. I hope the architecture makes sense. Now let's discuss supporting components. So firstly, why are these called supporting components? So these components are not directly involved in reconciliation logic, but are essential for scalability, performance, and enterprise access. And we'll see how. So first is Argo CD Redis. As the name implies, Redis, it's a caching system. So it caches things to improve the speed without affecting the reconciliation logic. Then there is Argo CD application set controller. What we saw previously was application controller. This one is application set controller. Now this is an advanced topic and I don't want to confuse you right now, but just understand for now that it enables scalable multi-cluster GitOps patterns and it can generate multiple application CRs dynamically. We have not discussed application CRs yet, which is why let's park this for now and later in this course we'll be dissecting this. Then there is Argo CD DEX server. Now if you want to outsource the authentication part and you want to integrate SSO, you want to bring in OIDC or SAML, then DEX is the component that is used. Now that we have this theoretical understanding, let's go and install Argo CD. So I'll go to my GitHub notes right away. And here I will go to Argo CD basics to production. And I'm already there in lecture 2, install Argo CD and architecture part that we have discussed. And here are the certain prerequisites that your laptop or your, if you are using a thin client like Ubuntu VM to do these labs, then you can use these prerequisite to ensure that Argo CD runs properly. So first is Docker desktop. If you are using an Ubuntu VM on cloud, then you can just install Docker engine as well, but anyone who is using Windows, Mac can install Docker desktop. Next is kubectl must be installed. You can install it using this link. Then you must have Helm. We are installing Helm because we'll be installing Argo CD using Helm charts. Kind. So right now at this stage, I want things to be simple so that everyone can follow along with me, which is why I am using a kind cluster. But later in this course, we will be leveraging an actual Kubernetes cluster that could be a self-managed one or Amazon EKS to make sure that you understand the concepts. If kind you are not aware of what is kind, then I already have a video in my CKA playlist that details kind and how to install it. If you are already aware, then you can use this link for the installation. And of course, fifth is IDE. If you want to practice further with me with YAMLs, then you would need an IDE like Visual Studio Code. So with that understanding, let's create a cluster. I will create a single node cluster using this command, that is kind create cluster, and I'll be naming my cluster cloud with varjosh k8s. So I'll go to my terminal. I will paste this command here and I'll press enter. So what this would do is this would create a single node cluster for me. Now understand that if you want to fetch any of these Helm charts from the web, then Artifact Hub is a place from where you can download popular Helm charts. So what I will do is I will access Artifact Hub, and yeah, this one, artifacthub.io. So I'll go here and it is asking me to search for the package that you want to install. So I'll search for Argo CD. It's essentially the chart that you want to install, and there are many results here. So what I would do is I will click on official here so that I see only official results, and Argo CD is the one that I want to install. The Helm chart for Argo CD is what I want. So I'll go to Argo CD, and here if I click on install, it will just give me the instructions on how to add this repo. So once you add this repo, you can install whatever version of Argo CD you want, as long as this repository has that version. So let me copy this. I will go to my CLI and here I will paste it. So Helm repo add Argo. So Argo, I already have it because I was doing practice for this lecture. But if you want, you can use this link to add this repository, and you can name it anything. But if you want to practice along using my GitHub notes, then I would suggest use Argo itself. Now that you have this repository, I will run Helm repo list to see this repo indeed exists, and you can see Argo exists, and there is my Bitnami which I added when I was teaching Helm in my CK series. So what I'll do is I will run Helm repo update. Now see, I have just added a repository. I do not have to run Helm repo update because it just updates the index. So for example, a repository can have multiple charts. Maybe since you added this repo, some new chart versions or some new versions were added. So if you run Helm repo update, it will update that index. For example, my Bitnami, I added this 8 months before or 4 months before. If I run repo update, it will update the index. In this scenario, I don't have to run it, but I want this to be your habit to run Helm repo update so that all your versions are updated, be it for any of the repositories. So right now we added Argo, but there could be other repositories as well which you want updated. I'm just using this for that. So I will run Helm repo update and it will do its job. Now what I can do is I can run Helm search repo Argo. So what this will do is it will search my repositories. Now it is not saying that search my repo Argo. No, it is saying search for Argo in all of these repositories. So if I press enter, it will give me wherever Argo came in all my added repositories. So this time Argo and MyBitnami and Stellar hosted are three of the repositories that I have. Out of these three repos, Argo keyword exists in all of these, but we know we want to use the official repository that we have just onboarded. So now that we have this, let's use the Argo CD instance we want to use. We want to use this one, okay? Because this is Argo CD. There is Argo CI, Argo events, Argo rollouts. We don't want to use this. We want to use Argo CD. So what I will run is kubectl search repo, and here I am searching my repository Argo CD. But Varun, why are you searching? You already know you want to use this. The point is I want to show you that this repository also has multiple versions of Argo CD itself. So if I run -- versions here, I will see it's version -- Varun, it's not kubectl, it's Helm. Sorry folks. Helm search repo this. Now this will list me all the versions that are available for Argo CD. What we will do is we'll use the latest version. So let's install this. Now if you have seen the diagrams and if I scroll up, you see we have deployed all things related to Argo CD in the Argo CD namespace. So we'll do the same for this installation as well. So anything related to Argo CD, we will be deploying those onto the Argo CD namespace. So let's do it. So I will run kubectl create ns, and this namespace I want to name Argo CD. Now the namespace is created. Now let's run our Helm installation command. So Helm install, I will call this my Argo CD. Argo is the repository I wish to use, and Argo CD is the chart that I want to install. And then here I will also give the version. Understand that if you don't supply the version, it will install the latest one automatically. But I wanted this to be like production where you want everything to be predictable. So I will hard code the version that I wish to use. And the version I wish to use, hold on, I have to run that command again. And the version I wish to use is 919. So I will just quit this. And then the version that I wish to use is 919. And then I also must specify the namespace. So the namespace that we created is Argo CD. I will press enter, and this will install Argo CD for us. So this has installed Argo CD for us. Now, these messages are important. Firstly, we will be, since we are using kind, we will be using port forwarding to access our Argo installation. So it is saying that you have to run this command. And what we will do is, what this command will do is, it will forward anything that comes on host port 8080, that is on my Mac, to port 443 of this service, that is my Argo CD server. And this is the API server that gets deployed. But before we do that, let's see what is our password. It is saying us, after reaching the UI, the first time you can log in with username admin and a random password generated. So we can fetch the random password by copying this. So let's copy this first. I will run it here, and this has given the password to me. I don't have to copy the %sign. I'll copy this. I will go to my browser. I will have my password here. I'll just keep this here because we'll first have to port forward. But before we do any sort of port forwarding, let's also do one thing. I will run kubectl get pods -n. Argo CD was the namespace where we deployed our Argo CD components. And you can see whatever components we just studied, all of those are here. Application controller, this is the main one. There is application set controller, there is a dex server, Argo CD notifications controller, we'll see this later. There is Redis, there is the repository server, and then finally here is the API server. So if I run kubectl get svc, then you will see the service that is participating in our port forwarding thing, and you see Argo server, and this is the service which listens on port 443 and 80. So now what we will do is we'll simply copy this from here, and then I will go to a new tab, and then I will paste it here because this will freeze my screen, which is why I'm using a new tab. So now it is forwarding. So if I go to my browser now and I click on localhost, I want to access this on port 8080, and then I also want to add http here, not https. I'll press enter, and this is giving me security warning, which is obvious. I will click on proceed, and here is the part. I will write admin, and then I will paste the password I have just created. I'll paste the password here. I will sign in, and then I will go to user info. I will go to update password, and I'll paste my current password here, and then I will set a new password. So this will make your life easier as we progress with this. Now save new password. Our password is changed. If I go to applications, I'll have to log in admin, and then I'll enter the password. And this is your Argo CD. I don't want to discuss anything right now. We'll be doing that in the next lecture. That brings us to the end of this lecture on Argo CD architecture and installation. You should now understand what Argo CD is, how its core components work together, and how DevOps engineers and CI systems interact with Argo CD without deploying workloads directly to Kubernetes. You have also installed Argo CD using Helm and confirmed it is running successfully. In the next lecture, we will build on this foundation and dive into application CRDs, followed by deploying our first application using Argo CD. If you have any questions, feel free to drop them in the comments. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi, and welcome to the third lecture in our Argo CD Basics to Production course. Before we start talking about application CRDs, which is we are going to discuss in this lecture, it is important we first understand CRDs in Kubernetes in general. Without that foundation, application CRDs can feel confusing or even magical. So, in this lecture, we will start by building a clear mental model of how Kubernetes resources work, how Kubernetes is extended using custom resource definitions, CRDs, and why controllers and reconciliation loops exist. Once that foundation is clear, we will connect it directly to Argo CD and introduce the application CRD. We will understand what it represents, why Argo CD defines it, and how it acts as a bridge between Git and Kubernetes in a GitOps workflow. We will reinforce our learnings with a hands on demo where we create our first application resource and watch Argo CD reconcile desired state from Git into the cluster. So, with that said, let's get started. What are CRDs? Firstly, when you create a Kubernetes cluster, there are certain resource definitions that already exist. So if I go to my terminal and run kubectl API resources, then these are the resource definitions that are already available in the Kubernetes cluster by default. So if you have bootstrapped a new cluster, whatever you see there when you run this command, all of those things are defined by Kubernetes. So these are essentially the resource definitions that are already available. Now, what exactly are resource definitions? Resource definitions are a way of telling when you create a resource using this resource definition, there is a certain schema that you must adhere to. Only then that resource can be created successfully. So, if I talk about my diagram here, here is a resource that we have created using the resource definition deployment. So if I do not indent something in it properly or I miss any of the mandatory fields, then I receive an error that this cannot be created. But if I adhere to the resource definition that is created by the Kubernetes community for the deployment resource, then I can create a deployment resource just fine. As simple as that. So resource definitions built in Kubernetes API type schema provided by Kubernetes itself. And prior to installing Argo CD into our cluster, whatever the result was this command, all of these resource definitions existed by default. We did not create them. These were defined by the community itself. And then what is a resource? User created instance of built-in API declares desired state for Kubernetes. So if I've created this, then this defines I want to have a deployment, and these are the characteristics of the deployment that I want to create. As simple as that. Now, we have been hearing since the very beginning that Kubernetes is extensible, it is modular. So what does that mean? So Kubernetes is extensible implies you can extend Kubernetes. And how do you extend Kubernetes? You extend Kubernetes by defining your own custom resource definitions. And when you define these custom resource definitions, you can create custom resources using that custom resource definition. So if you look at this YAML snippet, what I have done is I have defined my own CRD somewhere. Okay. And if you want to know nitties and gritties of this, you can watch my custom resource and CRD lecture that I created as part of the CK series, where we create a CRD and then we also create a custom resource using that CRD, which uses that CRD. the schema that is defined in that CRD. So once I create this resource using this custom resource definition, firstly, I must adhere to the fields that I have defined in CRD. And if I have defined them clearly in my YAML, then Kubernetes will create my custom resource. That is all. That is why we say Kubernetes is extensible, because I can bring in my own CRDs, I can define my own CRDs, and then I can create custom resources out of those CRDs. The difference between these two is of only the word custom. Custom implies it is written by you or by a vendor or by someone who is helping the Kubernetes ecosystem in some way. So these could be open source as well. CRDs can be open source as well. Now the question becomes, Varun, why are we discussing this in context of Argo CD? Understand, we are saying application CRDs, which is the title of this lecture. So what are application CRDs? Application CRDs are custom resource definitions, which is why we are discussing this concept. Now you also see a controller here, and the controller has optional written in parenthesis. So what exactly does this mean? So when I am talking about built-in resources, there are certain resources that would warrant a controller. For example, deployment warrants a controller, and controller can be thought of as a brain. So controller's job is to ensure that whatever is defined in the manifest is indeed what runs in the cluster. So if in the manifest I have said that I want 3 replicas, then the role of this controller would be to ensure that 3 replicas are always running. If 3 replicas are not running, then deployment controller will be taking some action. It works with the replica set controller and it will be creating pods for you. Or if there are more pods, it will be deleting the pods for you. That is what deployment controller in conjunction with replica set controller will do. And similarly, you have controllers for stateful sets. So they will ensure that stateful sets, the pods part of stateful sets, are created in order. They get stable storage identities, and there are many more functionalities to it. If I talk about cron job resource in Kubernetes, that also has a cron job controller, which ensures that whatever schedule is defined in the cron job, that schedule is adhered to. So something that is defined is run at that specific interval. Even the job resource also has a controller which will take care that a user has defined, user wants 3 pods to run till completion, till I say this job is complete. So that controller takes care of that. But not every resource has a controller. For example, if I talk about config maps, if I talk about secrets, they do not have a controller because they are just created once. These are essentially static. There is no controller needed to watch them continuously. So they do not have a controller. So I want you to understand that there are things that require a controller, and those things would essentially be that could deviate from their state. For those things, you have controller. So the job of the controller is to run sort of a control loop, observe the desired state, compare with the current state, and take actions to reconcile if the desired state does not match the current state. So that is what a controller will do. Now, if I talk about services, Kubernetes services, they do not have a controller. But Varun, who takes care of removing and adding the pods in the load distribution if services do not have a controller? See, all these pods are called endpoints. So when you run a describe on a service, you will see that certain pods are associated with that service. And we know that these work on the premise of labels and selectors. So what happens is there is a endpoint and endpoint slice controller which takes care of these things, which is why the service does not have a controller. And namespaces, Kubernetes namespace is a resource which also does not have a controller. So the crux of this is there are certain resources which will have controllers, and there will be certain resources that will not have a controller. When I talk about something that has a controller, you would often hear the term the operator pattern. So if you have heard about Kubernetes operators, it is something that has a CRD, and then there is also a controller which acts as a brain and ensures that whatever user has defined is there in the cluster. So that is the reason you hear terms like Argo CD operator. Argo CD is an operator because Argo CD underneath has CRDs. It has defined certain custom resource definitions, and using those custom resource definitions, you create custom resources. And application is one of the custom resource that gets created in Argo CD using the application CRD. So that is the crux of this discussion. Now, if I go to our lecture 2's diagram, we saw that Argo CD also has control plane components, and there is an application controller along with other pods that we saw in the past lecture that continue to run. So the role of this application controller is to ensure the desired state matches the current state. So now, before I leave this screen, I want to show you one more thing. So if I go to my terminal and I run the same command again, but only this time I will grep for Argo. And voila, these are the three CRDs that are defined by Argo CD. And if you see, here are the short names for these. Here is the API version. So whenever I create an application resource, so whenever I create a resource with kind application, I will be using this API version. And if I run kubectl get, I can use these short names for the applications resource. I hope all of these things are connected. Remember, why are you seeing these things here? You are seeing these things here because we have installed Argo CD onto our cluster using Helm in our past lecture, which is why these CRDs exist, and using these CRDs we can create respective resources. Now that we understand all of these things, what are CRDs, what are custom resources, let's understand application CRDs. Now, right off the bat, I want you to know that application as a term, application resource as a term, belongs to Argo CD, not your application that is running onto the Kubernetes cluster. We are talking about the application resource associated with Argo CD. Now let's read the first line. Application resource defines a deployed application instance. Varun, what is application instance? Now I want to simplify this because this was a point of confusion for me initially when I learned Argo CD. Now let's scroll to the left. Now we have discussed microservices architecture, multi-tier architecture in detail as part of one of my CK series lectures. So I will link that lecture. If you do not understand what is microservices design, what is multi-tier, I would encourage you to watch that lecture, because in modern application development, that architecture becomes really important. So first, we have a microservices architecture. Here we have application 1, and application 1 has 3 microservices. Microservice 1, microservice 2, microservice 3. Now, as a best practice, what happens is you create one repository per microservice. So this will have a microservice repository, a private repository, and then microservice 2 will also have a private repository. Let's say we are calling it microservice 2 repository, and similarly microservice 3 will also have a microservice 3 repository. So the crux here is each microservice gets its own repository, Git repository. Understand, I am not saying this application 1 receives a repository. No, microservices that are part of that application, that constitutes that application, those microservices, each of them receive a repository. But Varun, can't I create one repository, app one repository, and then have different directories within my repository depicting microservice 1, microservice 2, microservice 3? Of course you can, but should you? No. As a best practice, you should have separate repositories for your microservice. And we will see how these things are important as we progress with this section itself. Then, what is the application CRD doing? What application CRD is doing, my friends, is application, the resource that you create using application CRD, that is of kind application, connects your repository to your Kubernetes cluster. So in the application resource, you defined the source repository and the destination cluster, and that is how Argo CD knows which is the source and which is the destination, and we will be dissecting this throughout this lecture. And similarly, you could have a three-tier design: web tier, app tier, and then there could be a database tier. I have not shown data tier here because data tier could be part of, Amazon RDS. We do not need to deploy that. That's not a must that a database is deployed in Kubernetes. Most of the times, at least when I talk about managed services on cloud such as Amazon RDS, what you would see is the database is often deployed onto a managed service, and you connect to that using external name service. And this is something that we have seen in our Kubernetes load balancer controller demo, ingress demo, and we have also seen this in Kubernetes services lecture. If you want to refresh your memory, I will also link those lectures here. So in this scenario as well, web tier will have one repo associated with it, and application tier will also have one repo associated with it. And the application resource of Argo CD, the custom resource that is called application, is the one that acts as a glue between that repository and your Kubernetes cluster. So with this understanding, I want you to know one thing. One Argo CD application maps to one independently deployable unit. So here that independent deployable unit becomes the repository of microservice 1, and that unit could be a microservice, it could be a web tier, and it could also be a monolith. Maybe you have an application 3 that does not use tiering, that does not use microservice, it's just a monolith. It's highly unlikely that you will see a monolith deployed onto Kubernetes, but there are always corner cases. In that scenario, for application 3, you will have a single repository. In that scenario, that application 3 repository becomes a deployable unit. Now that we understand this, let's come back here. So what is an application resource? Application resource defines a deployable application instance, and we'll be dealing with the exactly same YAML as we progress with this lecture. So let's understand what is happening here. So I want you to concentrate on two important things here. The first one is source and the second one is destination. Source is the place where you define the repository. Like we learned before, this repository could represent a microservice, a tier, or even a monolith. And then we have a destination. Destination is where you define the Kubernetes cluster where the deployment must take place. Now let's read this from top to bottom. API version argoproject.io /v1 alpha 1. Hello. Hi. You see how all of these things are connected, folks? The kind is application and the kind is application. That is why kubectl API resources, this one is my favorite commands. If you add -o wide, this will also give you the verbs supported by these CRDs, and they will help when you are creating RBAC and all of those things. So let's come back here and metadata. Here we are calling this application resource guest book. And if I move to the left, let me do one thing. Let me quickly bring these things to the right so that we can correlate while we are discussing these things. Okay, I'll again zoom in and then I will go back here so that we can see everything at one place. Here metadata, I'm calling it name guestbook, but here I'm calling it ms1 app. Here I'm calling it ms2 app. Here I am calling it ms3 app. So create this mental model in your head. Then I'm saying the namespace is Argo CD. Now this namespace is extremely important, folks, because whenever you create any of these resources, you create these in a namespace that you created for Argo CD. If you remember in the last lecture, when we deployed Argo CD, we deployed Argo CD related resources onto Argo CD namespace. So whatever custom resources associated with Argo CD you create must be created in Argo CD namespace. Again, understand the distinction. I am not saying you deploy your pods associated with microservice 1 or anything associated with microservice 1 in Argo CD namespace. No, I'm not talking about your application. I'm talking about the custom resources that gets created as part of Argo CD. They must belong to the Argo CD namespace. Since we are creating an application resource here, application resource that is part of Argo CD, that is why we are creating this into a namespace where we have deployed Argo CD. This namespace could have been named something else as well. Understand the foundations, not just what you see on screen. Then you have the spec section. Project is as of now default. You can onboard things into different projects, and as we progress, we'll see how that works. Source, very simple. You add your repository URL. Here you have target revision. For us, the target revision is head. What is head? Head points to the latest commit in the default branch for your repository, and we'll see what that default branch is. It is typically main or master. Let's see what is next. Next is path. The path is guestbook. Now why this path is important? It is via this path that I am telling that the manifests that you must be looking for exist in guestbook. So there is a root path. Root path is as soon as you go to your repository, that is the root. So if I go to my Chrome browser and then if I open Argo CD basics to production, so this is the root. Whatever you see here is part of the root. But if I am saying guestbook here, that implies there is a directory guestbook, and inside that guestbook is my manifest, are my manifests. So that is what we are conveying here. Now understand, like I said, if for example this application 1 was not using the recommended design of having 3 different repositories for these 3 microservices, and they would have created just one app 1 repository, in that scenario they would have 3 paths. For example, path for ms1, path for ms2, and path for ms3. In that scenario they would create 3 application resources associated with each of those paths. So create that mental picture right now as well. Any exceptions we'll be discussing as we progress with this course. Then we have the destination. As the name implies, here you supply the destination cluster, and this is what we have supplied because we wanted to deploy onto our kind cluster. Namespace is guestbook. We are saying that whatever resources you create, so whatever is inside this guestbook path, whatever manifests are there, you must be deploying those manifests into a namespace called guestbook. It is extremely simple if you have that mental model in your head. Now with this understanding, let's go and do the demo. So I will go to my browser. I will go to this 03 application CRD demo. I will scroll down. I will use my clickable table of contents to go to demo, deploy a simple application. Now, before you do that, ensure that Argo CD pods are running. So if I copy this and go to my command prompt, I'll clear this, I'll paste this command here, and you see all my Argo CD related pods are running. But you must also ensure that port forwarding is still running. So for me, I have closed the port forwarding that was running. So if I try to access my Argo CD in my browser, it won't work until and unless I use port forwarding. And we explained this command in the previous lecture itself, so I will not be explaining that again. So I'll paste this here, not here, sorry. I will paste this in this terminal so that I can work on that terminal freely. I'll paste this here, and if I go to my browser now, if I access localhost on port 8080, and let me just add HTTP because this is not TLS, and then I will proceed to localhost, and I have my Argo CD up and running and accessible via the UI because I am using port forwarding. So I will go back to my terminal, and here what I can simply do is I can go to Visual Studio Code now, and then here what I can do, I can create a new file, and let me call this file sample app, okay, dot YAML. So if I press enter, I can go to my browser and I will be using exactly the same YAML that you see in the previous section. So I will come here, I will paste this here. That this is essentially the same YAML that we just saw. And I have taken this example right from Argo CD's documentation, the official documentation. So what I will now do is, because I have Argo CD already installed, I have something that understands the kind application because I have installed Argo CD. I can go to my terminal and I will go to this screen, and if I do ls, I'm already in the directory where sample app YAML is located. So I will simply run kubectl apply -f sample app .yaml, and this says the guestbook application is created. Understand that we already have a namespace named Argo CD where all of the Argo CD related pods are running, as you can see here, -n Argo CD, all these pods, and we are creating this application in the same namespace. So what was the short name for applications? The short name was app or app. So if I now run kubectl get app-n argo cd, and this says sync status is out of sync and health status is missing. So let's go to the CLI. I will go to my browser. I will come here and I will hit refresh, and it says status missing and is out of sync. So you see we are in the applications tab, and here we see the guestbook application, and guestbook is the name of the application that we just created. It is saying this application is out of sync and health status is missing. So I would encourage you to go and check these things. So if I go here, guestbook UI, it was saying me that this is the manifest that it is using. But Varun, from where did this manifest come? So let's understand this a little. So I'll go here, and then let's go to applications, and here I will do one thing. I will just copy this URL. So okay, so whatever is here, let me just go to my Visual Studio Code. I will just copy this, and then let's see what is in this repository. So what we are saying is, in this repository, look for head, that is the latest commit in the default branch, and let's see what is the default branch. So if I click here, you see there is default written against master. So master is the default branch. If we write head here, it will point to the latest commit in the master branch. And if I go to guestbook, that is the path defined here, and that is this guestbook. This becomes the root, and guestbook is one directory inside. And here you see guestbook UI deployment and guestbook UI SVC. So if I see this, this is exactly the YAML that will be applied onto our cluster. And I want you to notice a few things. So I'll go here and let's open the deploy. And if I go here, here I see annotations, here I see namespace. Important thing, guys. And if I come here, there are no annotations and there is no namespace defined. What is the funda here? So annotations is something that Argo CD is adding, and we know from our Kubernetes learnings that annotations are something that is not directly used by Kubernetes itself. It is predominantly used for informational purposes, and this information that you give under annotation is consumed by external tools. And I also see a namespace. Why is this namespace here? This namespace guestbook was not there in my repository and my repository depicts the desired state. I have not defined the namespace to be part of the desired state. Then why is this namespace guestbook automatically added? This was added because while creating this manifest, the application manifest, you defined the destination as this cluster and then you said the namespace should be guestbook, which is why Argo CD has fetched these details from the repository and automatically added this namespace and the annotations part. And you will see this in the SVC YAML as well. So you have this annotation here and then the namespace is also guestbook. So this gives you one more flexibility. You can keep your manifest without namespaces, and in the application resource of Argo CD, you can define the namespaces where you want to deploy your application. This is extremely powerful because this will make your manifests platform agnostic. So because you are not specifying any namespace like dev, prod, or any application specific things, you can just specify these things here. So that's one thing that you should know. And then I will let you explore other things as well. So now it is out of sync. Let's click this sync button. I can use this sync button here, or I can just click here or here. It's your call. So I'll click here. It will give us a few options here. I don't want to go into these options right now. For now, I just want to say synchronize. And once I do, it says the sync has failed. So early for a failure. So let me click here and see what's going on. So I clicked here, I can click here, and it is saying namespace is guestbook not found, guestbook not found. So here we have defined that we want these resources to be created, but there is no namespace. So understand that Argo CD is not automatically creating a namespace for you. That is why I have kept it this way. So let's go to our terminal and let's run kubectl create ns, and the ns name should be guestbook. It's guestbook, right? Guestbook. I'll press enter. Now the namespace is created. I will go back to my browser, and here what I will do is sync again and with the same settings, and this time it should succeed, and it is. We love green hearts everywhere. So there are two things here I want you to understand. There is a heart and there is a tick mark. So the heart, or the healthy, this represents the app health and this represents the sync status. Now what do I mean by that? And to explain this, what I will do is I'll go to my diagrams. I would rather go to my GitHub notes directly, and here what I want to show you is, if I scroll at the very top in the demo itself, if I look at key Argo CD status concept, so I want to pay attention to these concepts. First is the sync status. It could be sync, that implies live state matches the git. So what you have running in your cluster matches what you have defined in your repository. So sync status indicates whether live state matches desired state. Out of sync simply signifies that what is there in the repository is not running in the cluster right now. Progressing is reconciliation is ongoing. And all of these are pretty self-explanatory, but I wanted to point these out. Health status, which is something that we saw here, app health. This is healthy, application running as expected. Degraded, application synced but unhealthy. Now what does that mean? So Argo CD is a tool that will ensure what is there in your Git repository, the desired state, matches what is running in the cluster. But if you have defined in your repository a wrong manifest, a wrong YAML, then Argo CD would care less. It will just apply those YAMLs onto your cluster, and it is your responsibility to ensure your manifests are working correctly, that when you apply those manifests, they will run properly, they will create the corresponding resources. That is your responsibility. So Argo CD is saying, I will give you sync status, and then I will also give you health status. Health status is for your application, whether your application is running or not. So if your pods are not in running state, your health status would be degraded. So understand these distinctions very clearly. There is the sync status, and then there is the health status of your app alone. And your sync status okay does not mean your health status is also okay. Now let's go back to the GUI and see what all things are happening here. And I would encourage you to click onto these resources and see what is going on. See, there is a pod, which is a wrapper of your containers. Then there is replica set, which is a wrapper of your pods. Then there is deployment, which is a wrapper of your replica set. And then we also created a service, which is here. Now what we want to do is we want to access our application. So let's go back to the terminal, and here I will run kubectl get pods -n, and the namespace is guestbook. And this will show me that there is one pod which is running. And why there is one pod? Because if I go to my repository and I go to my deployment manifest, this is what I have defined, which is why one replica is running. Now if I would have changed this, then there would be a drift, and then the Argo CD should be performing a sync. Right now the sync is manual. When I click on sync, it only syncs then. As we progress, we will see automated sync as well. Understand that this repository belongs to someone else. I can fork this and then perform these changes, but I do not want to do that. In the next lecture, we'll be having a private repository and then we'll be doing things. So let's go back to our terminal, and we see the pod is running. And if I check the service, I will see the service is also created, and this service is listening on port 80. So if I have to access this application, what I will have to do is I will again have to use port forwarding, but this time I will use this terminal which is there at the very last. I will run kubectl port forward. Sorry, I should spell it right. Port forward. And what I want to forward, there is a service. And what is the name of that service? Let's quickly see. The same name is guestbook UI. So I will write guestbook UI here, and then I should also add a namespace. Namespace is guestbook. And what I will do is on my host port 8081, because 8080 is already being used by Argo CD. So I will use 8081 here, and then whatever comes to 8081 on my host, forward that to the service guestbook UI on port 80, because our guestbook UI service is listening on port 80. So we'll press enter, and once we do that, the forwarding has started. So what I can now do is I can go to my browser. I can run localhost 8081, press enter, and our application is up and running. So this is not an interactive application. If I do this, I click on submit, nothing will happen, but you get the understanding. In the next lecture, we'll refine this further. Now let me see if I want to discuss something else. What I would encourage you to do is click on each of these, see what is the desired manifest, see the difference, see the live manifest, and it will tell you a lot of things. So just explore the UI. I cannot explore each and every item with you in this lecture itself. So I would again encourage you to, check details, check the logs, familiarize yourself with this. Having said that, as we progress with this course, we will be looking at a lot more things. So I think I've covered everything that I wanted to. So that's a wrap for this lecture. You should now have a clear understanding of how Kubernetes resources, CRDs, and controllers work, and why this foundation is essential before learning application CRDs. We then connected these concepts to Argo CD, understood what the application CRD represents, and saw how Argo CD uses it to reconcile Git state into the cluster. We also walked through a hands-on demo, creating our first application resource and observing Argo CD in action. In the next lecture, we will build this foundation by connecting Argo CD to private Git repositories and diving into few additional core concepts of Argo CD that are essential for real world usage. If you have any questions, feel free to ask them in the comment section. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi, and welcome to the fourth lecture in our Argo CD Basics to Production course. In this lecture, we focus on how Argo CD is actually used in production environments where almost everything is private by default. We will see how Argo CD connects to private Git repositories, how Kubernetes pulls images from private image registries, and how credentials and secrets fit into a GitOps model without breaking its core principles. Once that production setup is in place, we will extend the same demo to explore Argo CD's advanced sync features like automated sync, pruning, and self healing. We will understand not just how to enable these features, but why they exist, when to use them, and when not to. By the end of this lecture, you should have a clear end to end understanding of how Argo CD operates securely and predictably in real projects, not just demos. So let's get started. Now, if you are new to the channel, I would request you to subscribe. If you are watching this video and you see the hype button, then do hype this video. So let's get started. Firstly, if any one of you do not have Argo CD installed, then just go to lecture 2 and here in the GitHub notes, click here where we walk step by step on how to install Argo CD. Now, the prerequisite for this lecture is you understand the application CRD, which we discussed in lecture 3, and you have an Argo CD installation up and running. So if you have both of these things in place, then let's get started. So I'll go to my diagrams first. And in this lecture, we are straight away starting with a demo, because while we are doing this demo, we will be understanding the concepts as well. So let's see what are we going to do. And most of the things that you will see in this demo are production aligned. You will see real environments using exactly the same strategies that we intend to use in this demo. This demo has 11 steps, and I encourage you to do all these steps along with me. And once we have done these 11 steps, then we will be discussing advanced features such as automated sync, pruning, and self-healing. So let's discuss what we are going to do in this demo, which is called production style GitOps with Argo CD, from private source code to reconciled Kubernetes state. So in the step 1, we will be creating private Git repositories, and we know whenever we are dealing with the production implementations, public repos are not used until and unless you are working on some OSS project. Your application repos will be private, and that is exactly what we will be doing. We'll be creating 2 repos here. One app repo, which will hold the application code along with Docker files and other things. And then there will be a config repo. Config repo is the one that holds your Kubernetes manifests, and in actual environments, it will also hold your Terraform templates, your Ansible templates, and so on. In the second step, we will be generating GitHub personal access tokens. Why? Hello, you have a private repository. How do you access your private repository? Which is why we'll be creating a personal access token in second step. Step 3, prepare local project structure. I will walk you through all the YAMLs that we will be using in this course, and we will have 2 different directories. Here I have shown a Visual Studio Code icon because we'll be working there, and we'll be creating different directories for both of these repo. The contents in one directory will go to the app repo, the content in another directory. The second directory will go to the app config repository. In step 4, we will be creating a Docker Hub repo, a private Docker Hub repo. This is important. Your container images will be private. Not anyone can pull those images like we have done in our Kubernetes course or in our Jenkins course. What we have been doing is we have used Nginx image or Ubuntu image. These are public container images which anyone can pull. But your private images can only be pulled by authenticated and authorized tools or users. In step 5, we will be building the image and pushing that image to Docker Hub. In step 6, we will be creating a namespace because we know it is a best practice that all your application related configuration files or application related resources that gets created, they reside in their own namespace. Now there are different namespace strategies, but in this example what we will be doing is we'll be creating an app1 namespace where all our app1 related resources that are of course namespace scoped will reside. And we will also be creating a secret. Why a secret? I want you to know that when you have a private container image and you want your container runtime to pull that image, and we all know that it is the container runtime that pulls the image. So container runtime first must authenticate with the private image registry, and that is what this secret will allow us to do. In step 7, we will be creating Kubernetes manifest. We will be deploying a very simple app, but this simple app is extremely powerful. And why I'm saying powerful? Because you will get to see the entire process. We'll have a Docker file, we'll have a code. With that, we'll be creating a container image and we'll be pushing that container image onto a private image registry, and then we'll be using that image in our deployment manifest. And we will also create a cluster IP service. Why cluster IP service? Because we will be using the same method that we used for Argo CD, that is port forwarding, to access our Python based application. In step 8, we will be creating an Argo CD application, and we all know what is the purpose of Argo CD application. The application CRD in Argo CD is the one that marries the source and the destination. Source is your Git, which is your single source of truth or which has the desired state, and then the destination or the target is your Kubernetes cluster. Application CRD is the one that marries both of these so that Argo CD knows what is the live state and what is the desired state. Then there is step 9 where we will push code to Git. So understand, here we created private repositories and here we created the folder structure. And in the folder structure, we'll have Kubernetes manifest, we'll have application CRDs. Along with that, we will also have the actual code. So in step 9, we will be pushing everything to our GitHub repositories, to our GitHub private repositories. And then step 10, configure Argo CD repo access. Hello, you have a private repository for Argo CD for the application controller that we talked about here to know that the live state matches the desired state. We need to provide Argo CD with those credentials so that it can access our app config repo. Understand that Argo CD does not need access to your application repository. It only needs access to your application configuration repository, because that is the repository that holds your Kubernetes manifests. And as we have discussed in our past lectures, that it is best practice to create two different repositories, one repository for application code, and that will of course also hold your Docker file, Jenkins file, and other CI YAMLs, and then a separate repository that will hold your key manifests. And these manifests could be your Kubernetes manifests, your Ansible playbooks, it could be your Terraform templates, and so on. And in the final step, we'll be doing a synchronization, a manual synchronization, where we go to the GUI and press synchronize to verify that everything works as expected. And only after that, we'll be moving to advanced demos, where we'll discuss advanced features that are available at your disposal by Argo CD, so that your application deployment becomes true GitOps style. And again, step 1 through 5 can be categorized into artifact creation, which is essentially a pre-GitOps, and then all these steps that you see here are GitOps reconciliation. Argo CD controller is behaving here, is participating here. Now that we have this understanding, let's start this demo. So I'll straight away go to my browser. I am already in GitHub. I will scroll at the very top. I'll go to lecture 4 just in case we need to, see some files here, because I have all these steps, all these 11 steps are listed here with all the details, even the advanced demo thing. And if you have participated in any of my courses, you know that all the lectures come with detailed GitHub notes, which can help you with revision. Now I will just open this. I will go here and I will zoom in a little, and here I will go to repositories, and here I will click on new, and here first I will create my application 1 repository, and I will call this cloud with Varjosh app 1. That's it. And the next one we will call cloud with Varjosh -app1-config. So this repository will hold our code and the Docker file. And since we are not using any orchestrator like Jenkins or GitLab CI or GitHub Actions right now, we'll be doing these things, the CI steps we will be performing manually. So for now, this will not hold any Jenkins file or any CI YAML files. This will just hold the application code plus the Docker file. So I will scroll down here. From public, I'll change this to private, and in the description I can add app1 application code. That's it. I'll click on create repository. After that, I will again go here. I will go to repositories, and then here I will again click on new, and this time I will call it cloud with Varjosh and then app1, and this time I want to name it app1 config. Once I have done this, I will change this to private, because we know private repositories must be used in production implementations. Once I'm done with this, I will go and create a personal access token like we discussed here. So step 1 we have done. Now we are in step 2. We will be creating a personal access token. So I'll go here. I will go to settings here, and then I will scroll down, developer settings. Then I will go to personal access tokens, fine-grained tokens this time. Generate new token. I will use my passkey. It is asking me to provide my ID. I'll do that. This is done. And now I am here. So I'll call this Argo demo. Yeah. Argo CD demo. Let's be a little complete. And description, Argo CD to GitHub. Now understand, what I am doing right now is I'm only creating one personal access token, and that one personal access token will be used by 3 entities. Now why 3 entities? First is your developer. Your developer is pushing the application code. Second is your DevOps engineer. Your DevOps engineer is pushing the code onto the app1 config repo. Then third is Argo CD itself. Now, Argo CD will be requiring access to check what is there in the repository so that it can ensure the desired and the live state or the current state or the running state matches. So idea is Argo CD just requires read access because it will just be reading our repository or cloning our repository. And then when I talk about our developers and our DevOps engineers, they would need a read write access because they will be pushing code, correct? Now, the resource owner, I will leave it to Cloud with Varjosh. In this lecture, I will be using a single personal access tokens for all these three entities. But as we progress to advanced demos, we'll see what are the different ways that we can leverage. Expiration can be 7 days, that's okay. Repository access, now here is the critical piece. With this new generation tokens, with fine-grained tokens, what you can do is you can only select the repositories to which the access will be granted. So I will click on here and then it is asking me to select the repositories, and you know we have two repositories. First is this one, that is app1 app code. Second one, I have not given any description. So this will be Cloud with Varjosh app1 config, Cloud with Varjosh app1. So I have selected these repositories. I'll click here now. Now here comes the interesting part. In the permissions section, I will click on add permissions. And then here I have to search for contents. And once I click on content, here is the key part. See, it is asking what will be the scope of this token. Right now, it is read only. So if we keep this read only, then we know that developers and DevOps won't be able to push code, right? So here we'll be choosing read and write. But I also want you to know that for Argo CD, you must provide read credentials. As I told you before, as we progress, we will be doing different things, we'll be seeing different authentication mechanisms, but I want to plant this thought in your head right now that Argo CD just needs read access and we must adhere to principle of least privilege. So this becomes extremely important, and it is not just personal access tokens that you could be using. There are SSH keys as well. And there is another concept called deploy keys. And as we progress, we'll be discussing those things too. So do not worry. At this stage, we are learning to walk, not to run. So I'll click on generate token here. And this will generate a token for me. It is just asking me to reconfirm that two permissions for two repositories. We are good. I'll click on generate token. So this will only be shown to you once. So copy this, and what I will do is I'll go to Visual Studio Code, and here in 4 itself, I'll create a new file and call this creds, because we'll be generating this token for Docker Hub as well. I want these things to be at one place. So I'll paste this here. Now step 2 is done. Let's see what is step 3. Step 3 is prepare local project structure. So I want to give you a walkthrough of what we have with us. So I have created 2 directories, and these 2 directories you will also find in your GitHub repository. In the GitHub repository for this course, you see app1 code and app1 config. So I would encourage you to clone this right now and practice these things with me. Do not park this for later. If you are watching the video, it will maybe take 2 hours, but if you are practicing along, it may take 3 hours. But if you practice at a later stage, and if you do not practice at all, that is not good, folks, because just watching is good for nothing. Trust me, it is video overload and you will not be learning anything until you do with me. So let's go back here and let's see what the project structure looks like. So I have app1 code here. This is holding my code. So let's see what we are doing. it's a simple Python application. We are using the Flask framework, and this application just says Argo CD basics to production, GitOps managed Flask application deployed to Kubernetes via Argo CD. And I have configured my application to listen on port 5000, which is important because we will be accessing our application on port 5000 and we'll be using port forwarding. So we'll see how that works. And then I have a requirements.txt, and with Python you would often see this file, and this will have all the packages that are required by your application. So for my application, for my Python application, I only need Flask, which is why I just have an entry of Flask along with the version. And then is the main part. So we have seen app.py, we have seen requirements.txt. Now let's see what is here. So this is your Docker file. This is something that will connect everything. We are saying the base image is Python 3.11 slim. Working directory is /app, which applies all the subsequent commands. Wherever they run, they will be running in this path, or whatever you run will be running in this path. Then I'm saying copy requirement.txt to this. This implies copy it to /app. Then I'm saying pip install no cache dir, because I don't want the cache to be stored on my container image, because I know that will increase the size of my container image. Then I'm saying whatever you want to install is there in requirements.txt. Pip is Python's package manager. And then you have copy. We are saying copy this code app.py onto /app. Expose is just for documentation, so that DevOps engineers like me, when watch this Docker file, immediately know that this Docker file, the container image that will result from this Docker file, or the application that will result from this Docker file, will be listening on port 5000. And at the very last, I am running my Python application by saying Python app.py. As simple as that. And then I have my app1 config. So I will not give you a walkthrough of these YAMLs right now. Just understand this. Whatever is in app1 code will be pushed to the code repository, and whatever is there in app1 config will be pushed to the config repository. And this is important concept to grab, folks. If you have not watched previous lectures, then do watch it. But if you have that understanding already, then you can continue along with me. So I'll go back here and see what I want to discuss next. Step 4 is create private Docker Hub repo. Now understand what we will be doing in this lecture is we will be using a private image registry. So let's do one thing. Let's create a repo first in Docker, and in that repo we'll be adding our images. So let's go there. Now I hope everyone understands that a repo is a collection of similar type of images. So let's go there so that I can explain you properly. So I am already in my Docker Hub account. I have logged in, and you see here, if I talk about Cloud with Varjosh DevSecOps-demo, this is a repository, which is why it is listed under this repositories. And if I go to this repositories, I will find multiple container images with tag latest 58, 57, 56, 55, and so on. If I had a single tag, let's say, then I would say my repository has just a single image, because image is a combination of a repository and a tag. That is why we call this container image, which is why if you see a Kubernetes manifest like this one here, this one, I'll just open a deployment manifest, you have an image section. So image is repository, which is this one, Cloud with Varjosh-app1, and then tag is this one, v1.0.0. So with that understanding, let's go back to our browser, and here in the repositories section, I will click on create repository. And I'm already creating a repository because this is where I will be pushing my container image. And why I'm calling that a container image, because that will have the repo name along with the tag. So I will call this cloud with Varjosh app1. As simple as that. Another thing we want to do is we want to make this private. So I will click on create now, and this will create this. Understand, we have a repository, but this repository does not have any images right now. So I will click on this sign here, because what we are going to do now is we are creating a Docker Hub token, because that token will be used by my container runtime to pull the container images. So I'll click here, account settings, and then from here I will go to security, I think here, personal access token, sorry. So you go here, and then I'll click on generate new token. This token can be called Argo CD demo, like we have done for our GitHub personal access token. Expiration, let's keep it to 30 days. And then optional, public repo read only access, read and write access, read, write, delete access. Understand, we'll be using this token to just pull images. Container runtime will be using this token to pull images. We are not using this token to push the images. Have that clear distinction in your head, folks, because that is where engineers are separated. So keep that distinction in mind. So when I am pushing this image, I will be using my Docker Hub credentials, as in my password, because I'll be pushing those from my host itself, from my laptop itself, and my laptop has Docker desktop installed. So if I go here, I go to Docker desktop, my Docker desktop, I have already logged in via cloud with Varjosh account with my password. So when I create an image and I push that image, which we will be doing in step number 5, we will be pushing using these credentials, not this token. This token is only for my container runtime to pull images, which is why I will close this one. And then I will go here to my browser and I will give read only access, and then I will generate this token. Again, this will also be shown once to you. So keep that in mind. So we will not be using this step. Do not worry. We'll be embedding this token in our secrets YAML, and we'll see how that works. Okay. I'll copy this one. I'll go to Visual Studio Code. I will paste this token here. So let's go to our draw.io and see what is our next step. So till step 4, we are good. We have created a private repo. We have also created a token as part of this. And then step 5 is we are building and pushing image. Now we are building and pushing image. I want you to know that here is the directory where we'll be dealing with, because this directory has our Docker file. So I will go to my terminal. I will go here in this tab. I'll press ls. So I know my application code is in app1-code. I will cd app1 code, press ls. This is where I have my Docker file. Simple Docker build command. So Docker build -t. I will call this cloud with Varjosh. That's my account name. And then I could have added docker.io as well, but we all know that that is automatically added. So I'll have cloud with Varjosh, and what did we call? app1, right? This is the repo name that we gave there. So now if we are creating an image, I also want to give this a tag. So I will tag this v1.0.0 because this is version 1 for my application. v1, this 1 implies the major version, minor version, and this is the build or patch release. So 1 is the major version here. So I will then provide dot, that implies that whatever is needed to build this container image is available in the current directory, that is Docker file resides here. Requirements.txt is needed, which also resides here. App.py will also be needed because this has our code. So understand, all these three files are required because in this Docker file we are calling these things somewhere. App.py is called here because we are copying this, and then requirements.txt is called here. So our build context, which is denoted by dot, will be using all of these things. I'll press enter and this will build my image. Now I will run docker push. I will be pushing this image, and from here what I'll do is I'll just copy this so that there are no errors. I'll paste this here. Now understand, I have already logged in into Docker desktop, so it will not ask me for any credentials. But if you are not using Docker desktop, you are using Ubuntu VM where you have installed, let's say, Docker engine, then in that scenario you will have to first run Docker login. If you are using Docker desktop and your Docker desktop has already logged you in, like my Docker desktop instance here, then you are good to go. So I will press enter here and this has started pushing my image. So once this image is pushed, I should be able to see this image. If I go to my browser, I'll go to my Docker hub here, and then if I click on refresh, then it has not yet come. Let's allow it some time. It's still pushing. Okay, let it push completely and then it should be there. Okay, it has pushed. So if I go to my browser, I hit refresh and I see that image is here. Now let's see what is our next step. So let's go here. Next step is create namespace and secret. And I told you before, most of these things that we are doing, building the image, pushing the image, these things are automated using a CI like Jenkins, and we will be doing that later in this course. But first I want to give you a thorough understanding how things work manually and slowly progress. So let's see what is in step 6. Create namespace and secret. So namespace, you all know that we'll be creating namespace so that our application resources can live here. So what I will do is I will run kubectl create ns and I will call this namespace app1ns, and this says that your namespace is created. Now what I want to do is I want to create a Kubernetes secret. Now that secret will be used by what? It will be used by my container runtime to pull container image that we have just pushed, but that information we'll be calling via our deployment YAML and we'll be seeing that. So first let's create a secret. Now what I will do is I will go to my GitHub repository and then I will go to step 6 here because I don't want to type that command manually right now. So this is the command. I will copy this command and here I will paste this command. Now let's understand what we are doing in this command. First is kubectl create secret, that is fine. And then we are creating a secret of type Docker registry. Now do not confuse this to be restricted to Docker hub only. This is registry agnostic. Even if you are creating this secret for Amazon ECR, for GitHub container registry, or any other image registry, you would still be using this secret type. This is the type of the secret. This is not the name of the secret. So if you, for example, run kubectl create secret and then you write -h, this will give you 3 options. And Docker registry is one of those options. It says create a secret for use with Docker registry. Now Docker registry, as we all know why this is called Docker, because Docker was the first one to introduce this containerization concept, at least from a containerization perspective, which is why Docker registry stayed here. But they should have now called this image registry, not Docker registry, and not Docker registry, image registry. So understand this nuanced difference. Okay, I want you to understand whatever you are doing. Do not just run commands blindly. Now if I again, let's do one thing. I'll go to Visual Studio Code and there I will explain you that command. That will be better. I'll paste this here. So we are saying Docker Hub create secret Docker registry. We are calling this secret Docker Hub secret. So Docker Hub secret is the one that we will be calling in our deployment manifest. Docker server is this. Now this server will change for different image registries. For Docker Hub, with which we are dealing with right now, because our container image is stored in Docker Hub, which is why we are using this. Docker Hub username self-explanatory. I'll have my name here. My name is Cloud with Varjosh in my Docker Hub, and then Docker password. Now this is the piece where you will be pasting this. So I'll come here and then I will paste this here. Then Docker email is this, and create this secret in app1 namespace. Now I'll run this command and I'll tell you a few more concepts while we are working with this. So I'll paste this here and I will press enter. So this says your secret is created. Firstly, this is not something that everyone should have access to, and I'll tell you why. Okay, if I run kubectl get secret -n app1 ns, and then I will name that secret, it's Docker Hub secret, and then if I write -o YAML, then I see that secret here. So if I copy this, okay, and then if I run echo -n and I paste this here, and then I pipe this, and then I write base 64 decode here, and I press enter, you see it has spit the actual token to me, which is not good, right? Now there are two learnings I want you to take away from this. First, this get access, kubectl get secret, this access should not be given. Firstly, anyone who is creating a deployment using this secret, Docker Hub secret, does not require access to secrets themselves. So you do not have to give that user who is allowed to create deployments to also have secret access. You don't have to do that. They are two different things. Even if you are calling this secret in a deployment YAML, anyone who is creating that deployment will just need access to create deployment, not to get or create any secret. So keep that thing in mind, because it is the container runtime, that is, let's say, the Kubernetes engine, that is supposed to use these credentials, not the deployment itself in general, because anyone who has access to this can grab your token and you may not want that thing. That's first thing. Second is, but Varun, firstly, you created this secret imperatively. So this token is anyway here. And Varun, this is not true GitOps. You are doing things manually. You are creating this secret manually here. And again, you cannot, let's say, even if you create a YAML for the secret, you will not be version controlling this, because your credentials should never be version controlled. Now, even if your repository is private, your credentials should never be version controlled. So having this is not good. But Varun, what is the way forward then? How do I create my secrets declaratively? Because right now we created a secret imperatively and we saw what are the hazards for this. Firstly, you have your token visible here. Anyone, let's say if your CI system like Jenkins is creating this, then of course there are means to, redact these things, but in general, they are still available. So what is the correct way to do? First is, see, there are level of securities. Okay, so I'll talk in priority. So first is, you use your Docker Hub, username and password. That is the beginner mistake. So you learned creating secrets that way. So instead of this token, you have your Docker password. So don't do that. Second level is using this personal access token. Then third level is use an external secrets manager. Now what that would do is, your secret will be kept in, let's say, HashiCorp Vault or AWS's secret manager, and then your manifests will be calling that secret from there, and that will be fetched during runtime. So if possible, use in production, always use HashiCorp Vault or AWS Secrets Manager or any other security solution to hold your secrets information. Next thing I want to talk about is if you are on cloud, let's say if I am on AWS, then of course what I can do is I can have IAM roles associated with my Argo CD instance or my Kubernetes nodes who can fetch the information from AWS ECR. If you are hosting your images in AWS ECR, and we saw this in DevSecOps mega demo, IAM roles under the hood to authenticate to Amazon ECR. And that is the best way. In that scenario, do not use AWS's Secrets Manager or HashiCorp Vault. But if those things are not available, then of course, using external secrets are highly recommended. And when you do these things, you already have an operator for most of these tools like HashiCorp Vault, which will ease your job of deploying these solutions. So I will leave this here because this is not a security lecture or a lecture where we are discussing HashiCorp Vault in detail. But at this stage itself, I wanted to plant these concepts in your head so that you know where in the hierarchy your GitOps maturity or your project maturity falls. So for now, we have created this secret and we have studied what are the security considerations. So two things. First is RBAC. Do not get access to this secret because whoever has that access can fetch this token and it is not good. You should adhere to principle of least privilege. And then second is your secrets should not be created imperatively. You should have declarative means to create these secrets. And you should be using external secrets using things like HashiCorp Vault, AWS's Secrets Manager, and or if you are wholly solely on cloud, then you should use something like IAM roles. Azure and Google also have something similar. Now let's see what we want to discuss next. And step 7 is where we want to go now. Step 7 is define Kubernetes manifest. So let's go to Visual Studio Code. And here is my app1 deploy.yaml. You see, this is a regular deployment manifest, extremely simple. What I want you to concentrate on is image pull secret. And here is where I am calling Docker Hub secret that I just created. Image is cloud with Varjosh. This is the image that we just pushed. And we are saying the port on which our application listens on is 5000. And then these are regular things, match labels, selectors. I will not be discussing these because I am working under the assumption you already know Kubernetes because you are working on Argo CD right now. And then I have app1 SVC. App1 SVC is the one via which we will be configuring port forwarding. And here the selector is app is equal to app1, which is why it will be dealing with all the pods that will be created with the labels app is equal to app1. So this thing is understood. And here the key thing is we are only created one replica. This is important for you to know because we'll be referencing this as we progress. Now let's go to a draw.io and see what is the next step. Step 8 is create Argo CD application, and let's do that. So I'll go to Visual Studio Code. I already have this app1 app CRD. This is exactly the CRD that we have used before. Okay, we have used this in the previous lecture, but here, so let me just give you a quick walkthrough. Namespace is Argo CD. We all know that Argo CD related resources, that is your application CRD. If I go to my terminal and I run kubectl API resources and then here I grep for Argo, then you see ApplicationSet and AppProject. These three resources, whenever you create these will be part of the namespace Argo CD. Any exceptions, we'll call that out separately. Then in the spec section, project is right now default, which is fine. And then we are defining the source and the destination. This is important. So source, I'm saying you go to So I'll go here and let me just show this to you in a refined way. I'll go to home. I'll see all the repositories. I want to show you this one, app1 config. So if I go here, I want this repo. I'll copy this entire URL. I will go here and then I want to paste this here. What I'm saying, whatever code is there, that code that manifests, app1 deploy or app1 svc will be available in this repository. And we know Argo CD must only deal with the repository that has config repos. It does not require access to your repositories where your code is located. Target revision is head we know will point to the latest commit on the default branch, and the default branch in our scenario will be main. Path is just dot. So previously we saw that we had guest book here when we were looking at the sample Argo CD demo. Right now we are saying path is dot. Dot implies whatever files you are looking for will be there in the root of the repository. Root of the repository is as soon as you go there, whatever you see is the root of your repository. So if I go here, Argo CD basics to production, if I click on this, whatever things are here, these are part of the root of the repository. So similarly, we are saying at the root, destination is, this is my Kubernetes cluster, and I am specifically specifying deploy whatever is in this repository in app1 namespace. Now this is powerful. If you see these manifests, I have not added the namespace field here, but when these manifests are applied, they will be applied onto app1 namespace itself. So app1 svc also does not have any namespace. I'm not defining namespace in my manifest, but I would encourage you to define everywhere. I wanted to show you this, which is why I have not defined here. But in app CRD, I have categorically said that whatever you deploy should be deployed in app1 namespace. Now that we have this understanding, let's do one thing. Let's apply this application manifest. So I will hit cd ... to come one step back. I will cd into app1 config, and then I'll clear my screen, press ls, and I will run kubectl apply -f app1 crd app1 appcrd.yaml. I'll press enter, and this says application this is created, app1 is created. So if I now go to Argo CD, and let me just open that, localhost 8080, and I press enter, I go to advanced, and then I proceed to localhost. Now this is working because if I go to my command prompt, I am port forwarding here. So you should also be running this command before accessing the UI. The UI will only be accessible if you are doing some sort of, this combination. So I will go here. So if I click here, you see there is one error. And if I go here, it says fail to load target state, fail to generate manifest. This password authentication is not supported for Git operation. So we have not supplied any credentials yet. So let's fix this. But before we fix this, let's first push our code so that when it deploys something, we know it is deployed there. So when it checks our repository, it should know that these are the manifest. Let's deploy them. So first, let's push our code. So what I'll do is I'll go to first draw.io here. So we have done this. Now we have to push code to Git. So I will go here in the terminal. I'll go to this terminal, and we have to push both the code. So the code for application need not to be pushed right now because we have already done what was supposed to be done, but we will do that for the sake of completeness. So I am in app1 config. So let's do this step by step. I'll go back, and then I'll first go into cd into code repository. So I'll go here to the code directory, and whatever is here, I want this pushed to my app code repository. So I will write git init first, and then I will run git add. Git add will move anything in my working directory to the staging area. And once this is done, I will run git commit -m, and here I can write initial commit with code. I'll close this and then I will press enter, and here I will write git branch. So this actually, if I run git branch -v, then you would see this is called master by default and GitHub calls it main by default. So what, I don't want that mismatch, so I'll call this main itself. So I'll run git branch -m main, and if I run that again, my branch is renamed to main, which is what I wanted. And now I will run git remote add origin. Now origin is something that I am calling it. You can call this anything. Don't think that origin is the only name that you can give to your remote. So what we are defining here is, we are saying git remote add origin. So the remote that you want to connect to is called origin. And then what is the URL for that origin? So what I will do is, I'll go to my browser, and here I want to deal with not app1 config. So let's copy this. I'll just remove config from the name and that will be fine. So I'll come here, I'll paste that here, and then here I will just remove config, because we are dealing with app1 code directory here, and we want whatever we have here to be there in the cloud with varjosh -app1.get. So I'll press enter, and this has done its job. But now is the critical piece. Now we have to push it, but for pushing we also need to supply credentials. So what I'll do is, I'll come to Visual Studio Code, I will go to creds, and then I will paste a command here, and these commands are already there in my GitHub notes, so you can go and watch those commands. So here our repository is just app1 git remote set URL origin is this. Why we are doing this? We have to supply credentials so that we can push to a private repository. Right now you won't be able to push if you do not provide any sort of authentication. So I'll copy this, and we'll be zooming in into this at a later section as well in this lecture itself, because I want to clear a few more concepts. So I'll copy this here, and then I will go to my terminal, and here I will paste this. I'll press enter. Now if I run git push, I want to push main to the origin, and origin is the name of my remote. So I'm saying whatever is there in my main branch, push it to origin. And what is origin? This is my origin I have defined here. I'll press enter, and this will do the push. So if I go to my browser here, and then I open cloud with varjosh here, and then I come here and I click on show more, and if I go to just app1 here, and I'll move app1 at the front, and then here you see whatever we have done, it was committed here, was pushed here 3 minutes ago. So we are good. Now I want to do the same for my other repository. So I'll go to my terminal, and then I'll clear my screen for some clarity, and then I'll come one step back. I will cd into app1. This time I want to go to config, and then if I press ls, you see all my YAMLs here. Understand that your application config repository is also holding application CRD. This is important thing to know. We are also version controlling app CRD. So I will write git init, and then I will write git add dot git branch -m uppercase M main, and then I will write git commit -m initial commit in config repo. I'll just write this. Okay, I'll press enter, and here again we'll have to run the same commands here. So first I will run the command that I copied that time. I'll paste it here, and this time this should be not app1 repo. This should not be just cloud with varjosh app1. This should be app1, and here I should have config, right? Let me just quickly verify. Yeah, app1 config. And that is what I have here. I'll press enter, and then I will have to run the same command again. Now, this is the distinction I wanted to tell you. Now, since we are acting as both developers, DevOps engineers, and also Argo CD, we are doing all of these things. But in essence, your developer would be different. They will have a different token. You will have a different token, and so on. So I hope that distinction you are able to make in your head, because that's important, right? And here I will have just config, and here this origin is fine, and this should just work. I'll copy this. I will go to my terminal. I'll paste it here. I will then write git push origin main, and this will push my code. So if I go to my browser now and I refresh this, you see all our YAMLs are now version controlled, which is how it should be. Now let's see what we want to do next. So if I go to draw.io, we have the 10th step. Configure Argo CD repo access. Now this is important. So firstly, let me go to my browser, and if I go to repository for this lecture, I will go to lecture 4, and then we are in step 10, right? So I'll go here. So if you do not have Argo CD CLI installed, yes, there is a CLI for Argo CD. You do not have to master it right away. It is very intuitive. As we progress with this lecture or with this course, you will see how it can be used. So for now, we will be using Argo CD CLI to add the repository and give it credentials. So right now we will be using Argo CD CLI to supply the authentication information. So just go to this link and install Argo CD CLI for your operating system. And once done, you can come to your terminal, and if you run Argo CD version, it will tell you that version, Argo CD version. Okay, just version. Sorry. Argo CD version. This will tell you the version for this. Now, what I also want to do is, see, you could be dealing with multiple Kubernetes clusters, and each of those clusters can have different Argo CD instances, or you could just have one Argo CD instance that is managing multiple Kubernetes clusters. Both the scenarios are possible, but understand, Argo CD client, Argo CD CLI is installed in my Mac right now, but I have to tell my Mac which Argo CD instance you need to connect to, right? Hello, we have to do that. So in this step, we'll be doing that. So I'm saying Argo CD, and now I'll be saying login. Login to what, my friend? Login to localhost 8080. And before you run this, ensure that your port forwarding is working correctly and Argo UI is accessible like it is for me. Okay, I'll go here, I'll press enter, and this says server certificate had error. We know we are using HTTP, so I'll press yes, and it is asking for a username. I'll add my username, and we created this when we were installing Argo CD, and then I will enter the password for it. And once I do that, it says admin login logged in successfully, context localhost 8080, and we'll learn more about context in a little while. So like I said, you can have multiple clusters where in which context you want to learn run these commands. So that is what context decides, similar to Kubernetes context, right? So now that we are connected, so let's run this command. So I'll copy a command and I'll tell you how simple it is. Okay, so I'll go to Visual Studio Code again, and here I will paste that command. Very simple command. Argo CD repo add, give the repo URL, name it or not name it, it's your wish, provide a username, and then provide a password. So if I come here, if I come to my CLI, if I run Argo CD repo, if I hit -h, it will tell me all the options along with examples what I can do. So the help is very intuitive. I would encourage you to use it. Argo CD repo list to list all the repos that you have added. Now, which repo you will add? You will add the repos that you are using, my friend. We are using this repo. So I will be adding details for this repo, and which is exactly what I'm doing here. I'm adding this repo, the credentials for this repo. This is the username Argo CD and this is the password Argo CD. So we are telling this to Argo CD that this is the username and this is the password. So for password, I will copy my GitHub personal access token. So I'll copy this one and I will paste it here. And then I will, hold on. Then I will copy this entire command and I'll come here to my terminal and I'll paste this. And this says repository this added. Now you could have done this via UI as well, but I wanted to show you how to do this via CLI. So if I go to my browser and then if I go to settings here and then I go to repositories, you see whatever we created is here. And you could have created this from here as well. Connect repo, you would have provided the details. Now if you were using SSH keys, you could have also provided that, and you could have done this via the UI as well. I'll cancel this right now, but for now our repository is added and the connection status is also successful. So if I go to applications now, if I click on this, there is one error. Then let's refresh this so that it checks with the repository again. Now here is the magic. See, by default, Argo CD checks with the repository approximately every 3 minutes. Okay. Now what refresh will do is refresh will tell it to check the status immediately right now. So when I clicked on refresh, it checked immediately and it detected that currently the cluster does not have any of these, which is why you see this yellow mark here. Now again, like I said in the previous lecture, you go to these things and explore. You see it has added an annotation automatically and it has also added the namespace. So that is what Argo CD does for you. Automatically an annotation is added so that Argo CD knows that this is a manifest or this is the resource in the cluster that is managed by me. So this is for Argo CD's reference, and namespace app1ns was not there in our manifest. So if I go to this, if I go to app1 svc, let's say, you do not see any namespace mentioned here, but namespace was added because the application CRD we created had defined app1ns, which is why Argo CD shows this here. Explore all of these manifests for now. Now I want to discuss one more thing. So we have talked about access tokens a lot, and I want to give you a clear picture on what to use when. So when I talk about developers or your DevOps engineers, you would be using a personal access token or SSH keys, and both of these will be associated with your user. So for example, when I created a personal access token, that personal access token was associated with cloud with Varjosh. That credentials, that token was associated with Varun Joshi. So for developers and DevOps engineers, you want that because I should know which developer committed something, because this will be good for auditability as well. When users are doing things, I want to know which user did that, which is why I will use personal access tokens or I will use SSH keys. But when I talk about a GitOps tool like Argo CD, you use something called deploy keys. Now, why deploy keys are so important? Deploy keys give access only to a specific repository. So they have one-to-one relationship with a repository, which is why it is recommended to always use deploy key. So for example, if Argo CD is managing 10 applications for me, and we are working on the assumption each application has its own repository, then you will be creating 10 deploy keys, one deploy key for each of your application, and then you will be adding 10 different repositories here in this setting. So you will have 10 different repositories because you are dealing with 10 different repositories which have 10 different deploy keys, and we'll see deploy keys later. But what about CI systems? CI systems like Jenkins, what would they use? They can use something called GitHub app, or they could also use deploy keys, because deploy keys are specific to a repository that gives fine grained access. Now someone is thinking, but Varun, what I can do is I can create a user that is specifically for GitOps, and I can call it GitOps bot, and GitOps bot can have personal access token associated with it, and I can do this. Of course you can, and you will see some projects that are using this sort of architecture. But again, the difference is nuanced. The difference is when you do that, you are tying that token to a user identity. Even though you are calling it GitOps bot, but it is a user. But when you are dealing with deploy keys, you are associating them with repositories themselves. So that is something we'll see later in this course, but I wanted to plant this in your head right now itself. Now let's do the fun part. Let's go to repositories, go to applications, and run sync. So I'll go here and I'll press sync, and it is asking me what to synchronize. I want to synchronize everything. So I'll click on synchronize here, and I will click on this application, and you see all our resources are deployed, and you can have different views for them. You can use this view, you can use this view, you can use this view, but I like this one. Now if I go to my terminal, if I run kubectl get pods -n app1ns, you see 25 seconds back this pod was created. I want you to have one clear distinction. Even though Argo CD was not syncing until and unless we clicked on sync, it was checking with our repository that whether what is there in the desired state matches the current state, which is why you are seeing out of sync here. Folks, understand these nuances because these are extremely important. You should know why the status was out of sync. It was out of sync because Argo CD was already checking with your GitHub repo. But when we clicked on synchronize, it only then synchronized. That part is clear. Now we have successfully deployed an application using Argo CD, and now I want to discuss the advanced concepts that I promise you that we are supposed to discuss. But before we do so, I want to explain one more thing. This has a refresh, and then there is also a hard refresh. So if you click on refresh, that would be a general refresh. But if you click on this arrow and then click on hard refresh is, see, normal refresh is you recheck git and the cluster state. But hard refresh says forget everything that you know. Even if you have cached something, you recalculate everything. So use this based on whatever is your requirement. So with that said, let's discuss the advanced features. I'll come here and then I'll scroll down. Argo CD sync governance feature. How Git drives automation, cleanup, and drift correction in production clusters. So first, let's discuss automated sync. And this one is pretty self-obvious. Up until now, we have been clicking the synchronize button to synchronize our cluster based on the desired state. But what if you want to do that automatically? That is something we'll be discussing in this part. So purpose is automatically apply approved Git changes without requiring manual synchronization. What it controls: speed and consistency of applying Git defined desired state. Now, if you know for sure that the Git will always have the desired state, then why not have automated sync enabled, so that whatever is there in your Git gets deployed onto your cluster automatically. And again, I want you to understand that we are not just talking about new resources, we are also talking about any changes that you do to a resource. For example, maybe in a deployment manifest you changed the replica from 1 to 2. In that scenario as well, automated sync should come into picture and should be creating one more replica for you, and that architecture is supported. Default is disabled because we have been using manual synchronization up until now. Best suited for stable GitOps workflows with strong pull request governance. That is understandable. Your Git must have the correct state. Your Git must be the source of truth for this to be applicable for your project implementation. Now, if your Git access is not governed, or if there is no PR process in place, as in the Git discipline is not adhered to, then this feature will not make sense to you. So let's see what is going on. Let's come to Visual Studio Code. I'll come here. What we are saying is, if there is a change, let's say, let's change this to, if I go to Git right now, then if I come here, app config, deploy, replica count is 1, correct? And that is the reason currently I am running 1 replica, right? Now let's do one thing. Let's change this replica count to 2. Now I can do it from the GUI as well, but that is not how production clusters work. Production Git repos work. So what you would essentially be doing is, you will be first making the change here, app deploy.yaml. You will changing it from 1 to 2. You will be saving this. And then if I go to my terminal and I am already in the config repo, if I run git status, we will know that this file has changed. Now, if this has changed, what we will do is we'll run git add here dot, and then we'll write git commit, and we'll have a good message: changed replica count from 1 to 2. And then we'll close this, then this, and then I will write git push origin. But will this work directly? No, it will not work. Why it won't work? Because I have not changed anything in Argo CD. For this to work, I must change the application CRD manifest as well. So let's do that. So I'll come here again. I'll just cancel this one, and then I will go to Visual Studio Code. I will go to our app1 app CRD, and here what I will do is, in the spec section itself, I will have one more section, and that section will be sync policy. And then I will have that. I'll click this, and then I will have automated here, and then I'll just have this. And later we will enhance this further. So for now, it is saying your sync policy when it comes to automated sync is enabled. So doing just this makes that work. Now, if I save this and I go to my terminal and I run kubectl apply -f, and here what is my YAML? My YAML name is app1 app CRD. So app1 app crd.yaml. I press enter and this says configured. Now I want you to notice one thing. If I go here to my Visual Studio Code, if I go here to my browser and then I go to Argo CD UI, I click on details for app1 and I scroll down. enable auto sync is checked. It was not checked previously. It is checked because I reconfigured my application CRD. So just close this, and now our cluster is automatically syncing from the Git repository. So what I will do is I'll go to my terminal, and now I will push the changes. So once I push the changes, and the change is I've changed the replica count from 1 to 2. So once I push this, Argo CD will detect it, and then it will create one more replica. So that is what we want to see. So I'll come here. I will then run commit. We have already done. So let's run git push. Let me run that again, because understand, if I check git status, it will say that you have also modified this. So let's run that again. Git add dot git commit hyphen m changed replica count and argo cd app crd, and then I will press enter, and then I will write git push origin main. I'll press enter. So this has pushed the code. Now if I go to Argo CD now, it will check every 3 minutes, we know, but if I click on refresh, it will start checking right now. And notice this pod. Okay, see how quick that was. It has created one additional pod for you. And if I go to my terminal, and if I run kubectl get pods -n app1ns, you would see one pod was created 15 seconds back. So this is the beauty of automated sync. So whatever changes it sees in the Git repository, it will quickly replicate those onto your cluster. Again, this timer is 3 minutes approximately, and if you click refresh, it will immediately check and then apply the changes. Now this thing is fine. We have 2 replicas running. Now let's discuss the next point, and next is pruning. So I'll go to my draw.io. Pruning. What does pruning means in general? Pruning implies removing something, deleting something. By default, what happens is, if let's say you have removed a manifest from your Git repo, then Argo CD by default does not delete that resource from your cluster. So for example, if you let's say delete the service manifest from the GitOps repository, Argo CD will not delete that service by default. So that is what pruning will do for you. Automatically delete cluster resources removed intentionally from Git. What it controls: cleanup of obsolete resources during architecture evolution. And understand, and we'll be doing this in the demo. Let's say you have a cluster IP service, and in our testing, in our local testing, we are using port forwarding. That is why we have that cluster IP service created to begin with. But now our testing is done, but now we want ingress, or let's say maybe gateway API. In that scenario, the cluster IP manifest will be removed and new manifests will be added. And once that cluster IP manifest is removed, I would want to remove that cluster IP service from my cluster as well. That is exactly what pruning will do for you. If you delete something in Git, then that will be deleted from your cluster as well. So understand, the desired state is in Git. Even if something is deleted, pruning, when enabled, will ensure that your cluster also doesn't have it. Disabled to prevent accidental deletions from incomplete Git changes. This is the default behavior, best suited for environments treating Git as authoritative lifecycle source, and that is what we have been discussing thus far. So let's do a quick demo for this one. Now what I will do is, I'll come to my terminal, and first I'll clear my screen. I'll press ls, and you see app1 svc here, correct? Let me do one thing. Let me first remove this svc, rm app1 svc. So we have deleted this service manifest. So if I go to Visual Studio Code, you will see that that does not exist here anymore. Now, once that is deleted, what I will do is I will also modify my manifest. So application CRD manifest. So I'll go to Visual Studio Code, And in this one, I will come here and I will add within automated, I will add prunes. Once you have automated here written, then this automatically implies that you have enabled automatic sync. And that is the first one that we discussed here. But now we are using pruning. So within the automated block, you will add prune. So I will indent it with 2 spaces, and then in the prune block, I will write true. So once you add this, what you will also have to do is you will have to remove this curly braces, because now you have content within automated itself. So I'll add prune is equal to true, which implies now you also start pruning. So what I'll do now is I'll go to my terminal, and here is the magic. So I will now write git status. This will tell me that you have removed one file and you have modified one file, which is okay. So I'll write git add dot git commit hyphen m, deleted svc and added prune in app crd. Then I'll press enter, and then I will write git push origin main. Now we are deleting this service with an understanding that our cluster will soon be using ingress or gateway API. So right now the service is deleted. So if I go to my browser, I go to Argo CD, this has not checked with Git yet. So let's click on refresh, and you notice this service here. And I completely forgot when we did the big demo, when we were in step 11, I should have shown you what the application looks like, but now I have already deleted. So let's see if I have time. Okay, I'll quickly go to terminal, and then here run kubectl port forward, and then I want to port forward a service that is in namespace app1 namespace, and then the name of that service is app1 svc and 8081. Anything that comes on my host on 8081, you send it to port 80, because port 80 is the port on which my cluster IP service is listening. I'll press enter, and let me quickly do this. Okay, I'll go to this localhost 8081. This is how my application looks. Okay, thankfully it has the 3 minutes did not elapse. So you see GitOps managed Flask application deployed to Kubernetes via Argo CD. And why I'm doing this quickly, because soon this cluster IP service will be deleted, because we have enabled prune and I will not be able to access my application. And again, I want you to see that we are using port forwarding. And if I go back here, if I go here, and if I go to history and rollback, so these are all the things that we have done thus far. So first we deployed the application, and this is for this initial commit. Then the change was changed replica count and Argo CD app CRD. This was done 9 minutes ago. And the recent one talks about this. So the commit message that we gave there was this one, deleted svc and added prune in app1 crd. So that should also come here soon. So this is taking some time. So let me click on refresh, and you see, I think I forgot to apply that manifest. Okay, so see what is happening. So if I click on details, this is selected, but understand, I did not first apply that app crd manifest. I made the changes, but I did not apply those changes, right? I made the changes, but I did not run kubectl apply. So that is my mistake. I should have run kubectl apply. So now to practice this properly, let's do one more thing. I will go to Visual Studio Code, and here in the deploy YAML, I will change this to 3. Okay, so I've made one more change. Now I will go to iterm, and then I will click on git status, and it will tell us that you have changed something. So I will write git add git commit hyphen m changes to replica count. I will write 3 here, and then I will write app crd includes prune, which got lost in the last time. I'll press enter, and this time I will push it. Okay, now this should work. Okay, I'll press refresh. See, sometimes the errors will make you learn something even better. So no svc now here. So if I go to my terminal and I run kubectl get svc -n app1ns, then you see no resources found, and whatever was working before this thing, this will stop to work now. And see, this is not working anymore. Now let's do one thing. So we have done these things. Now let's discuss the last one that I want to discuss: self healing. Purpose: automatically revert manual cluster changes to match Git. Now Git is our single source of truth. If someone modifies something in the cluster, what we want is those changes must be reverted, and the Git should represent the single source of truth. So for now, if I talk about my GitHub repository here, then what you see is app1 config, and if I go to deployment, if I refresh this, right now it has 3 replicas. If I change these replicas manually in the terminal for my deployment resource, so if I run kubectl get deploy -n app1ns, if I change this number, let's say from 3 to, let's say, 1, then Argo CD should revert it automatically to 3, because 3 is what is available in the Git 3, and this is 3 what is available in Git. So let's do this. And before I do that, so let me also tell you what it controls: continuous enforcement of configuration consistency across workloads. So no one should be able to, come to your cluster, do changes, and those changes should pertain. Those changes will not pertain if you have enabled self-healing. And another thing is best suited for production environments where manual changes are strictly prohibited. Now, if your specific implementation allows manual changes, then of course you will not be using self-healing. But I also want you to know one more thing. To use pruning and self-healing, you must first enable automated sync, because that is the only way via which Argo CD will be able to implement the changes in your direct cluster, in your Kubernetes cluster. So this must be enabled for this to work and for this to work. So first I'll go to Visual Studio Code this time, and I'll go here and then add self heal true. Now let's first apply this manifest and push it, because only when we push this, this will be registered by Argo CD. So understand, extremely important. If I apply this right now, self heal won't be applied. You know why? Because Argo CD, because of step 1, is automatically performing a sync, and my repository right now, making sense, right? My repository right now holds this information. It does not have self heal. So if I write self heal and apply this manifest, this self heal will not be there, because my Argo CD is syncing with Git, which is the single source of truth, and the YAML that Git has does not have self heal in it. So it won't work. So first we make the change, we push this to Git, only then we move forward. So I will run git add dot git commit -m added self heal, and then I'll press enter, and this will make the changes, and then I will use git push origin main. Perfect. And if I go there in my browser and I hit refresh, then self heal is now added. Extremely simple. I'll go here again, and I want to show you one more thing. Oh, this session has timed out. And then if I go to this app1, if I go to details, now you see self heal is not checked right now. It is not checked right now because the sync has not been performed yet. The interval, 3 minutes interval, has not triggered yet. And let me also show you why this is 3 minutes. Okay, if I run kubectl describe cm-n argo cd namespace, and here I want to check, I have to spell it right, hold on, describe for auto completion to work properly, argo cd, and then here I want to check this config map, argo cd cm, argo cd cm. Yeah, so if I check this config map, if I scroll up, further up, yeah, timeout reconciliation. 180 seconds. So it is 3 minutes by default. So I'll go to my browser now, and here I will click on refresh. And it was out of sync for a moment and it changed to synced immediately. Now, what is the difference? If you go to details, you see self heal is now checked. Understand these differences, folks. You will not be running kubectl apply on your application CRD manifest after making changes if you are committing that to your config repository, which you ideally should. Automated sync was enabled, so it auto applied this manifest. Now I right now have 3 pods here. So let's change this manually. So I'll go to my terminal. I will run kubectl edit deployment -n app1ns and then app1. I go into insert mode and I change this replica count to 1. And then if I run kubectl get pods -n app1ns, I see that it did terminate pods, but it again started, but they again started because in Git I have defined I want 3 pods. And here I said 1, but Argo CD controller said no, you cannot do that because Git is the single source of truth and I'm configured to self heal your cluster. So if an administrator walks in and change the number of replicas to anything but 3, then Argo CD is going to take action on that. That is how it is done. And why it could do this immediately? Because it had that information cached, which is why we didn't have to hit refresh or wait for any timer for this to happen. I hope this is understood. With this, I would like to end this lecture. That's a wrap. You should now have a clear understanding of how Argo CD works with private Git repositories, private container images, and Kubernetes secrets. Why access and credentials are platform responsibility rather than part of the application's desired state. We then built on the foundation by enabling and demonstrating auto sync, pruning, and self-healing, and saw how these features turn Argo CD into a continuous reconciliation system that enforces Git as the single source of truth. This lecture is an important milestone because it marks the shift from basic Argo CD usage to production grade GitOps practices. In the next lecture, we will take this further and focus on Argo CD orchestration. We will look at how multiple applications are managed together, how dependencies are handled, and how Argo CD scales beyond single application deployments. If you have any questions, feel free to ask them in the comments section and I will reply. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I'll see you in the next lecture. Thank you very much. Hi, I am Varun Joshi and welcome to the 5th lecture in our Argo CD Basics to Production course. In this lecture, we focus on Argo CD projects, a concept that fundamentally changes how Argo CD is used in real production environments. Until now, we have relied on the default project. Today, we will see why that approach doesn't scale and how projects introduce governance, guardrails, and clear ownership boundaries. We will understand what an Argo CD project really is, how it differs from Kubernetes namespaces, and how it controls source repositories, deployment destinations, allowed resource types, and GitOps level RBAC, all enforced before the sync even begins. We will then walk through a hands-on demo using a single fictitious application called application 1, composed of front-end tier and a back-end tier. Essentially, we'll be deploying a 2-tier application using Argo CD. We will create an app project for this application, deploy both tiers within its boundaries, and intentionally violate rules to prove these guardrails are real and enforced. by the end of this lecture, you should have a production ready mental model of how Argo CD projects enable safe, scalable GitOps. So let's get started. Now, before I start, if you see that hype button, I would request you to hype this video. Secondly, 50% of the audience that watches my channel, they are not subscribed. I would request you to please subscribe to this channel if you are finding value here. I am creating high value content for free. I hope you will understand the time and efforts it takes to make this kind of content. So if you are liking these videos, subscribe to the channel, like the video, comment how you feel about the videos. It would really mean a lot to me. And lastly, I have also opened memberships in this channel. If you want to contribute further, then please do become a member. So let's start with this lecture. Why Argo CD projects? Firstly, I want you to know that we have been using Argo CD projects since the inception of this course. Why, Varun? So firstly, if you see, we have always defined this project as a default. Now, this default project is available to you by default. It does not have all the bells and whistles that Argo CD projects have to offer. So keep that understanding in mind before we start discussing why Argo CD projects. So first bullet is unrestricted source repository. So right now, whatever Argo CD applications that we are creating, we are free to use any source repository, and that's a security risk because I do not want my DevOps engineers or my developers to be creating Argo CD applications that are using unauthorized source repositories, because I, as an administrator, clearly know that the config repository for, let's say, this microservice or this tier or this application is located in this repository. Hence, I must only allow those source repositories. And it is not just from a security perspective. I also want you to think of this as a guardrail perspective. Maybe I, as a DevOps engineer, was doing an all-nighter, and today by mistake I added something in the source which should not have been added. Maybe my personal repository, maybe my forked repository. I don't want whatever manifests are there in those repositories to be deployed into my cluster. Hence, we must have means in place via which we can control what can be defined in the source repository section. And then the second one is uncontrolled deployment destinations. And this makes sense. I want my Argo CD application to be only be able to deploy resources onto a cluster for which that application is authorized. I don't want my engineers to mistakenly deploy onto clusters which do not have to run those applications. And I want you to know one thing very clearly. You could be dealing with 10-15 clusters and you are deploying onto those 10-15 clusters using a single Argo CD instance. In that scenario, this becomes extremely critical. Maybe the application YAML that I have created must deploy into cluster 1, but what if by mistake my engineer added cluster 2 here? If I do not have guardrails in place, then this kind of mistakes will continue to happen. And I, as a DevOps engineer or as a DevOps lead, must be ensuring that both mistakes, genuine mistakes, and attacks can be prohibited. And these things can only be prohibited if you are adhering to principle of least privilege. Hence, both in source and destination, I should have proper guardrails in place so that only allowed repos are used and the destinations must also be clearly defined. Now, I want you to know that right now we are saying that this is the application, deploy this in this cluster and use this source repo to check for your manifest. But when we are using projects in a proper way, then we will have means to define that only these source repos are allowed and these destinations are allowed. Third is no resource level safety. Let's see one thing. I will go to my terminal and I'll run my favorite command, kubectl API resources. Now, this will give me all the resources available at my disposal, be it custom resources or be it normal native Kubernetes resources. Why I am bringing this up? For example, if my application just requires two manifests, and these two manifests are one a deployment YAML and another a service YAML, should I allow my Argo CD instance to deploy anything other than these two? Doesn't make sense, right? I have so many resources at my disposal, but if I know my application just needs two of them, let's say deployment and service, then why would I allow rest of these? With this application manifest, I do not have means via which I can be strict that when someone uses this application, Argo CD can only deploy a deployment and a manifest. That's all. It should not be allowed to deploy a config map. It should not be allowed to deploy an ingress and rest of the resources. It should only be allowed to deploy a deployment and a service. That is what we lagged. We did not have means to define that here. Next one is missing application level RBAC. Now, let's first understand why this is my favorite command. So if I run up arrow and here is my kubectl API resources and I add -o wide, I can see that what all are the verbs that are supported by, let's say, a resource. So for example, if I talk about daemon set, then all these verbs you can use to allow different users. So if you give get permissions, then that user or that group can only run get commands. So this will also give you verbs. But why I am discussing this right now? So this point says missing application level RBAC. Now understand, I as Kubernetes administrator, if I run this command again, but this time what I want to also do is I want to grep -i argo. I just want to list Argo CD resources. Now what I can do as Kubernetes administrator is I can give certain admins access on applications, on application sets and app projects as well. So these are the verbs that are available at my disposal, and we have seen this extensively in the CK code. So if you have any confusions about this, you can watch authorization, cluster roles, cluster role bindings, and that lecture will give you more clarity on how to use these verbs. But for now, I want you to understand that these verbs are talking about these resources, okay, but they are not talking about Argo CD specific nitties and gritties, such as I cannot disallow a user to perform the sync operation in Argo CD UI. So once you have this application, you can run sync apps, you can run a refresh, you can run prune, you can run so many things that are related to Argo CD, but you cannot use Kubernetes RBAC for that. You can use Kubernetes RBAC to allow or disallow users to create applications, create application sets, create app projects, and so on. But when it comes to performing sync operations, prune, and so many other things that Argo CD has to offer, you cannot use Kubernetes RBAC for that. But what is the solution for that? There must be something within Argo CD that will allow us application level RBAC. So when we just use applications with the default project, we do not have that functionality. Last one is single tenant trust model. All applications share identical permissions. Now let's say you have 50 Argo CD applications. And if all of these are using the default project, then you have no segregation based on criticality. There is no governance, there is no security, and so on. Now, what is that thing that takes care of all these challenges? And here I welcome the Argo CD project. So Argo CD project define hard GitOps boundaries that every Argo CD application must satisfy before sync begins. And this is the critical piece here. Before sync begins. So before synchronizing anything, Argo CD application must ensure that the things that are defined in the Argo CD project are being adhered to, and only when those things are adhered, the application is deployed. So let's first understand what we had before. So if I move here, this is the default Argo CD project that we have been dealing with thus far. So what it is automatic fallback used when no project is specified, fully permissive by design. Now what I mean by permissive is there are no guardrails in place, everything is allowed. So it is fully permissive, good for learning only, suitable for demos and quick experiments, which we have been doing thus far. Then unsafe for production, and we know why it is unsafe, because there is no isolation, no governance, or blast radius control. So with this understanding that what are default projects, let's see when we are leveraging custom projects what all we can do. So let me just balance this out first. Now let's first see what are these three snips. Now first snip is of an app project, and app project is what defines a project. So if I go here to my terminal, and if I just run this command again, kubectl API resources, I'll just remove -override from here. So when I installed Argo CD, 3 custom resource definitions were installed, and applications we have already seen, and today we'll be discussing app project. So understand that we will be writing app project YAMLs. Hence, they also need to be version controlled. Like we saw in our previous lecture, we version controlled our applications YAML. Similarly, we will be version controlling our app projects YAML. So anything that is declarative, we typically version control it. And so app project will also be version controlled. So like you see here, here is an example of this sample YAML. Now, we will be doing this deep dive in our demo section. For now, what I want you to understand is here is an app project YAML whose name is application1 project. And if you see, both of these are applications. These applications are my backend and my front end. So what I'm trying to convey you here, folks, is my application at large is called application1, and that application1 has a front end and a back end. So what we discussed in past lectures is essentially you would have different architectures. So in this section, we are dealing with tiers, app tier and a web tier, also called front end and a back end. Hence, I will have 2 different Argo CD applications for this, which is why you see I have 2 different application YAMLs. Now, what is the difference? In the project section, it is referencing a specific project that we have created, and this one is referencing this app project. And if you see the source repos, I'm saying anyone who references this app project or this project can only supply the names of these 2 repos. Hence, if I supply anything else in the source, then this will error out. So this has given me governance on what can be defined in the source repos section. Similarly, The destination here can only be this, and that is why in our application manifest, we can only define this as destination. Now, there are other controls which we will see as we will progress from this point. First point is GitOps guardrails, enforces boundaries beyond simple application grouping. Now, I want you to know that this is not just application grouping. Of course, what we are doing is we are doing some sort of grouping here, but that grouping is not just a simple grouping. It is there to enforce boundaries, to have controls in place. Second is governance abstraction, defines and enforces application level permissions such as trusted source repositories, deployment destinations. We have already discussed this. Allowed Kubernetes resource kinds. So when I talk about resources in Kubernetes, they can be either namespace scoped or they can be cluster scoped. And we'll be diving into this concept as we progress with this demo. So for now, just understand you can define what are the things that are whitelisted. Like I talked in the previous section, I said if your application just uses deployments and services, then only allow that. And that is exactly what we are doing in this YAML. So we are allowing creation of 4 kinds of objects or resources: deployment, service, config map, and secret. See the kind here, and we'll be dissecting this. So allowed Kubernetes resources kind, application level RBAC. That snip I have not shown here, but when we move to the demo, we will see how application level RBAC works, organization and multi-tenancy, and we'll be dissecting all these points in the demo. So I believe you have a fair understanding of what Argo CD projects are. With that understanding, let's move to the demo. So I will scroll down. The demo is working with app project, two-tier application, from GitOps guardrails to enforced application state. So in this demo, we'll be dealing with a two-tier application, and that application will have a front end and it will have a back end. So if you see, the step 1 is repository layout and creation. We understand that there must be separate repositories for our code and config. In this step, we will dissecting this point in detail. Second is we'll be creating a namespace. Understand, for now, we will be manually creating the namespaces. As we progress with this course, we will learn about sync waves, hooks, and so on. At that stage, we will be creating namespaces using YAML. Now, why this is important? Understand, when you create resources, you would want a certain order. For example, you would want the namespace to be created first and then the resources that will be deployed onto that namespace. So there must be some means via which you can define a sequence. So we have not studied that part yet, which is why we'll be creating this namespace manually. Step 3 is the most interesting piece. We will be creating this app project YAML. We will be understanding each field in detail. Step 4 is we'll be creating Argo CD applications, and exactly like this, we'll be creating 2 applications, one for the front end and the second one for back end. And then step 5 is build and push container images. In this step, we will be building a container image and pushing it onto Docker Hub. I want you to know that in the previous lecture where we discussed about private repositories and also about private image registries, we used everything private. But in this lecture, for simplicity, I would be using public image registry and public repos. And in this step itself, we will understand the application code. So what is the front end code? What is the back end code? Step 6 is where we'll be populating our config repositories with our manifests. Then in step 7, we'll be verifying whether everything is deployed by Argo CD. Understand that we will be using features like automated sync, pruning, and self-healing, which is why as soon as the connection with the repositories is established by Argo CD, we will see that the resources have been deployed. In step 8, we will be accessing our application using port forwarding. And finally, in the step 9, we will be doing some sort of chaos engineering to prove that the guardrails and airbags are enforced properly. Now, before I move on with the demo, I want to show you the prereqs for this one. So I'll go to my GitHub page, and then here I will go to Argo CD basics to production, and then here is this lecture's notes, and then I will scroll down, and from here I will go to prerequisites for this demo. Understand that you should have an Argo CD instance up and running, and it should be port forwarding. So for me, the port forwarding is already working. So if you see here, port forwarding is working. And then if I go to my browser, I have already logged in into my Argo CD instance. So this should already be in place. Now let's start discussing about the first step, repository layout and creation. So in this step, we'll be creating our repositories and we'll be understanding the structure. Now we clearly know that the application code repo and the config repos are separate. It's a best practice to have these things separate. But if I talk about my front end and back end tier, you can have different repository designs. So I want to take a moment to tell you what all options are available at your disposal. So if you look at this chart, let me scroll down, maybe my face is interrupting your view. And here you can either have two repositories, and when you have two repositories, one will be holding the application one code, and this implies there will be two subdirectories created, one for front end and one for back end. And similarly in repo 2 as well, application 1 config repo, you will have two directories created, one for front end and one for back end, for separation. And we have talked about this in detail if I go to lecture 2 and lecture 3. So if you do not have that understanding, I would encourage you to go and watch those lectures. So this design is used by small to mid-sized organizations. It is most common there. Shared life cycle for front end and back end, minimal ownership and governance boundaries. And that is obvious. You are using essentially a mono repo design, which is not recommended when you are dealing with production grade implementation. And then there is a three repository design. What you will have is, you will have three repositories. Repo 1 will have application front end code, repo 2 will have application backend code, and then there will be a third repo which will have app1 config. And this repo, the third repo, will now have two directories, one for front end and one for backend. That is how you will be segregating resources if you go with three repo design. Now I want you to know that when I talk about the code repo will also hold your Docker file along with your Jenkins file or your build spec.yaml or any YAML that pertains to your CI/CD tool. So keep that thing in mind. And you may also see this design being used when I talk about the recommended design. So this is the recommendation when you are dealing with enterprise grade applications. You have 5 repositories, but Varun, why 5? 4 I can understand, 2 for app code front end and back end, and 2 for config front end and back end. What is the 5th repo doing here? I want you to clearly know, to whom does this app project YAML belong? This belongs to application 1 as a whole. It does not belong to backend or front end. So where do you store your project YAMLs? So you create another repository where your this YAML will be stored. Project YAML will be stored. So that is what the fifth repo is doing, used by large enterprises, regulated environments, strong separation of duties, smallest blast radius per change. Argo CD platform config is what we'll be calling this repo. It defines global GitOps guardrails, access and onboarding for all applications. Now, as we progress with this lecture, we will learn what all other manifests can be stored in this Argo CD platform config. For now, we will just be storing our project YAML. Now what I will do is I will go to my GitHub and I will start creating my repository. So from here I'll go to the top and then I'll open this in a new tab, and here I will go to repositories and then I will click on new, and here I will be creating my first repo that is named app1 frontend config. So I'm creating the config related repositories. For front end I have created, for backend I will create next. So I'll click on create a repository and then I will create one for backend as well. So I'll go here and then here I will go to repositories, new, and then I will paste that here. App1, this is for backend. Previously what we created was for front end, and this will be public. That's correct. I'll click on create repository. Now let's also create a third repository, and this repository I am creating for my Argo CD project YAML, and this one I will call Argo CD platform config, and you will see what other things we can store in this as we progress with this course. So we have created 3 public repositories. Now understand, when you are dealing with production implementations, these will be private like we saw in our previous lecture. For simplicity, I am showing these as public, and I want you to know that right now I am not creating any repositories for my application code. So you know, when we are dealing with production implementations, you have CI servers. In those scenarios you will have these code repos as well. I will just be creating, container images and then pushing them. I don't want my code to be in repository. But if I talk about production designs, you will have 2 more repos here as well. Now that we have this understanding, we have the repos created. Next, I want to create a namespace. So I'll go to my terminal and then I will go to this tab here. I will run kubectl create ns app1 ns. I'll be creating a namespace where we'll be deploying both the tiers of application 1. I'll press enter and this says that the namespace is created. Now let's see what we want to do in step 3. In step 3, we want to create our project YAML. So let's go to Visual Studio Code now. Now, when you go to the GitHub repository for this lecture, you will find that I have defined the entire structure for you. You can download this and go hands-on along with me itself. So I will first open Argo CD platform config. This is where my project YAML resides. So I will zoom in a little and then I will give you a walkthrough of this line by line. So first is API version, and we know all of these things can be understood from this kubectl API resources command. So if you run this command, you will know what is this API version and you will also know what is the kind. So since we are dealing with app project, you can see this and this from here. And these are the short names for app projects. We'll be using this as we progress. Then metadata. So we are calling this app1 project. Namespace is Argo CD. We know that whenever you are creating resources associated with Argo CD like these 3, you will be creating them in the Argo CD namespace itself, which is why I have defined Argo CD namespace. Under the spec section, we have description first. Project for app1 frontend and backend workloads. Understand that when you are in production implementations, having detailed description is important, so have something meaningful here. Source repos. I have defined 2 repos here, and both these repos we just created. So if I go to the browser and you see front end, this is the URL for the front end. And if I go to backend, this is the URL for backend. And I have defined these in the source repo. Now, anyone who is referencing this project, any application that is referencing this project, can only use these two repos. Destinations. Now, destinations, I have namespace is app1. Anything starting with app1 is permitted, and I'm defining that the destination can only be this cluster. So whatever applications will be using this app project can only deploy to this Kubernetes cluster in this specific namespace. So app1 and then hyphen and then a wildcard. See, at this stage itself, I want you to broaden your imagination. So right now, I am creating this project for app1. Okay, but understand, I could also be creating a project for anything development, and I can call that dev project, and based on that dev project I can have source repos, namespaces, and all these things defined. Do not restrict yourself from thinking that this project must be application specific. So if you understand why projects are used to begin with, then you can create that mental picture in your head. So if I create, let's say, a dev project here, then any applications who are referencing this dev project can be using any of the repositories that I define here, and all the destinations that I define here. Maybe in that scenario, I will have dev and then a star. So anything that starts with dev, resources can be deployed onto that namespace. So broaden your imagination. Okay. Then next is cluster resource whitelist, and then you have namespace resource whitelist. And if I run that command again, if I go to my terminal and I run kubectl API resources, then we know that there are certain resources that are namespaced, and then there are certain resources that are not namespaced. So namespaced resources are essentially the resources that you deploy onto a namespace, and the resources that are cluster scoped, as in non-namespaced resources, are the resources that span the entire clusters. For example, if I talk about ingress classes, they span across the cluster. And if I talk about ingress, they are limited to a namespace. And similarly, you can check about deployments, services, and so on. All these are namespaced. But when I talk about persistent volumes are cluster scoped, but persistent volume claims are namespace scoped. So you have to understand these things, only then you can be writing these things in your YAML. So here what I am saying is, when I talk about cluster scoped resources, only whitelist namespaces. Now what does this mean? Now let's say if any of these repos have a namespace YAML, the namespace can be created because I have allowed that, I have whitelisted that. But if user tries to have any other manifest here for the cluster scoped resource, for example, if I talk about, let's say, persistent volumes, okay, persistent volumes are cluster scoped. If someone tries to create a persistent volume, then I won't allow that to be created, because what I have done is I have only allowed namespaces when it comes to cluster resource whitelist. Understand this point. It is critical to understand this. Now, when you allow a certain resource, then there is an implicit deny. So if you have allowed namespaces, then any other cluster scoped resource will not be allowed. Then second is namespace scoped. So here we are saying namespace resource whitelist. So anything that is namespace scoped and you want to allow, you allow in this block. So in here, anyone who is trying to create a resource that is outside of that list, so any manifests that are held here in these two repos should only be these. If there are any other manifests, for example, manifests that are creating persistent volumes or persistent volume claims, then those things will be denied. So only these things are allowed. Then I have deliberately added this block here, cluster resource blacklist, although these things are disallowed by default because there is an implicit deny after this. So once you have allowed something, once you have whitelisted something, there is an implicit deny that follows. So I didn't have to have this block. I have kept this block so that you can understand it. Now, Varun, what is the group and then what is the kind? Kind you already understand. Kind is this kind. Okay. So when I talk about deployment, I am allowing deployments to be created, which is why I have, the kind deployment allowed. So if I scroll down, where is deployment? Yeah. So if you see this, I am allowing this. But what about this group here? So this has apps, this has blank. Now what Kubernetes has done is they have segregated the resources based on their API versions. This can be thought of as a grouping. So when I talk about anything that has a v1 here, that belongs to the traditional API group, and when we are dealing with app version v1, then you do not have to supply anything inside double quotes. And if you have good understanding of cluster role bindings, role and role bindings, then you will understand this point in a much better way, because there as well we use something similar to this. Again, if I talk about deployment is under the apps API group. So if I go to deployment here, if I scroll down, you see this is part of the apps group, which is why we have apps written here. Similarly, if I talk about RBAC cluster role and cluster role bindings, if I scroll down, you will see cluster role and cluster role bindings. Here are the role bindings, here are cluster roles and cluster role bindings, and you see these are part of RBAC authorization KTS.io, which is why you see here RBAC authorization KTS.io. So I hope these things make sense, and if you have okay knowledge of Kubernetes, you would already know these concepts. Then let's talk about the interesting piece. Here we have roles. Now, what are these roles? So we are saying we are creating two roles. We are naming them dev read only role and platform admin role. And then we are defining a description for each of these. We are saying that anyone who is part of the group app1 devs can use this role. Anyone who is part of platform team group can use platform admin role. So this thing is obvious and can be easily understood from this YAML itself. But Varun, what is this? So for this, let's go to our GitHub notes. I'll go here, I'll go to this one, and then I'll go to scroll down, and I want to go to create app project guardrail, and I'll scroll down. So the description of this YAML is also here if you are interested in reading. I'll scroll down further down, and here is the syntax for this, and it is very simple, and once you start using this, you will have an understanding of this very clearly. So I've opened the reference as well, the official documentation for this, and this you can refer this one. So the syntax is p role user or group, then you enter a resource. Now what is this resource? This resource can be applications, application sets, clusters, projects, and so on. In our example, if you see here, we are talking about applications, which is why we have applications here. As we progress with this lecture, this course, we will see more things that can be used. So let's do one thing. Let's walk this from left to right. So I'll go here, and then let's match this one by one. So we are saying the syntax is p, so this p is here. Then role user group. So here we are saying we are talking about a project. That project is app1 project. And why we are calling app1 project? Because we have named our project app1 project. And then what we are saying, platform admin. So platform admin is the name of the role. So we are discussing this, hence we are calling this. The name is platform admin. And then we are saying applications. So the resource that we are dealing with is applications in this scenario. Then you have actions. Actions is applications is fine. You are allowing things to be done in applications. But what things are allowed? What are the verbs that are allowed? So here I'm saying anything is allowed. So this can be view, sync, update, delete, rollback. All of these things are allowed. But when I talk about this role, dev read only, this one is saying allow users in the dev read only role to view, that is read only, all Argo CD applications within the app1 project. Then in this one, what I am saying is allow users in platform admin role to perform all Argo CD application operations. All. And what are those operations? What those operations could be: view, sync, update, delete, rollback, prune, etc. And why do I know this? Because this is already there in the documentation. So if I go here, what it is saying: get, create, update, delete, sync, and based on what resource you are using. So I am using applications right now, which is why I can leverage all of these. So invoke is not available here. So for example, now I want to give you one more direction here. So Argo CD is a GitOps controller. It is not something that will manage your users for you. Of course, you can create local users, but in production, you will rarely be using such kind of approach. What you would be doing is you would be integrating your Argo CD with your SSO. For example, so if I go to the documentation itself, and if you see here in the user management section, you can integrate Argo CD with Okta, OneLogin, Google, even AWS's IAM Identity Center, which was formerly known as AWS SSO. So once you integrate with these solutions, all the groups that you create in these respective identity providers, Argo CD will work on that premise. So for example, let's say you are using Microsoft's Active Directory. In that scenario, you would first create a platform team group in Microsoft Active Directory, and then you will be adding users to this group. For example, a DevOps administrator would be part of, let's say Varun is the name. So Varun will be part of the platform team group. And once Varun is added, then Varun will have these level of permissions when I talk about applications that are referencing app1 project. So I hope you have this solid clarity. With this understanding, let's apply this manifest. So what I will do is I will walk you through the structure later, but for now I will right click here. I'll click on open integrated terminal, and here I will write kubectl apply -f, and I only have one file here, app1proj.yaml. I'll press enter and it says the project is created. I want you to notice one thing very clearly, that I first created a project and only then I will be creating my Argo CD applications. Then that is understood. Until and unless the project is created which is referenced by my applications, it wouldn't make sense. Hence, you first create your project and then you move to creating your applications. So what I will now quickly do is I will use that terminal only to see my resources. I will run kubectl get app projects and -n Argo CD, and this will tell me that you have app1 project and you have the default project. App1 project was created 46 seconds back. So if I go to my browser now and I go here and I go to settings and then I go to projects, you see the default project had asterisk everywhere. So it was allowing everything, which is why I said this project is fully permissive in nature. But when I talk about the project that we recently created, you can see whatever we defined in the YAML, all of those things are available here. So you can check this via the UI, or you can check this via the CLI using the describe parameter. So if I run describe here, then it will show me all the details about this application project. So we have this clear understanding. Now with this, let's move to the next step, which is step 4. And let's see what we want to do there. I'll go to my diagrams, and step 4 is create Argo CD applications, front end and back end. And it is exactly like we saw before. So what I'm doing is I'm expanding the app1 backend config, and in app1 backend config I have two directories. Understand that one that is called Argo has my application manifest, the Argo CD application. And then if I talk about backend, this has my Kubernetes manifest. Understand what we learned. You separate your application code repository and your config repository. The code repository for backend is this one. Right now I want to concentrate on the config repository, and we learned that the config repository will also have your Argo CD application along with your manifest. Now I have segregated these into directories for better readability, and I'm calling this backend. You would see this also called manifest, or whatever your chief engineer or your application architect or your DevOps architect decided the nomenclature to be. But understand, these nomenclatures must be self-explanatory so that anyone who is working, even if you leave the organization, can see and understand what this previous engineer was trying to do, and he or she should have a smile that this person did things how they are supposed to be done. So this terminal I can exit, and now what I want to do is I want to open a terminal in this Argo directory. So I'll click on open integrated terminal here. Understand where I am. I will run kubectl apply -f. I only have one file here, app1 backend application CRD. And if I apply that, it will say created. And we have already seen these, but I will again give you a short walkthrough of this. So I'll click here, and then let's see what is going on. So here this part is understood. Application metadata app1 backend app. I'm calling this so that as soon as I see this application, I know this belongs to application 1 and this is for backend, and I have that app so that I know via the naming as well that this is an Argo CD application. Naming is important. Namespace is Argo CD. We understand why this is Argo CD, because Argo CD related resources should be created in the Argo CD namespace. In the spec section, I have project, and here I'm referencing the app1 project that I just created. So what I will do is I will open these things side by side so that I can show you these things in a better way. So I'll open this in the right, I'll split this to the right, and then I will close this from here, and then I will also minimize this one here. Maybe let me just zoom out a little. And then I'm saying the source repo to be used is this one, app1 backend config. And why I can freely use this? Because in my app project YAML, I have allowed this. Target revision is head. This will point to the latest commit in the, in the default branch, and the default branch in our case is main. Path is backend. Now what I'm saying, in this repository, the things that you have to apply, the manifests that you have to apply are there in the backend directory, and that is what the structure that we have defined. In backend config repository, we will have these things in the backend directory, and that is what we'll be doing. We'll be uploading these soon to our GitHub repository. I'll minimize this, and then destination is already understood. Sync policy, we are saying we will be using automated sync. Prune is true, which implies if something is deleted from the repository, then you delete it from the current state as well. Self-healing states, if someone creates a new resource or modifies any resource in the current state, then delete that resource, because our desired state must always match the current state. So if you do any modifications in the current state and the desired state does not depict that, then the current state will be modified to adhere to the desired state. So I hope this is clear. Now I will close this YAML. I'll close this too. And then let me just quickly reopen this so that we don't commit any mistake here. I will right click here, open in integrated terminal, kubectl apply -f. I'll apply this YAML. And this is already applied. I think I applied it before and along with you itself. And then if I go here to this application for front end, let's apply the front end application as well. So if I go to app1 front end, it has the similar structure, Argo and backend. Here we have Argo and front end. If I expand Argo, you see app1 front end application YAML here. So I will right click here, open in integrated terminal, and here as well I will run kubectl apply -f and then name of that YAML. So I want you to see that this is also similar, if not same. It is just that in place of backend, we have front end, and path as well is front end. So if I go to my UI now, if I go here and if I go to applications, I see that both of these applications are created. Now I want you to clearly know that the status is showing healthy for both of these, the application health status, which is wrong. And of course, this is because we have not performed a sync yet. That's why it is showing healthy status. This is not the actual healthy status. So it will show unhealthy when the sync has been performed once. Right now, it does not have any real information because it cannot connect to a repository. Or can it? It can connect to your repository, but your repository does not have anything yet. So if I click on this error, it is saying fail to load target state, fail to generate manifest from source 1 of 1, unknown description, fail to list references, remote repository is empty. So it is saying I'm able to connect, but your repository is blank, my friend. Then what is that I should be doing? So let's upload our repository with the files that are needed. So if I go to my draw.io, so we have done this, So before uploading anything, let's first build and push our container image. But before we even do that, let's understand our application code. So I will go to my Visual Studio Code again. I will exit this so that we have more real estate. Exit this too. And then I will close this. I will minimize everything and then reopen. So let's run tree instead. That would be better for your understanding. I'll write tree here. And you see, I have 5 directories. And like I said, you will be creating 5 repositories in production implementations for this kind of application. Now, application 1 backend and application 1 frontend, these two are my code repositories. So this has the data that should be uploaded in the code repository. Now what this has my application code for frontend. This has the application code for my backend. And similarly, if I talk about config repos, the Argo directory has my application YAMLs, the Argo application YAMLs, and backend and frontend, these have the respective frontend and backend YAML. So we are just creating a deployment and a service. All these YAMLs are here. So now we have this understanding. Let's see the application code. So I'll go to Visual Studio Code. I will expand application 1 backend. Let's first study the backend. And if I open this, this is just saying that hello from backend API. That's it. And this is listening on port 5000. Okay, this is backend. So if I go to the Docker file here, we are saying that use this as the base image. Working directory is /app. We install Flask because our application uses the Flask framework. Then we are saying copy app.py, which is this one, to the /app. That is our working directory. Then this is just for information. We are saying our backend listens on port 5000. Understand, this is just for documentation. actually opening the port is part of the application code. So here we are saying our application listens on port 5000. And then Dockerfile, we are just running the application by running Python app.py. So that is our backend code. So we'll be using this Docker file to build the container image. Now let's also see the Kubernetes deployment and service manifest for backend. So if I open this as well, if I go to deploy.yaml, then I would see that it's a very normal YAML. I am just calling this deployment backend. We are deploying this in app1 namespace, one replica. All of these things you already understand. But here is the key part. We are saying that the image that you should be using is this one. And this will make much more sense when we, create our container image using the Docker file that you just saw. Ports, I am saying this listens on port 5000, and this is again just for information. Your application should indeed listen on this port for this to work. Then we have the service manifest. The service manifest is also simple. We are saying that the target port is 5000. This is the port on which my container is listening, and then the cluster IP port is also 5000. So this is our backend code and manifest. Let's talk about the front end code and the manifest. The code again here is simple. It is trying to reach the backend URL and fetch the message that we showed there. So what we showed there was this one, right? We showed there that service backend, hello from backend API, status is success. And that is exactly what we are polling here. We are reaching our backend service and we are asking it to show that message. And then our front end service will also be saying front end. And you see, we have defined certain variables here, which will be calling our backend service URL. Now you see, we have defined that here. We are saying whatever you want to fill here, get the details from backend SVC on port 5000. And we know backend SVC is this one, which is listening on port 5000. So this is a very simple application. I gave you a walkthrough so that you understand the application as well. Front end deploy is simple. Here we are defining an environment variable. We are saying the value for backend URL is this one, and that is okay. Then we have service manifest. Here we are saying the target port is 4000. The 4000 is the port on which my application is listening. And why is that? Because if I go to the code, it is listening on port 4000, which is why if I go to service manifest or front end, the target port is 4000 and the cluster IP port is 80. So we have this understanding. Now let's do one thing. Let's create our container image. So I will again minimize everything. Then I'll go to 5 and then I will go to app1 backend and then right click here, open in integrated terminal. And here is where I will be creating my Docker image. So I will run docker build -t cloud with Varjosh. That is my Docker Hub account name. And then I will write app1 backend. And then let's have a tag v1.0.0. So 1 is the major, 0 is the minor version, and 0 is the patch release. And then I'll add a dot for the context. I will press enter. And this has started building my container image. Now, if I run docker images, then I would see that my image is created. App1 backend is created here. Now let's do one thing. Let's push this image. I'll run docker push and then I will just copy this thing from here and then I will paste it here and I'll press enter. It directly pushed. It did not ask for any credentials because I am pushing into cloud with Varjosh account. How can I push into an account without logging? I can, because if I go here, if I go to my dashboard of Docker desktop, then you see I've already logged in via my cloud with Varjosh account. If you are using Docker engine in, let's say, Ubuntu or any Linux based VM, then what you should be doing is you should also perform a Docker login. Only then this will work. Docker push will work. And if you are using Docker desktop, just ensure that you are logged in. So I'll close this one, and this has pushed. So now what I want to do is I want to also push the front end. So I'll let me copy that so that I can quickly type the commands. I'll copy this, and then I will go to app1 front end. I will open an integrated terminal, and then I will paste it here. And this time here I will write front end, and rest is okay. So I'll press enter, and this will build this for me as well. And I'll copy this, and then I will write docker push, and this will push into my Docker Hub account. So in the meantime, let's go and check my Docker Hub account, hub.docker.com. And you see app1 backend is already here, and my terminal is still pushing app1 frontend. Let this work. Let me try this again. Let me run Docker images, and I see app1 frontend is created. So let me just try to push it again. Docker push, and then it has copied the tag 2. I'll press enter. Oh, this says done. So let me go to my browser. I will hit refresh, and I see app1 frontend and backend are both here. So this is my private account that has two public repos here. These two are public repos. This one is a private repo. So that is why we do not have to supply any credentials. That is why in our deployment manifest, we are using these with just this information along with the tag. Now, if you want to see how this works in, let's say, when you have private repos, in that scenario, you should check the previous lecture. Now let's go to our draw.io and see what we want to do next. So this part is done. Populate config repositories. Now let's upload our content to our repository. So first, let's go to our Argo CD again. And here you see the status is still unknown and unknown because we do not have any files in our repositories. So let's go to backend first, and let's click on upload existing file. So I'll go to Finder, I will go to courses, and then Argo CD, then lecture 5, this one, and then this is for backend config. I will go here, and then I will move both of these here, and I'll do the same for the app1 front end config. I'll go and click on upload existing file, and then I'll go to this again. I'll go to front end config, and then I will drag these here. I'll do full screen here, and this has uploaded. I'll click on commit changes here as well. I'll click on commit changes. So both of these changes are committed. Now what we should see, understand, right now it is unknown. If I go to my application CRDs, let me exit this. If I go to my Argo CD application for backend, you see that I have sync enabled, automated sync enabled, prune and self-healing is also enabled. So ideally, if I go to my browser, then this, you see, this is now synced because we have automated sync enabled, and this was checking with my repository if there is something to be deployed, and it saw that the desired state that is defined in Git is not matching the current state, and hence it performed a sync. Now this is actually healthy. So if I click on, let's say, backend first, then you see there is a backend SVC, and then there is a backend deployment as well. So, and you see it is referencing a commit which ends with 01D. So if I go to backend, you see 01D was the commit that we did a minute ago. Now I want you to know one thing very clearly, that Argo CD checks your repository approximately every 3 minutes. Understand, it has synced automatically because we have enabled automated sync. If we didn't have that in place, if we didn't use this, let's say sync policy automated, Then we would have to click on synchronize for this to synchronize. Okay, so the interval that is defined is for checking with the GitHub repository whether the sync will be performed automatically or not is governed by this. So I hope that distinction is there in your head already. So both front end and back end are deployed. So let's do one thing. I'll go to my terminal. I will clear my screen for more real estate. I will run kubectl get all -n app1ns. And you see the backend pod is running, the front end pod is running, the services are created, everything is hunky and dory. So let's do one thing. Let's access our application, and accessing our application is also our next step. That is step 8. So step 7 we have already done. Deployment and service are created for us. Now let's access our application, and to know that the name of the front end service is front end svc. So what I will do is, here I am port forwarding for my Argo CD. Let me open another terminal. I will zoom in here. I will run kubectl port forward -n app1ns, and then the service there that I want to use is svc, front end svc, and I want this to listen on port 8081 on my local host, and the port to which I want to forward anything that comes on 8081 is, if I go here, it is port 80. That is the cluster IP port for my front end service. So I'll go here and I will write 80 here. I'll press enter. And this has started forwarding. You remember our application front end, the front end of our application 1 is listening on 4000. So if I go to my browser, if I type localhost 8080 and press enter, oh, 8080 is Argo CD. I'm so sorry. Localhost 8081, press enter. Hello from backend API. So this is what we were displaying, and the service that is displaying this is this one. The code that we had in our front end was hello from front end. So this was a very simple application. I hope all of these things are connected perfectly. Now let's verify whether whatever we have done, all the guardrails that we have implemented, are they working correctly or not. So if I go to, let's stay in this browser itself. So if I go here, rather let's go to Visual Studio Code. So if I come here, so what we have said is, when it comes to cluster resources, only namespaces are allowed to be created, and namespace resource whitelist, we only have these 4 objects that can be created, objects or resources. These 4 can be created. So as long as I'm creating these 4, I should be okay. But if I create anything other than these, then I should not be okay. And same applies for cluster scoped resources as well. Only namespaces are allowed to be created. So let's do one thing. Let's try to create a namespace scoped resource and a cluster scoped resource. So I'll go to my browser. I will go to backend. Let's do this in backend. I'll go to this backend path, because understand that we have defined the path as backend. So I will click on add file here, and then let's do one thing. Add file, create a new file, and then I will name this pv-pvc.yaml. And here we'll add a pv YAML and a pvc YAML. So I will go to my GitHub repository for this course. I have a YAML there, a pv and pvc YAML. I'll scroll down and here it is. So here we are creating a persistent volume and then a persistent volume claim. So I'll copy this. I'll go to new file here. I'll paste this here, and then I will click on commit changes. And there is one more thing I want to highlight here. Now you would be thinking, Varun, if we do any changes in this manifest, then those changes will not be automatically applied by Argo CD, because Argo CD is just monitoring backend directory. And that question is correct, and we'll be answering that in our next lecture. So for now, this understanding is sufficient. So we have already created this YAML file. Now we understand that automated sync is enabled. Argo CD will be checking with our repository app1 backend config to see if there are any changes. As soon as it finds this, what Argo CD should be doing, it should see that what are the guardrails that are available in the project with which the application is associated with, and based on that it should take a decision. So if we go here, you see sync is okay. So let's do one thing, let's wait, or we can also click on refresh. So for now, let's wait. What I can also do is I can manually click on refresh so that it checks with the repository if something has changed or not. But for now, let's wait for this to be automated. So it checks approximately every 3 minutes. You see, it automatically sets syncing, and then it says out of sync. And you see here, these things are green, but these things are yellow. And if I click on this syncing, read the message. Persistent volume is not permitted in project app1 project. Resource persistent volume claim is not permitted in project app1 project. And this is so interesting and so cool. Anyone who tries to create resources that we have not specifically allowed, then those things will not be allowed to be created. So we have understood this thing. What we can do is quickly we can go to this, and then we can go to this file, and then we can delete this file. I'll come here and then let me delete this. Commit changes, commit, and this will delete this file so that this is again back in healthy state. So if I hit refresh, so let it work under the hood. We'll come back to this later. Now let's see what we want to do next. So what we have checked is we have checked these things. We have checked that if we are trying to do anything outside of this, it is not being allowed. Now I want to do something here. So as I told you, I do not have an integrated IDP where we can test this thoroughly, but what I can do is I can create a user locally and then see how it works. Understand, if I create a user locally, that user should not be allowed to see anything, because only users that are part of this group are allowed get access, and that too only on applications that are part of app1 project, that are referencing app1 project. So for now, let me go to the CLI, because if I go to this screen, I'll tell you one more thing. If I go to Chrome and then if I go to a user info, I don't see a tab to create a user here. Okay, if I go to settings, even if I go to accounts, I don't see an option to create an account here. So we'll have to use the CLI. So I'll go to the CLI. I will run Argo CD account list, and this shows admin is true, capabilities is login. Now if I have to create an account, then what I can do is I can edit the Argo CD CM. So what I will do is kubectl edit CM -n Argo CD, and the config map that I want to edit is called Argo CD -cm. So this is what I want to edit. I'll press enter, and here in the data part, what I will do is my camera is obstructing my view. Hold on. So I will indent this properly, and then here I will write accounts.cwvj. What I am saying is I want to create a user that is called Cloud with Varjosh, or I want to create an account that is named CWVJ, and here I will write login. So what I'm telling here is the user that I create should have UI login privileges. And I want you to know one more thing. Right now we are using the admin user to log in and perform all those actions. If you want to disable that admin user, then you can remove this line as well. So I press escape shift ZZ, and the user is created. See, the user is created, but how about password? Because if you log in into the Argo CD UI, it always asks you for a password. So let's do one thing here. I will run an Argo CD command. I'll go to GitHub here, and then I will scroll further down. And this is how you create a password. So Argo CD account update, name of the account, CWVJ, that is what we just did. Current password, this password is for the admin user, anyone who is running the command. So I am running the command as admin user right now. And if you don't know how to log in as admin user, you go to Argo CD login and then supply the URL of your Argo CD instance. Understand that you could be having several Argo CD instances. On which Argo CD instance you want to run the commands. For that, you first run Argo CD login and then the cluster where you want to run the command. And once you press enter, it will ask you whether you want to proceed. Because we are using HTTP, then the username is admin, and then the password for my admin account is admin@123. Once you have added that, you will be running commands in that context in that cluster. So if I go here, then here I'm saying the current password for the user that is currently running commands is admin@123. The new password that I want to set for this user is cloud with varjosh@123. So I'll copy this one, I'll paste this here, I'll paste it, press enter, and then it says password updated. So if I go back to the UI and then let me log this out and let me run localhost 8080, I press enter, and now I will log in with cloud with varjosh, and then password is cloud with varjosh@123, and I don't see anything because there are only two groups that are allowed to see what is there in the app1 project, what are the applications that are part of app1 project, and the user that we are currently using does not fall under any of these groups, which is why that user is not permitted to list our applications. I hope that makes sense to you. Now let's do one thing. I will now exit from here, log out from here, and then log in again because our one thing is still pending, correct? Localhost 8080. Let's see what's with that sync status, admin@123. Sync failed. And then let's click here and see what is happening, why the sync failed. Okay, let's do one thing. Revision. Let's do one thing. Let's refresh this. If I refresh this, so it is not giving any problems here. Those yellow highlighted PV and PVCs are now gone. But here it says sync failed for 89C. Now let's see why this failed. 89C. So I deleted that as part of this commit. So history is this. And we added that as part of 89C. So it has not read this commit yet. So hold on. Let me see why this is. Argo CD, refresh. Let me manually try to synchronize this. Synchronize. Oh, it worked now, and it is now reading the latest commit. And if I go here, what was the latest commit? It is F90. And if I come here, it is F90. I hope this connected a lot of the dots for you. Now, if you want to practice anything else, what you can do is you can try to create an Argo CD application that uses any other repository than this and also points to this project. So try doing that. That should not work if you are pointing to any repositories other than these two. That brings us to the end of this lecture. You should now have a clear understanding of why Argo CD projects are essential for production GitOps and how they enforce boundaries around where applications can deploy, what they can deploy, and who is allowed to operate them. We validated these concepts hands-on by applying app project deploying applications within its constraints and intentionally triggering failures to observe policy and RBAC enforcement in action. This lecture lays the groundwork for what comes next. In the upcoming lectures, we will build on the same setup to explore orchestration concepts like sync waves, hooks, and ordering, and see how Argo CD scales to complex multi application environments. If you have any questions, feel free to ask them in the comment section and I will reply. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi and I welcome you to the sixth lecture in our Argo CD Basics to Production course. In this lecture, we will deep dive into Argo CD sync phases and hooks, a topic that's often misunderstood but critical for running Argo CD in production. We will start by revisiting what a sync really is and why it is more than a simple kubectl apply. Then we will break down the sync process by hooks and clearly explain how they fit into Argo CD sync lifecycle. Next, we will draw a sharp distinction between phases versus hooks, helping you understand where Argo CD is in the life cycle and what actually runs at each point. Finally, we will walk through a hands on demo to observe sync hooks in action so you could see how this life cycle behaves in real deployments. So, let's get started. Before I start with the technical discussion, if you see that hype button, do hype this video. If you are liking the kind of content I am creating, I would really appreciate if you could like the video, comment in the video, even if it is just a hi or to tell me how I can improve or what is working good for you. That would be great. Of course, it would really help if you can subscribe to the channel. Also, I have recently opened membership. If you want to go a step ahead, then I would also urge you to become a member of this channel. So, what is a sync operation? And we have been using this sync since the inception of this course, be it manual sync or be it automated sync. A sync operation reconciles get declared desired state into the cluster until live state matches. So, in simple terms, whatever you have defined in the Git, a synchronization operation, be it manual or automated, will ensure all those resources are created in your cluster. So first point is state reconciliation, compares git manifests with live cluster state to detect and fix configuration drift. Second is delivery confirmation. Success means manifests were applied, not that workloads are healthy. And I see a lot of folks get confused here. So what we are saying is there is a synchronization process, and the synchronization process will only succeed when all the YAMLs that you have defined in your Git are created successfully in the cluster. I'm saying all the YAMLs are applied successfully. Only then the synchronization process is a success. If there are any typos or if there are any errors in your YAML and that results in that YAML not being applied successfully, in that scenario, the synchronization operation fails. Now, this is different than application health. Even if your synchronization has succeeded, your application could be unhealthy. So let's take an example. If you are creating a deployment that has 4 replicas and you have defined the YAML correctly, and the deployment is created and there are 4 pods created because you defined 4 replicas, but there is a possibility that those 4 pods are stuck in some error. Maybe there is image pull back off, image pull error, or container error, and so on. In that scenario, your application would be unhealthy because your pods are not running. However, The synchronization process succeeded because it was able to apply all the YAMLs that were defined in Git in your live cluster properly. So understanding this distinction is important, that even if the synchronization is successful, your application could still be unhealthy. Now that we understand what a sync operation in Argo CD is, let's talk about what are sync phases. Now, when you clear an interview, you just say, I have cleared the interview. But in clearing the interview, there were so many phases involved. There would have been a phase where you decided, I want to switch my job. Second phase would have been preparing a roadmap for yourself, then working on that roadmap, and then finally doing some revision and appearing for the interview. So when you cleared the interview, clearing the interview is an umbrella term, and that umbrella term had different phases. Similarly, synchronization is a process which has different phases underneath. So in this lecture, we'll be understanding what these sync phases are and then what are hooks. And we will also dissect what is the relationship between these two. So sync phases are named execution stages that represent where Argo CD is during a sync operation. So execution sequence defines execution boundaries, such as these are the sync phases for you: pre-sync, sync, post-sync, and sync fails. And all of these are quite self-explanatory. This is before the sync begins, this is during the sync, this is after the sync, and this is when the sync fails. So these phases are understood. And then the next part is resource application. The sync phase applies standard Kubernetes manifests to the cluster, and we know that from our previous discussion that whatever manifests are there in your Git, the sync operation will apply all those manifests to your live cluster. The next part is what is hook. And let me tell you, why are we studying sync phases? We are studying sync phases so that we can discuss hooks in a proper way. If hooks did not exist, then we wouldn't be studying sync phases, because for us, as long as synchronization worked, we were happy. But when you synchronize something, there are few more things that you might want to take care of, which is why hooks were introduced. Now, a hook is a Kubernetes resource. Now, this is important. It's a Kubernetes resource. It can be native or it can be custom, that Argo CD handles differently from normal reconciliation to run conditional or one-time logic. Now, there are 6 hook types that we are going to discuss, and you can also call them as hook names, which are pre-sync, sync, post-sync, SyncFail, post-delete, and skip. I want you to pay close attention. There is a hook named after all of these sync phases. So now I want you to create a mental picture along with me. A pre-sync hook will be running in the pre-sync phase. A sync hook will be running when the synchronization is happening. A post-sync hook will run once the synchronization has completed. A SyncFail hook will run if the synchronization for XYZ reason fails. What is post-delete? Now, post-delete and skip, these two are the hooks that do not directly relate to synchronization phases. So what will post-delete do is, post-delete will take effect if the application CRD itself is deleted. Skip hook. Now, a lot of folks think skip hook can be used to skip a specific manifest from your Git repo. So maybe there are 10 manifests and you do not want to apply the config map manifest. In that scenario, you can use skip hook to skip that manifest, but it does not work like that. Skip hook is used to skip a hook itself. Now, what does that mean? We will see later. But for now, I want this concept to be there in your mind, that skip is not used to skip the creation of resources. Skip is used to skip a hook itself. For example, a skip in a pre-sync hook will say, do not apply the pre-sync hook. Not to worry, if things are hazy, we will be dissecting this step by step, inch by inch. Next is task execution. Hooks are used for tasks like database migration, prerequisite checks, smoke tests, or cleanup. And we will be seeing that in the next part. So now that we have this basic high level understanding, let's move to the next section where we will understand more about sync phases and hooks. Argo CD sync lifecycle, phases versus hooks. So first, let's see what is happening in this diagram. So these can be thought of as two different diagrams. At the very top, I am showing Argo CD phases. We have just studied these: pre-sync phase, sync phase, and post-sync phase. These three are the main. And then if the sync fails, there is also a sync fail phase. And at the bottom, I am showing Argo CD hooks. Now, understand that these Argo CD hooks like pre-sync, sync, they are named after the sync phases because it is during that phase that hook type is applied or that hook name is applied, which is why they are named after Argo CD phases. So pre-sync hook, sync hook, and then if there is a sync failure, for example, then you have a sync fail hook. And then if the sync is a success, only then post sync hook is applied. And then, as we learned before, there are two more hooks like skip hook and post delete hook. And here you can see what can be used as a hook. Now understand, as I said before, hooks are Kubernetes resources, native or custom. So what can be used as a hook? A hook can be a Kubernetes job, which is the most common. So for example, if you are already aware of Kubernetes jobs, and if you are not, I would link a video which you can watch to have more understanding about jobs. Now, when we talk about using a Kubernetes resource as a hook, jobs are the most famous ones because jobs are something that can be used to perform certain actions when you want to perform certain actions. But do not limit your imagination. You can use any Kubernetes resource, be it native or custom, but jobs are the most common, and any Kubernetes resource, native or custom. And then also Argo CD workflows, which we will see later in this course. So for now, just understand this part. This is quite self-explanatory. Phase is where Argo CD is in the synchronization lifecycle, like pre-sync, sync, sync fail, or post-sync. Hook is where user defined action at that point. So for example, before the synchronization happens, I want to do something that is defined by the pre-sync hook. During the synchronization process, I want to do something that is defined by the sync hook. When the synchronization fails, I want to do something, and that something is defined by the sync fail hook, and so on. So let's talk about pre-sync hook. Runs pre-sync checks. Now, when would you use this? Maybe you want to perform DB migrations. For example, before I have my pods running, I want to prepare my database. I want to do some migration and so on. I want to maybe change the schema or do something of that sort. In that scenario, you can use pre-sync hook. Now, I know there is someone who is thinking, Varun, we can use init containers for that, can't we? And of course you can, but understand, when init containers finish successfully, only then the main container starts. Here we are limited to a pod, but what PreSync is saying, even when the entire manifest that is defined in your Git repository can be applied, before that there must be certain checks, and these are defining that. So init containers are defining when to start the pod, when to start the main container, whereas PreSync hook here is deciding what to do when any of the manifests are created. So for example, maybe I want to check that my cluster must be running version 1.33 or higher to apply these manifests. I cannot achieve that using init containers. Maybe I can, but that's not a good choice here. What I want is any resources defined in my Git must not be created until a PreSync hook succeeds. Now, like I said, you could be checking the Kubernetes version here. You could be checking whether the node groups that you wanted are available or XYZ. I will let you figure that out. And here is the job YAML. I don't want you to concentrate on the part that is Kubernetes specific, but I want you to concentrate on annotations. And we understand that annotations are just for informational purposes, and whatever is defined in your annotations can be consumed by humans or different tools. For example, right now, whatever I have annotated in my job manifest can be read by Argo CD, and then Argo CD, based on whatever annotations I have defined, can take actions. And what those actions are, the action that will be defined in this job will be that action. Maybe I want to perform a DB migration, and only when DB migration is successful, I move from PreSync to the next phase. Understand, hook failure stops sync. Remaining hooks are skipped. If your PreSync hook fails, then sync hook won't be applied. And if the PreSync hook fails, the next phase will not be triggered. So create that mental picture in your head. Now let's see what these annotations are. So Argo CD, Argo project IO / hook. This is a PreSync hook, which is why we have a PreSync here. A SyncFail hook will have SyncFail, and PostSync hook will have PostSync, and so on. And then I'm saying hook delete policy. And there are two policies I have defined here before hook creation. So what I'm saying is, even before the hook gets created, you delete if there is any existing hook with the same name. And I'm saying when the hook succeeds, you then also delete this job object. And Varun, why are we deleting this job object? I don't want my cluster to have resources that are not needed. If I have already performed my PreSync prerequisites, that is, let's say, DB migration, then why would I want that job to remain in my cluster? Why would I want a successfully completed job to remain in my cluster? Which is why I am defining this. If the hook succeeds, then you delete this resource, delete this job. And if for any reason this job fails or this hook fails, in that scenario, that job would be there in your cluster so that you can check the logs and see why the failure occurred to begin with. Now let's discuss sync hook. Honest confession, I could not find a use case for sync hook. If you can tell me a use case where sync hooks can only be used, not PreSync or PostSync. Any task that you feel can only be done by sync hook, you let me know. That is why I have written here rarely used in practice. I have used the word rarely to be a little humble, but I couldn't find a use case to use sync hooks. Anyway, let's move to the next one. SyncFail hook executes only when sync fails. Understood. Use cases, log collection, failure notifications, and so on. So for example, if let's say your sync fails, I want my admins to be notified. You can do that using SyncFail hook. Next one is PostSync hook. Understand, PostSync hook will only be applied if you are in the post sync phase. If you are in the sync phase and then sync phase has completed successfully, only then post sync hook will be applied. If your synchronization has failed, then post sync won't be applied. So validates deployment outcome after rollout. Now this can be implementation. Do not get confused by Kubernetes deployment here. This is just saying if everything is applied successfully, only then post sync hook will do its job. And what are the use cases for this? Maybe once everything is applied, I want to quickly check whether my application is accessible over a URL or not. That something can be performed by post sync hooks. Skip hooks and post delete hooks we have already discussed. For skip hooks, I have a demo for you. Post delete implies that we will be doing this once an application CRD is deleted, once Argo CD application is deleted. Now with all this understanding, let's go to the demo. So I'll go to my GitHub repository first. I will zoom in a little. I'll go to Argo CD basics and production. And if you are finding this repository helpful, I would request you to please star this repository. So I'll go here and then I will go to lecture 6, that is sync phases and hooks. And from here, I have clickable table of contents. Here I can directly go to demo sync hooks in Argo CD. Firstly, there are certain prerequisites. You should have Argo CD up and running. And if it is up and running, you are running it as a container like we did, then you should also be port forwarding. So let me also run this. I'll go to the terminal and here I will start the port forwarding so that I can access the Argo CD UI. So I will write localhost and it is 8080. I'll go here and you can see Argo CD is accessible. I will enter my credentials and then it has logged me in. So I don't have anything deployed in here. I do not have any applications created just yet. So I'll go here again. Then what we are demonstrating. So we will be demoing pre-sync hook, post-sync hook, and then a skip hook. Now I want to walk you through the repository structure that I am using. So first I will show you the directory structure that I have in my Visual Studio Code, and exactly like that we'll be creating different repositories. Now I am using the repositories that I created in the previous lecture. Both of these are public repos. You can create them in a fly. So let's go to my Visual Studio Code here so that I can show you the repository structure. So I have zero sync, sync phases, hooks, and here are all the directories that we would be using. So let me do one thing. Let me go to item, go here and run tree for you. So this will give me a better view for my directories. So I have app1 backend and this has my application code and the Docker file. Similarly, app1 frontend will have my frontend code and then the Docker file that is used to create the container image for frontend. Then I have app1 backend config. Understand that when you are doing GitOps, it is preferred that you separate different repositories. That is exactly what we are doing. I will not go into details because we have discussed this in our previous lectures already. So in the app backend config, we will be storing the configuration files associated with app1 backend. So you have a Argo directory in here and a backend directory. Argo directory has my application CRD because we know that everything must be version controlled when we are adhering to GitOps methodologies. Then I have a backend here, and here I have a deployment YAML, a service YAML, and a PreSync hook YAML. Similarly, the front end config has all of these things, but for front end specifically. we are defining a pre-sync hook for backend and a post-sync hook for frontend. So this structure is understood and we have already seen this in our previous lecture. So if I go to my browser, then I have two public repositories created here, app1 frontend config and app1 backend config. Both of these repositories as of now does not have anything stored, and we'll be storing things into this as we progress with this demo. So if I go to a repository for this lecture, then you will see there is a step 0.5 which talks about building and pushing container images. So I already have this in place. If you do not, then you will have to run this. But before running, ensure you change this to your own Docker Hub account, and this will only work if you have Docker desktop logged in. So if I go here, I go to my dashboard, then you see I have already logged in via cloud with Varjosh. And if you have logged in into your Docker Hub account in your Docker desktop, only then these commands will run. And ensure you run them by going into the app1 frontend directory. And where is this? You can find this in the lecture notes itself. All of these, whatever files that I am using for this demo, all of them can be found in the repository for this lecture. Now let me go back here. I lost that. I'll go here, and yeah. So ensure that you have this. And once you enter your own account here, I also want you to ensure that in Visual Studio Code, when you expand the config repo in the backend in the deployment manifest, you mention your Docker Hub account, because your Docker Hub account will be holding the container image. Another thing is, for some time maybe this image will exist in my Docker Hub, but maybe at some point I might delete it. So in that scenario, if you are directly applying this manifest, this may not work. So keep these basics in mind whenever you are doing this demo with me. So let's now go to our browser and see what is that we want to do next. So let's start with the demo. So firstly, if you see my manifest, if I go to deploy, we are creating all these in application1 namespace, because as we know, our resources must be contained in their respective namespaces, and it is a best practice to logically segregate resources into your specific namespaces. Again, this is a simple two-tier application. I will let you go through the code and the manifest to understand the application better. Having said that, if you watch the previous lecture where we discussed Argo CD projects, in that lecture, we discussed in detail what this two-tier application is all about. Now, let's get started with our demo. So here I will first run kubectl create namespace app1 ns, and right now I'm creating this namespace manually, and later in the course we'll automate this part as well. So now our namespace is created. Now let's directly talk about our pre-sync hook. So as we know, pre-sync hooks are applied just before the synchronization, that is during the pre-sync phase, and we have a simple job YAML. We are calling it pre-sync db migration. We are creating this job as well in the application1 namespace. Annotations, this is a pre-sync hook, which is why in the hook type I have pre-sync, and the hook delete policy I'm saying is hook succeeded. So if this job completes successfully, then I want you to delete this job. Then there is containers. Here I am saying this is the important piece. What I'm saying is invoke a shell. Then I'm saying execute the following string as commands. And what you see here, this is called a YAML block indicator that allows multiple lines to be passed as a single script, and that is what we are doing here. We are saying echo running db migrations, echo migration completed successfully, and once this container will complete successfully, it won't be restarted because we have restart policy never. And again, once it runs both these commands, the container will be in completed state, as in the hook will be successful. And once the hook succeeds, the job will be deleted. So we have walked through the sync hook YAML. Now I also want you to walk through I go to front end, post sync hook. So post sync hook is also similar, if not same. These parts you already understand. We are naming it accordingly. But here is what is different. Now, what we are saying in the post sync hook is you only mark this as completed successfully when I am able to access front end SVC on port 80. And we are creating a front end service which listens on port 80. So if I go to this YAML, you see there is front end SVC that listens on port 80. This is the cluster IP service port. And that is what we are saying. So this will also finish successfully. So let's see what we want to do next. Now we have this structure already. Now let's do one thing. I'll go to my browser and now I will add the front end manifests here and also the back end manifests here. So I will go here and then let me do one thing. Let me minimize this. I'll click on add files, upload files, and then I will go here. I will drop these, whatever is there in the front end here. And then I will commit this. And if I go to backend, I will do the same for backend. Upload files, and I'll go here. I'll go one step back, and this is my backend config. I will copy these and I will drag them here. And here as well, I will commit my changes directly to the main branch. And all the files that are needed are there in my repository. Now I have not created the repositories for my code. If you want, you can also do that, but at this stage it is not something that is needed. I will full screen this. Now let's apply our Argo CD application. So I will go to my Visual Studio Code and I will go to Argo CD and I want to show you the backend application manifest. So this is my application manifest. What I want you to pay attention is it is looking at my app1 backend config and destination is namespace is app1 namespace, and this is the cluster that we are dealing with. The important part is I have removed the automated sync part from here. And why I have done that? I have done that so that I can show you the jobs appear and go based on our will, not based on automated synchronization. So we'll manually press synchronization, clearly monitor, and then give a go ahead to the demo. So I'll go here, I'll right click here, open in integrated terminal. I will run kubectl apply -f, and I only have one YAML here. I'll click here. So the Argo CD application for backend is created. I will do the similar for front end as well. So open in integrated terminal, kubectl apply -f, and I will apply this YAML as well. Now if I go to my browser and I go to Argo CD, you see that both of these things are here. It says out of sync for both of these, and that is obvious. Understand that right now what is happening is, let me refresh this. I'll tell you what this refresh will do. There are three things. There is a refresh, there is synchronization, and then there is application health. So when I talk about refresh, Argo CD by default checks your Git repos approximately every 3 minutes to see if there are any new objects or if there are any changes to the existing objects. It will see all those things, and that process happens every 3 minutes, approximately 3 minutes. And if you click on refresh, it will immediately check whether there are any changes in the Git repo or any additions in the Git repo. And it did that, and right now it is saying out of sync because our repositories have manifests, both backend and front end. They have manifests, but those manifests are not applied in my cluster. Hence, the desired state is not matching the current state. So let's do one thing. Let's synchronize these apps one by one and then see what happens. So let's first go to backend, and I want to revise what was there in the backend. So if I go to backend had a pre-sync hook. So what should ideally happen is a job should be created, and only when that job successfully completes, then we should go to the next step, that is synchronization. So let's go here. I will click on sync, and I want you to pay clear attention. I will hit sync, I will run synchronize, and you see a pre-sync DB migration is created first. This completes, this will be deleted, it is deleted, and only after that the synchronization process completes. Only after that the YAMLs are applied. So if I go to my cluster right now, if I go to my terminal, I run kubectl get all hyphen n, and then the namespace name is app1ns, then you see both of these are created. There is a service created for us, and then there is a deployment also created for us. I hope this is understood. Now let's do the same for our front end, but in front end we have a post sync hook. Now what it is saying, once the manifests associated with front end are applied successfully, only then run this hook. Previously, before the synchronization, we were running the pre-sync hook. Now we are running the post sync hook. So let's go to our browser, and here I will go to app1 front end, and then I will click on synchronize, and they are applied first, you see, and then you see front end smoke test. This will be checking whether our service is reachable or not, and when it sees it does, it deletes the job automatically, because we have said once the hook succeeds, you delete the job. That is governed by our hook delete policy. I hope this makes sense, and if you have that mental picture already there, then this is pretty easy to understand in my opinion. So I'll exit this, I will exit this as well, and then let's do a demo for skip as well. So I will go to my browser. Okay, let's do one thing. Let's go to our front end, that is where we applied changes right now, and let's run a skip hook. Now let's say you are troubleshooting something because of which your service is not running, and you don't want your hooks to be interfering in whatever you are doing. Not a good use case right now, but what I want you to take away is what a skip hook will do. A skip hook will ensure that a pre-sync or a post-sync hook, wherever the skip hook is applied, that hook is skipped altogether. So right now I am in front end config. I'll go to front end, and here I will go to this part, and we saw that when we were running this hook here, when we were synchronizing front end, the front end hook ran post sync and it disappeared. The job went away because of our deletion policy. Now let's define a skip hook and then see whether the post sync hook is applied or not when we skip that. Ideally, it should not. So I will go right here. I will click on edit. And what I will do is I will copy this one. I will paste this here, and here I will just write skip. And one more thing, you can also have multiple hooks within this. Okay, you can have post sync and pre-sync, as in this job, whatever defines, should also be run pre-sync and post sync. So that is also available, but you cannot combine post sync and skip, and for obvious reasons, right? And then I will commit this and let Copilot detect fix duplicate hook annotation. So this is duplicate in its opinion, but it is annotation, so it does not really matter. So I have this here. Now, if I go back to my Argo CD, now this is saying synced because it is not checking my latest commit. So approximately, like I told you, after 3 minutes, it checks. But to force that check, let's hit refresh first. And once I do that, you see it checked and it is there. So let's run a synchronization and let's click on synchronize. And this one did not run because we have added skip here. So it did not run altogether because we asked it to skip this hook. I think that is all I wanted to cover in this lecture. You should now have a clear understanding of what a sync really is, how sync phases structure the life cycle, and how hooks add controlled behavior around that life cycle in Argo CD. We saw how phases and hooks differ, how failures propagate, and why hooks like skip and post delete behave differently from phase based hooks. Finally, we validated all this through a hands on demo, observing real sync behavior instead of relying on assumptions. This lecture intentionally focused on lifecycle control, not ordering. In the next lecture, we will build directly on this foundation and introduce sync waves, where we solve ordering problems inside the sync phase itself. If you have any questions, feel free to drop them in the comments. And if this lecture helped you, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi, and welcome to the seventh lecture of our Argo CD Basics to Production course. In this lecture, we will break down Argo CD sync waves by first understanding how Kubernetes resources are created and applied, and why default ordering is often not enough in real world deployments. We will then look at why sync waves exist, what problem they are designed to solve, and what sync waves actually are from an Argo CD lifestyle perspective. Finally, we will walk through a hands on demo where we will use Argo CD sync waves to control the creation order of Kubernetes resources and observe the behavior in real Argo CD application. So let's get started. And before I start, if you are new to this channel, we cover everything DevOps and cloud related. If you are already familiar with this channel and you have not subscribed to it, I would request you to please do that. And if you see that hype button down below, then do press that too. And it goes without saying, if you are finding the content helpful, then do like the videos and comment how you feel about the lecture. So let's get started. How Kubernetes resources are created and applied. There are two execution models for applying Kubernetes resources, with the API server as the final entry point in both. And we understand this very well. Whenever humans, tools, or anything in this planet Earth or even outside wants to communicate with our Kubernetes cluster, the entry point will always be the API server. Now, how you interact with API server is via REST. So Kubernetes exposes APIs, and those APIs can be accessed over REST. Now, any tool that you are using to interact with the cluster underneath would be using REST APIs to communicate with your cluster. So for example, if you are using kubectl client, under the hood kubectl client is sending your requests as REST, because that is what the API server understands. So now that we understand this part, let's talk about the execution models. And in our CK course and in general, when you are interacting with your Kubernetes cluster, it is kubectl client that you use to interact with your cluster. Now, kubectl directly is not the only means via which you can interact with your cluster, but yes, humans will typically tend to use the kubectl client, but there are other means as well. So you can directly communicate with your cluster via a REST API. And if I talk about Argo CD, Argo CD also interacts with your Kubernetes cluster, but it does not use kubectl under the hood. It directly interacts with the cluster using the REST APIs. Now let's understand what happens. Client submits manifests directly to the Kubernetes API server. Second point is each object is persisted independently, and we know that. So if you are creating a deployment, or if you are creating a network policy, or whatever object you are creating, they get persisted in HCD independently with no orchestration or logical sequencing. So we are talking about the kubectl client. So to zoom in into this point, let's first go to Visual Studio Code. So I'll go here, and then I will expand this lectures directory. I will go to test1.yaml here. Now what you see here is a simple deployment manifest, and here is a simple namespace manifest. So we are creating a deployment and we are creating a namespace. So let's go to our terminal, and from here I will run ls, and you see test1 exists here. I will run kubectl apply -f, and then I will write test1.yaml. I'll press enter. It says the namespace got created, but there is an error when it comes to creating a deployment, and it says namespace this does not exist. Now why this happened? Whenever you are using kubectl client and you have defined your resources within a single manifest file in a specific sequence, so in this sequence deployment comes first and then comes the namespace. In this scenario, kubectl will always adhere to a sequence, and although that sequence is not logical, because what we would want is we would want the namespace to first get created, and then the resource that is supposed to be living in that namespace. But it does not work like that when I speak about kubectl. Kubectl adheres to the sequence that is defined within the manifest. So in this manifest, the sequence was first create a deployment and then create a namespace. So first, when it tried to do this, it errored out, but then when it came to this part, it implemented that correctly, which is why you see here the deployment was not created, but the namespace was created. Now let's do one thing. Kubectl delete -f test1.yaml, and this will delete, and of course the deployment didn't exist, which is why this failed, and the namespace was deleted successfully. Let's now do one thing. Let's cut this part, okay, and then we will paste this at the very top. So I'll come here, and then I will paste this here. I'll come down, add the YAML separator, which is 3 hyphens, and then I will save this file. And now if I come here and apply the same YAML again, it will apply successfully, because now when it goes to create the deployment, it sees that the namespace already exists. So it works like that. Now sequencing works in this fashion. By default, when I talk about the kubectl client, now let's understand one more thing. It is not that always your resources will be defined within a single YAML. You could have multiple files where your resources are defined. For example, 1.yaml can have your deployment, 2.yaml can have your namespace, and so on. In that scenario, the sequencing will be based on the name of the files. The first 1.yaml will be applied, then 2.yaml will be applied, then 3.yaml will be applied, and so on. So that sequence is maintained. For example, let's say test1.yaml has my namespace and test2.yaml has my deployment YAML. In this scenario, first test1.yaml will be applied, so a namespace will be created, and then test2.yaml will be applied, and this deployment manifest will be created. But if in test1.yaml I have deployment, so let's do that. If I copy this and I paste it here, and then let me take out the namespace YAML from here, I will cut this and then I will paste it in test2.yaml. Now what should happen is, like we know, it will adhere to the sequencing when you are applying multiple manifests together. it will first apply test1.yaml, then test2.yaml. And this will also error out because the deployment will say, I do not find the namespace anywhere. So let's do that. So I'll go here to my terminal and I will again, let's say kubectl delete hyphen namespace, and the namespace I want to delete is app1ns. So first let me delete this, and then what I will do is let me also move both of these manifests to a folder. So I'll call this manifests, for example, and then let me copy these and paste it into the manifest directory. So I'll paste them here, and then if I go to my terminal and I run kubectl apply -f, and then it asks me which directory you want to apply. Let's say I say manifest, and I want to apply everything that is there in the manifest directory. I press enter, and you see the namespace was created and this was not created because there is a specific sequence that kubectl uses when it is creating resources. So we have understood the default behavior. When I talk about kubectl, it applies based on the sequence. If everything is defined in single YAML, then it will see the sequence in which the resources are defined. If the resources are split across multiple manifests, it will sequence them based on their naming. So that part we have understood. Now let me do one thing. Let me delete this. Now with this understanding, let's come back to the diagrams and see how resources are created using Argo CD. Now understand why we are bifurcating this into two. I said there are two execution models. First is kubectl, how kubectl interacts with your cluster, and then second is your custom behavior. And within custom, it is up to you. For example, if you are directly using REST, it is your call how you want the sequence to be, and that sequence must be defined by you as an administrator. Similarly, if I talk about Argo CD, Argo CD also has an ordering system in place which dictates how resources are created. And we very well understand that the kubectl client by default does not have means in which it can create resources logically. We want that if my deployment depends on the namespace, then the namespace must exist before the deployment YAML is applied. And if it does not adhere to that, which we saw kubectl does not adhere to that, in that scenario our deployment creation failed because the namespace it depended on, or the namespace in which the deployment pods were supposed to reside, was not in place. So the gist is kubectl is just one of many clients. Kubernetes is fundamentally an API driven system, and any authorized tool capable of making REST calls can interact with the cluster. So when you use kubectl, Jenkins, Argo CD, client libraries like Go, Python, Java, etc., or even custom platforms, every interaction ultimately becomes a REST request to the Kube API server. Now let's discuss the sequencing or ordering that Argo CD adheres to. Argo CD evaluates all manifests upfront and computes a deterministic execution plan. So if there are 10 manifests you have thrown to Argo CD, Argo CD will ensure that any of the dependencies, rather explicit dependencies, and we will see what is the difference between explicit and implicit dependencies later. But Argo CD, when sees that the deployment is defining, it requires a namespace, it requires a service account, it requires a config map, it requires a secret. Argo CD will ensure that those resources are created before the deployment manifest is applied. It does not care in which order you have defined the resources. Argo CD in itself has an inbuilt logic which ensures that the resources are sent to the API server in such a way that results in API correctness, that ensures the resources are created. So for example, if your deployment depends on config map, that config map is applied first and then the deployment is created, which is logical. It is better than the kubectl client's behavior. So let's read these points again. Argo CD evaluates all manifests upfront and computes a deterministic execution plan. For example, I have 10 manifests. I will be applying them in this sequence so that all of them are applied correctly. And what do I mean by applied correctly? I mean that whatever I run should result in this created, in something else created. So all of those objects must result in created. That is what Argo CD ensures. Default Argo CD ordering ensures API correctness, not runtime readiness or intent. And we will be dissecting this as we progress with this lecture. So now we have this basic understanding on how resources are created. Let's deep dive into this part. So resources created using Argo CD, control plane driven model. When Argo CD starts a sync, it orders the resources in the following precedence. For now, I want you to ignore the first one, that is phase. And I also want you to ignore the second one, which is sync waves, which is the topic for this lecture. So first we will see how the default ordering works in Argo CD and what are the ways in which you can manipulate that behavior. So let's talk about third, that is a resource kind. So what Argo CD will do is, the resource kind ordering implies that the ordering will be done based on the kind of the resources. And when I say kind, I mean this, the kind field that is available in all of your manifests, be it your custom resources or be it your default resources that are available at your disposal when you first create the cluster. So let's go back here and understand this resource kind. So first it will create namespaces, then it will create custom resource definitions, because you cannot create custom resources, be it namespaced or be it cluster scoped, until and unless the CRDs that are supposed to be used by those custom resources are in place. So first precedence is namespaces, then custom resource definitions, then other cluster scoped resources, and finally namespaced resources of various kinds. For example, config maps, secrets, service accounts, workloads, services, etc. So what we understand is, when it comes to the default ordering, first it is ordered based on kind, and then the last precedence is given to the resource name. So for example, if we are supposed to create 3 deployments and one starts with the name A and second with B and third with C, then it will first apply the deployment that is named with A and then B and then finally C. So it adheres to the resource names at the very last. Now you must be saying, Varun, this is awesome. kubectl client didn't have any intelligence, but Argo CD in here is quite intelligent. It will create my resources in such a way that there are no errors, because Argo CD aims for API correctness. It aims for this message that we saw here, the resource is created. It will prohibit this sort of behavior where the application results in error. Now, why is this? This is because Argo CD ensures that the dependencies are first deployed and then the resource is created, which is what we want. But is this all that we want? Let's see what else do we want in the next section. And the next section is appropriately called Why Sync Waves Exist. Now, there are limitations of the Argo CD's default ordering. And let's say what are those limitations. First is Default ordering ensures API success, not intent. So we understand that it ensures that the resources are created. It thrives for this message that resource is created, but not intent. And what we mean by that, we will see in a little while. Namespaced resources are treated as peers within a sync lifecycle. So anything that is namespaced, for example, here, the fourth block, all of these will be applied simultaneously. Of course, the implicit dependencies are maintained, but there could be race conditions, and we will see what those race conditions are in a little while. But before we do that, I want to tell you one important thing. This resource ordering, when I talk about this, if I go to my browser and I search for sync waves Argo CD, I'll go to the official documentation here, and then I will scroll down to, I'll zoom in a little, and then I will scroll down to sync waves here. And if I talk about sync waves, and they have given the same thing, the precedence is the phase, the wave they are in, by kind and by name. Understand, they have not strictly given the exact order in which the resources are applied, but I want you to understand that explicit dependencies are always catered. What are explicit dependencies? If I go to my manifest, I'll go here, I will go to this one, and then I will expand config, and let me go to deploy. So if I go to this deployment YAML, what I see is this requires a service account, and it is explicit because my deployment YAML has defined this service account. Another thing is, it is using a config map, and that config map is mapped as a volume. So that part is also explicitly defined. I am using a secret, and that is also explicitly defined here. So anything that are explicitly defined in your deployment YAML will automatically be created by Argo CD beforehand, and only then the deployment manifest will be applied. And this is what we want. We want anything on which my deployment depends should be created first. So here, these all are explicit dependencies. Then what are implicit dependencies, Varun? And before I answer that question, let me tell you, it is because of implicit dependencies we want something like Argo CD. Why, Varun? And what are implicit dependencies? What about resource quotas? I am also creating a resource quota, which is a namespaced scoped object. How do I ensure that the resource quota exists before the deployment is created? Because we do not have a resource quota field in deployment, which is why resource quotas are implicit dependencies in this scenario. Because what I am saying is, I want the resource quota to be there first, and then only create the deployment. And not just this, I also want, if I am applying a network policy, my deployment does not depend on network policy. As you can see, the deployment YAML does not have a network policy field. It just works on labels and selectors when I talk about network policies. And if I am creating a network policy after the deployment, then is there a point in that? Because my security teams won't be happy, because for brief amount of time, my deployment, the pods resulting from my deployment will be able to communicate with anyone, because the network policy YAML has not been applied yet. What I want is, there should be an order in which the resources must be created. And I understand that there is a default order with Argo CD, but I also want implicit dependencies to be created beforehand, so that I can have full control on how resources are created, in which sequence the resources are created. Now that we have this understanding, let's go to our diagrams again. And I forgot why I opened this tab here. I want to tell you that whatever ordering that we are discussing, Argo CD has not been explicit about this in their documentation. Okay, when I wrote this ordering sequence here, this one, they are not saying anywhere that CRDs are created before and namespaced resources are created simultaneously, and then other cluster scoped resources are created before this. This is something that I have tried, tested, and then observed. The documentation does not explicitly mention this. Now, of course, this list is not complete. There could be many things here. We all know that when we talk about explicit dependencies like config maps, secrets, service accounts, these will be created before the deployment by Argo CD itself. But when I talk about services, services are also implicit dependencies, resource quotas, network policies. We don't want a condition where these resources are also created after the deployment. We want these resources like network policies, like resource quotas, like limit range. All of these should be created before the workloads are deployed or before the deployment is created. Now let's see rest of the points. Namespaced resources are treated as peers within a sync cycle, and this part we already understand. Explicit dependencies are enforced, implicit dependencies are ignored by default, and it is because of implicit dependencies that we have sync waves in practice. Next point is sync waves exist to enforce implicit dependencies explicitly, so that you tell Argo CD that, hey Argo CD, you must create my network policy before you create the deployment, you must create my resource quota before you create my deployment, and so on. So for implicit dependencies you have this. Examples: network policy versus deployment. We have already seen that we want network policy to be created before deployment, we want resource quota to be created before deployment. Backend versus front end. And here is another problem. Let's say you have a single repository for your configuration, and that repository is holding all your backend and front end YAMLs. You want everything backend to be deployed first, and only then you must proceed to front end. And that is something that you cannot natively achieve via Argo CD's default behavior, because understand, the ordering is based on this. There is a possibility that front-end deployment is created before based on the nomenclature you have used, and after that the backend is created, and you don't want that. You want the backend YAMLs to be applied first, and only then the front-end YAMLs to be applied. And all of these things can be achieved when you are using sync waves. Now that we completely thoroughly understand why sync waves exist, let's see what sync waves actually are. Sync waves define an explicit integer based ordering for applying Kubernetes resources within a lifecycle phase of an Argo CD application. And the plain English for this we'll be dissecting as we move with this section. So first line is provide administrator defined resource ordering within a phase, not across phases. Now first I want you to understand that when I talk about precedence, the first precedence is given to phases. So for example, if I have a pre-sync, then whatever is defined in the pre-sync hook or in the pre-sync phase is applied first, even if there is a YAML that has a highest priority when I talk about the numbering. So for example, if I talk about wave numbering, the lowest number has the highest priority. So if you see this diagram, -99 has the highest priority for application. But when I talk about pre-sync phase, the highest precedence is given to the phase first. So when I have pre-sync hooks being used, and within that pre-sync hook, first it is seen which YAML must be applied first, and based on that the resources are created. So first precedence is phases, and second is sync wave. So first in the hooks we see which wave has the highest precedence. So for example, in PreSync, wave -5, and then wave -2, then wave 1, and then wave 8. And this is the diagram that I have taken directly from Argo CD's documentation. Then uses integer based wave annotations, and you can see here I have used an example where I am using -1, and you can have any sort of numbering here, and we'll see this more when we move to the demo section. Next is enforces tiered application of resources, and that is what we want. We want my network policy, my namespace YAMLs, and all of these to be first created, and at the very last I want my deployment to be created, or any of the resource to be created. So you can define that ordering based on your subjective requirements via sync waves. Operates within a single application scope, and this is important point. So if you have multiple Argo CD applications, it is not that you can define these sync waves across those applications. You can define sync waves within an Argo CD application, and we understand what Argo CD application is. Next is complements default kind and name ordering. Of course, let's say you have certain YAMLs where you have not defined sync waves at all. In that scenario, first preference will be given to sync hooks, then to sync waves, and then if there are YAMLs that do not define, then resource kind and resource names would be used to define the precedence in which the resources are created. Again, a lot of folks get confused between the first 2 points. I want you to clearly understand, when you have a pre-sync hook, that pre-sync hook will always be first applied. But within that pre-sync hook, what are the YAMLs which have the highest priority is defined by the sync wave numbering. So understanding this point is critical. So now let's reread this definition so that all the points get connected. Sync waves define an explicit integer based ordering, and this is the integer based ordering, or this is the integer based ordering that you see here, for applying Kubernetes resources within a lifecycle phase. So when in pre-sync phase, or when you are using pre-sync hook, all the YAMLs will be analyzed, and based on their numbering, that is lower values come first, they are applied of an Argo CD application. So I hope all these points are clear to you. With this understanding, let's move to the demo. So I'll first move to my browser, and then I will go to my repository here. If any of these repos are helping you, I would request you to please star these repos. It really helps spread the word. So I will go to Argo CD basics to production, and then I will go to 07 sync waves. All what we are discussing is written in these notes. All the YAMLs that I would be using are uploaded here. So for now, I will first go to this one, demo. Now, what are we going to do in this demo? Firstly, we will understand how explicit and implicit dependencies work, and we will see that using examples. We will be creating an application that uses all of these resources: namespace, resource quota, service account, secret, config map, service, and finally a deployment. And then we will be ordering them in such a way that they are created in that sequence. If you see here, we will be first creating the namespace, resource quota, service account, and secrets. All of these will be sent to the API server simultaneously, and how API server creates them, it is its responsibility. It is the race condition. So when three are fighting for a spot to be applied first, then API server will apply any of these based on whoever arrived to the API server first. So we are saying apply all of these together, and we know none of these depend on each other, so it is okay. So no explicit dependency and no implicit dependency either. Then I am saying create a config map. Config map has a wave numbering of 0. Then we are creating a service which has sync wave 1, and then deployment finally has sync wave 5. Now some of you might be thinking why there is a gap between 1 and 5. So the gap in sync wave values is because there could be other YAMLs, other objects that you could be introducing later in your implementation. For that reason I have left this space. And in production implementations, always do your due diligence, always leave room for future growth, so that if there are other things coming in, other resources coming in, you can decide appropriate number for them as well. Again, I have also mentioned here implicit and implicit, because all of these dependencies that are explicit in nature, you will see all of these defined in deployment. So Argo CD anyway will be applying these first before it creates the deployment. But when it comes to service and when it comes to resource quota, both of these we want to be created before the workloads are created. That is why we have explicitly defined a wave number for our implicit dependencies. I hope things are getting connected for you. Now there are two prerequisites for this demo. First is you must have Argo CD implementation. So if you have installed Argo CD based on our lecture 2, which is this one, architecture and install, then do not forget to port forward. So I will also copy this and then I will come to my terminal, this terminal. Oh, it is already port forwarding. So if I go to my browser again, then my Argo CD instance should already be, yeah. So my UI is working correctly for Argo CD. Ensure yours works too. And then you open the UI and check it. Then the second prerequisite is I want a clean demo. So if you have an existing app1 namespace, then ensure you delete that namespace. So first, let's go to our Visual Studio Code and understand what are the manifests that we are going to deal with. So first I will do one thing. I will just delete this manifest directory from here. And then I have app1 config here. App1 config has two directories. One is Argo and second is config. Argo has my application CRD, that is the Argo CD application that we will be creating. So let's go through that as well. So what I'm saying is this is the source I want you to connect to, and then this is the destination. So destination is the Kubernetes cluster that we have right now, our kind cluster, and the source is app1 config. I will be creating a repository in my GitHub which is named app1 config, and then I will be uploading everything that is there in app1 config in that repository. Ensure if you are using your personal repository, which I hope you are using, then you will also have to change your account name in this application manifest. I'm saying path is equal to config because my manifests that are to be applied by Argo CD are kept in this directory that is named config, which is why I have named config. And config will exist right in the root of my repository, which is why I just have config mentioned here. So keep these nuances in your mind. Now let's see what all I have in my config directory. First is we are creating a namespace, and the numbering is exactly like we have defined here. Then we are creating a resource quota, and these are Kubernetes specific things. I won't be explaining you these, but I want you to also know that when you are dealing with enterprise grade environments, you will always have resource quota object defined, which decides the ceiling for pods. So here we are saying not more than 2 pods can exist in this namespace. These are the requests, these are the limits of all these things. So you define the ceilings in the resource quota. Again, what I have done is I have defined requests and limits in my deploy.yaml itself. Now there could be scenarios where you would see that your application developers are not defining requests and limits. In that scenario, you can always have a limit range resource created, which ensures that if someone is creating resources without defining requests and limits, then these are auto added to those resources. You can do that. So I have not defined a limit range here, but in production you will always see that resource quota and limit range both are defined, and then the deployment may or may not define. If deployment is owned by, let's say, Kubernetes admins or your DevOps team, then of course they will define these explicitly. But if these are taken care by application teams, then there are scenarios they might not define it. In that scenario, limit range object always helps. Then I'm creating a service account. Here I'm creating app1 config map. I also want you to know that we have defined namespace in all of our manifests, but when you have application CRD or Argo CD application where you have explicitly defined this namespace, you don't have to explicitly define namespace in all those YAMLs. But I would encourage you to do that because it ensures completeness. Even if a junior engineer is watching your manifest, he or she can easily identify that this manifest will be creating resources onto a namespace that is app1 namespace. But again, if you have defined this in application Argo CD application, then you need not to define it here mandatorily. Now let's talk about what we are doing. So what we are doing here is we are creating an index.html file, and that index.html file will have this content. Then we will be mapping this config map to our deployment. We'll see that next. Then I'm creating a secret which has the API key called cloud with Varjosh is awesome. Tell me, is this channel awesome? Then we move to service.yaml. Here I am again saying that the cluster IP service listens on port 80, and then the target port is also 80, that is on which my application listens on. Now finally, let's see what our application is. My application uses Nginx as an image, and we are doing something very simple. What we are doing is we are mounting the config map as volume, and then we are mapping that volume onto our container at this location. So index.html that we just created using our config map will be mapped onto here. So whatever we have defined in that index.html should be visible to us. And similarly, we are defining that secret here, and then we are defining a service account name here. I hope these things are understood, and these are Kubernetes specific, but I still wanted to give you a walkthrough of this so that your dots are connected end to end. Now, with this understanding, let's first create our Argo CD application. So I will go to my terminal and I will clear my screen. I will run kubectl apply -f, and I want to go under app1 config, and under app1 config I have Argo CD directory where I have app1 app crd.yaml. I want to apply that, and this says your application is created. So if I go to my browser now where my Argo CD UI is already there, I see that it shows the app health as healthy, which is strange. And then it shows that there is an error, and the error is failed to connect to the repository, which is understood because we have not yet created any repository. Now you see that app health is shown as healthy, but our application is not healthy, right? But this is because a sync has not been performed yet. After the first sync is performed, this will depict the real application health status. But for now, it is healthy because the sync has not been performed yet. Again, I said that this will depict the application health status. It is not actually always application health status, but what it will show you is if there are 5 pods supposed to be running, it will just say that all are in running state. Maybe your application within that pod is not working correctly. This app health will not show that. It will just show you that maybe you created 5 pods, those 5 pods are created, hence your sync status is fine, but your application is unhealthy, maybe because your pod are in error state, and that error state could be maybe image pull error or container error and so on. So I hope you get that picture, and we have already discussed this in our past lectures as well. Now let's go here and go here, and then I will open this here, and then let me go to repositories, and then let's create a new repository, and I'm calling this app1 config. And then what I will do is I'll scroll here. This is already public, and for now we'll be using public repositories, but you all very well know that we have discussed how to connect to private repositories in Argo CD previously in our 4th lecture, and then we will be tying all these dots, whatever we have been learning in different lectures, in a GitOps mega project at the very last of this course. So for now, let's create this repository. It's a public repository named app1config, and I will click on upload an existing file here. I will minimize this a little, and then I will go here, and this is app1config. So I'll drag drop both of these here, and I'm also dragging Argo directory here because we know that our application manifest should also be version controlled. And here I will click on commit changes, and this will start committing the changes. Understand one thing very clearly. If I talk about this, if I click on refresh, it should now show us out of sync, which we understand. When we click on refresh, it will check our repository and tell you that whether what is defined in your desired configuration exists in your live cluster or not, and which is it is saying out of sync. And now you see the application health is also gone missing. Okay, so not after the initial sync, but after it has analyzed your repository. So it is now depicting the accurate status that is missing. So whatever is defined in your Git does not exist in your cluster right now. And it is also showing that these are the resources that are supposed to be created. So I'll zoom out a little so that we can see all these objects at one place. Now we will click on synchronize. Understand that what we have used is manual sync. If we were to use automated sync, then this would have synced automatically. I am using manual sync so that I can show you step by step how these are created when we click on synchronize button. An additional thing I want you to note that refresh is just checking with your repository. The deployment of resources will only happen when you manually sync it or you have enabled auto sync. I hope that part is extremely clear in your head. Now I will click on synchronize, and you see the sequence in which these will be synchronized. Okay, so see first namespace, and then you see app1 config, and after the now service, and then finally deployment. So it adhered to the sequence that we defined. That is why sync waves are important. So explicit dependencies, Argo CD will automatically take care, but how about implicit dependencies? That is what Argo CD just did for us. Now that everything is up and running, I can go to my terminal. I can run kubectl get all -n. What was the namespace? App1 namespace. And you see the pods are created, the service is created, the deployment is created, and this all command won't show you config maps and all of those things, but all of those would also have been created. So this is your CM, this is your secret, and then this is your resource quota. You see everything is available here. Now we have done this much. Let's also access our application. Our application, the cluster IP port is port 80 and name is app1 service. Let me come here, kubectl port forward, and then -n, the namespace is app1 namespace, and then that's a service, and the service is named app1 something, right? Oh, this is app1 ns. I'm so sorry. App1 ns, and then the services would be app1 service. And then what I want to do is I want to, on my Mac, I want this whenever someone accesses port 8081, it should be directed to cluster IP port 80. Let me press enter now, and then it is forwarding. So let me go to my browser. I will write here localhost 8081. Welcome to Cloud with Varjosh, your happy place for cloud and DevOps learning. Build, break, learn, repeat. This is the mantra that you must be adhering to when you are learning cloud and DevOps. I have already discussed whatever I wanted to discuss. That brings us to the end of this lecture. You should now understand why sync waves exist, how they differ from default Argo CD ordering, and how they enforce application intent. We saw how explicit and implicit dependencies differ, why ordering issues occur, and how sync waves solve them. We validated everything with a hands-on demo to avoid relying on assumptions. In the next lecture, we will introduce Argo CD workflows and shift from configuration delivery to workflow based orchestration in the Argo ecosystem. If you have any questions, feel free to drop them in the comments. And if this lecture helped you, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi, and welcome to the 8th lecture in our Argo CD Basics to Production course. In this lecture, we will break down how Helm works with Argo CD, starting with what Helm's role actually is in GitOps driven Argo CD workflow. We will then see where Helm fits inside the Argo CD architecture and why Helm is still valuable even though Argo CD manages the entire lifecycle and deployment. Finally, we will walk through a hands-on step-by-step demo where we deploy an application using a Helm chart as the source and observe exactly how Argo CD renders and applies manifests. To my fellow Indians, a very happy Republic Day. Freedom is truly amazing, not just the freedom to do whatever we want, but the freedom to learn, grow, and create a better future for our families. If through this course or any other courses in my channel, I can play even a small part in helping you gain that freedom, I would consider it an honor. So let's get started with this lecture. Now, firstly, we are calling this lecture Argo CD Helm tutorial. So it is understandable that this lecture will only make sense to you if you understand what exactly Helm is. So what I will do is I'll go to my browser and then I will go to Argo CD Basics to Production courses repository, and if this is benefiting you, I would request you to star this repo. I'll go inside it and then I will go to lecture 8, that is today's lecture. I will for now just go to demo prerequisite, but the prerequisite that I want to talk right now will help you understanding even the theory part. So I have a tutorial in this channel which teaches you Helm step by step, and you can think of it as basics to production in Helm. We have multiple demos there. If you do not have understanding of Helm, pause this right away, watch this Helm lecture, and then come back here. And I hope you have watched the Helm's lecture. Helm and Argo CD. Helm is used by Argo CD as a manifest rendering tool, not a deployment engine. Now, when we were using Helm alone without Argo CD, what were we doing? We were using Helm install to install our application, Helm upgrade to upgrade our application, Helm rollback to roll back our application, and so on. But when I talk about Argo CD, and when you are using Helm with Argo CD, you do not use any of those commands because those commands will not work. Then Varun, how do I integrate Argo CD with Helm? Because I understand the benefits of Helm and I understand the benefits of Argo CD and I want to use both of them. How do I do that? You can do that. What happens when you are using Argo CD with Helm is Argo CD under the hood converts whatever you have into Kubernetes manifest by using underneath a command that you already know. So what Argo CD will do is Argo CD will take whatever you have defined in your, let's say, charts.yaml, values.yaml, and so on, and then it will run Helm template command, and then Helm template command will give Argo CD all the manifests that are being used by your application. And then once Argo CD has those manifests, Argo CD will apply those manifests, will send those manifests to the Kube API server, and then your resources will be created. So the funda behind it is the same. Argo CD takes your manifest and sends those manifests to your API server. The only difference now is it first runs Helm template command, and that command is run under the hood so that it can fetch the manifest and then it can apply those manifests onto your Kubernetes cluster. But the difference is you cannot anymore run commands like Helm upgrade or Helm rollback. That is the only difference. Rest, Argo CD behaves the same way as it behaves. Now let's go through these definitions so that we understand this in a better way. Helm is used by Argo CD as a manifest rendering tool. Manifest rendering tool as in the tool that will give you the manifests that are to be applied, and not a deployment engine. I hope this is clear. Render flow, chart.yaml plus templates, and templates inside this templates directory you would have all your manifests for deployments, for secrets, for service accounts, and so on, plus values.yaml into Kubernetes manifest. That's what the render flow is. No lifecycle ownership. Argo CD does not run Helm install, does not run Helm upgrade or Helm rollback. It is just converting everything to Kubernetes understandable manifests and then sending them to the API server. Deployment method rendered manifests are applied via the Kubernetes APIs, and we understand that. Last one is chart sources, and even if you are using custom charts or public charts, both of these can be used along with Argo CD. Now, with that basic understanding, let's see where Helm fits in the Argo CD architecture. Now, as part of lecture 2, we understood the Argo CD architecture. We know it is the repository server, the component that fetches the desired state. Now, repository server here has also one more job to do. Here you read renders manifest from Git sources. Here the Git source is of course our repository, but that repository does not have plain Kubernetes manifests which we have been using thus far. What it has is it has a Helm chart and our templates directory along with values.yaml. Hence, the repository server must not just plainly render the files. It must have some means via which it can convert the files or the structure or the Helm chart that is available in your repository into usable Kubernetes manifest. So repository server is the one that is doing that job for you, that is doing the manifest rendering for you, as the second bullet says here. And then finally, we all know application controller is the heart of Argo CD. It is the one that applies those manifests and reconciles them. We understand this part, and that is what we are saying here. Repository server pulls Helm charts and renders manifests. Application controller applies manifests and reconciles drift. Post render behavior, Helm is no longer involved after rendering. So this is critical piece to understand. You are just using Helm, and not even you. Argo CD is just using Helm template command to convert the chart into a manifest format, to render the manifest. That's it, nothing more. After the application is deployed, you do not use Helm upgrade to upgrade the application or Helm rollback to roll back the application. Everything that we have learned in past, be it about rollbacks or be it about implementation, all of those things are performed by Argo CD itself. Now, many of you might be thinking, why use Helm if Argo CD manages the lifecycle of your application? There is no point, right? Wrong. The crux of using Helm, of course, Helm gave you that flexibility of rolling back the application or upgrading the application in one click. And all of those things we know can be done by Argo CD itself. Then why use Helm? Understand, when you are dealing with production grade applications, there are so many fields. You cannot, when you want to edit something, go into each manifest and do that. What you do is you go to your values.yaml and then just make the changes there. And the same applies for when you are having multiple environments. It's not that if you want to change something, you will go into three different application sets of manifest. For example, dev, stage, and prod. What you would do is you would just go to their respective values.yaml and perform those changes. So what Helm is doing, even when it is used with Argo CD, it is simplifying your YAMLs. It is helping with configuration at scale and industry standard. This one is the most critical one. Pick any production implementation of an enterprise grade application, of course, and you will always see both Helm and Argo CD have their place under DevOps team, because without these tools you cannot deal with a production grade implementation. Cannot is a strong word here, but it will surely make your life easier if you are using both Helm and Argo CD in production grade applications. Now, with this understanding, let's move to the demo section of this lecture. So I will go to my GitHub notes. I will go to the top first, and then I will go to demo, Argo CD, and Helm. So the prerequisites for this demo, you should have Argo CD up and running. If you have followed lecture 2 where we did that, you can simply use port forward so that your Argo CD UI is accessible. For me, the Argo CD UI is indeed accessible, because if I go to my terminal, I am port forwarding in this tab. So let's go back to our browser, and then the second step is, of course, you must understand Helm, because only if you understand Helm, you can learn how Helm integrates with Argo CD. Third is ensure you have a clean setup. If you are following my demos, there is a possibility that you have an Argo CD application created. So delete that application. If you have a namespace, app1 namespace, delete that namespace. We will be recreating everything from the very scratch. Demo introduction. We will be deploying a simple application onto our Kubernetes cluster, and under the hood we will be using Argo CD, and we will be integrating Helm charts with it. So let's see step 1. Step 1 is understanding the directory structure. So let's go to Visual Studio Code, and if I go to lecture 8, I have app1 config directory here, and you will find this directory in lecture notes as well, so that you can follow along with me step by step. And as I always say, it is important that you do these demos along with me, because only then you will face challenges, and only then these things will stick in your minds. So let me expand this. I have two directories here. One is app1 Helm and another is Argo. Argo is the directory that has my application manifest, and app1 Helm is the directory that has my Helm related component. So in this one, in this part, in step 1, we will study what exactly app1 Helm has. I won't be explaining you Helm. I will just tell you how our application is leveraging Helm here. So chart.yaml, it's pretty generic. We have written simple Helm chart for app1, and there is certain version and app version given here. So I'll close this one. This is pretty basic. Then values.yaml is the one where the magic is happening. So let's do one thing. Let's also open our templates, our YAMLs, the resources that we are creating, so that we can see how these manifests, these 4 manifests, are using my values.yaml. I want you to know that as part of this lecture, we will be creating 4 Kubernetes resources, rather 5 if I also include the custom resource that we will be creating here, and then we will be trying to access our application. So for now, let's do one thing. I will click on this, and what I want to do is I want to compare these side by side. So I'll move this here, and then I will split this to the right, and then I will close this. So I will also zoom in a little. So what I am doing here, folks, is I am saying create a namespace for me, and the name of that namespace will be go to values.yaml, and here is my values.yaml. Then go to app there, okay, then go to app there, and then go to namespace there, okay. I will go to the namespace there, and then that will be the name of my namespace. And what is that we are defining here? app1-ns. So this, when Helm template is run, this will be filled with app1-ns, as simple as that. And similarly, if I open config map here, then you see in the name we are saying give it the release name. But Varun, how will we supply the release name? And I will come to that in a little while. For now, understand that this will be filled by whatever we define in application CRD here. And if we do not define it, what will happen? We will see that as well. And namespace here, again, we are saying go to this destination to know what will be the value for namespace field here. If I go to service.yaml, here I am saying these things are understood before, and I am saying if you want to know the type, go here, values service type, values service type. So cluster IP will be filled here. Selector, I am saying selector would be the release name, and release name is something that we can supply, or we can leave it blank for Argo CD to fill it automatically, and we'll see how that works in a little while. Then ports, I am saying values service port, values service port. So 80 will be filled here automatically. So now that we have this understanding, let's also see the deployment manifest before we leave from here. And here as well, I am filling the fields based on values.yaml. It is pretty simple. And if you have done the demo along with me in my Helm lecture, then this would be a cakewalk for you. So with this understanding, we understand the directory structure at large. Now, let's do one thing. Let's create our application manifest as part of step 2. So if I go to my repository, step 2 is create and understand the Argo CD application. So if I go here, Argo CD, and here is my application CRD. Till here, everything is simple, and you would be understanding these things. Now understand the path I have changed to app1-helm. And why I have done that? Because within the root repository, we'll be creating a GitHub repository soon, and within that root repository, I will have a directory called app1-helm, and this directory will have all the files that are required to deploy my application, which is why I have app1-helm here. And here is the part I wanted you to know. I have added Helm release name equals to app1. Now, what will happen when I do that? Firstly, the fields that you see here, whichever had release, they will be filled with app1. That part is understood. But what I want you to concentrate on is what if you do not fill this, and what will be Helm doing under the hood when it sees release name is application1. So let's go to our GitHub repository and see how that will work. So understanding helm.release name block. So this is the block that we are dealing with. Helm will first cd into app1-helm, and then it will run Helm template app1. And why app1? Because the syntax of Helm template command is you mention the release name here and then mention your chart directory. Our chart directory is the one where we are right now, and where we are right now, we are in cd app1-helm. So it is saying templatize everything that you see in this directory, and the release name will be app1, and that is how supplying app1 here will help. Now, what if we do not supply this thing? What if we do not have this block to begin with. In that case, what Argo CD will do is Argo CD will use the application name that you supply here as the release name. But I wanted to tell you that difference, which is why I have added this field specifically. So the question is, if you are coming from my Helm tutorial, you know that there we had three different values.yaml for dev, stage, and prod environment. In that scenario, how will Argo CD know which values.yaml to use? Because if you remember, we had three different values.yaml, values-dev, stage-prod, which one to use. And if you have multiple values.yamls in your repository, then what you can do is you can specify which one to use using this block. And this is pretty simple. And here I have also shown the same things. If you want to run Helm template command, this is how you ran when you used, Helm directly. But since in this Argo CD is the one that is rendering our manifest, it is believed that under the hood, Argo CD runs this command for you. And why this one specifically here? Because if you have defined here values-prod, then Argo CD will be using this values-prod.yaml to see the values for your manifest while it is templatizing, while it is rendering. So in essence, what I want to convey to you is Argo CD just uses Helm underneath for generating your manifest, just for rendering the manifest. For everything else, Argo CD is doing it itself. Now, let's go back to our Visual Studio Code and destination. What we are saying is, we are saying this is the cluster where you need to deploy my manifest, and the namespace where all these manifests must be deployed. What all these manifests? All the manifests that you render from this source must be deployed onto a namespace named app1 namespace. One more thing is, I am specifying namespace here, and if you do that here, you do not have to have this namespace section here. Argo CD is intelligent enough that whatever is namespace scoped must be deployed onto that namespace. But for completeness, I always recommend to have the namespace section in all your resources that you are creating. Anyway, let's get back here. Yeah. And then I am defining a sync policy. Now, what we are saying is I want to do automated sync. This is that. And then I'm saying prune is true. What does prune mean? Prune mean if I delete some resource from my source, from my Git repository, then you also delete that resource from your Kubernetes cluster, from the live state. So the desired state, if has deleted some resource, then live state should also depict that. And then finally, I'm saying self-heal is true. For example, if someone changes something in the live cluster manually or via any script, then it is Argo CD who must ensure that my cluster must self-heal. What is self-heal, Varun? Self-heal implies whatever is defined in Git must be exactly the state of my live clusters. And if you want details around this, I have a separate lecture. I think it was lecture 4, where we discussed about all of these things in detail. So for now, we understand this. Let's now do one thing. Let's create our Argo CD application. So I will go here. I will click on open in integrated terminal, and then I will run kubectl apply-f, and I want to apply app1 app CRD. And if I go to my browser now, I go to this section, I should see an application here. And we all know why this is healthy, because the initial check of the repo has not been performed yet. So once we create the repo and have some manifests there, we will see that this healthy state, app health state, would be depicting the correct message. Right now, it is not, because the initial check has not been performed yet. And if I click on this, you would see the usual message that I don't see a repository there. Failed to load target, failed to generate manifest for source. So let's do one thing. Now let's create our repository. So I will go here and then I will move to the top. I will then open this in the new tab, and then I will come to repositories here. I will click on new, and I am going to call this app1-config, and then it is public. This is fine. I will click on create repository, and this will create the repository for me. I will go to upload an existing file here. I'll click here and then I will drag drop my file. So let me just quickly minimize this, and then I will go here, and these both are the directories that I want to upload. So understand that app1-config is my repo name, and both of these things are there in the root of my repo. Because they are in the root of my repo, that is why if you see here, I have specified app1 helm, because I want Argo CD to know that the configuration files, the manifest that must be used, are residing in app1-helm. App1-helm is something that we have uploaded. All the files in the directory as well are also uploaded. So I'll click on commit changes, and we have automated sync enabled. So let's go here and see that behavior. So right now the default behavior is it checks after 3 minutes, every 3 minutes approximately. So I'll click refresh so that it does that immediately. And wow, you see how quick that was. So it first checked with the repository that whether the desired state matches the current state or not, and it saw that it does not match. Since we have enabled auto sync, it automatically synchronized, and you see all of these resources are created. How magical is that? Now under the hood, it ran that command helm template or whatever mechanism Argo CD has under the hood, and then the manifests were sent to the API server, to the Kube API server, and all those manifests were applied successfully. Hence you see everything is up and running. So this one is for the deployment, this one is for the replica set, and this one is for the pod. So if I want to check the manifest for deployment, I will click here and I will scroll down. You see what is the name given to it? App1-deployment. App1 is the release name that we gave. And why do I have deployment mentioned here? I have deployment mentioned here because if I go to my manifest, I called it like that. You see, we have the correct namespace because that is what how we defined. The templating engine of Helm was used by Argo CD, nothing else. It had the manifest and then it sent those manifests to Kube API server to implement for implementation. And similarly, you can see app1 namespace. Here is the manifest for that. It was also perfectly rendered. Now let's see one more thing. Let's access our application. So what I will do is I'll go to my terminal. I will go to this tab here, and then I will run kubectl port forward -n. App1 namespace is where my service and deployment are residing, and then I want to port forward services, and the name of the service is app1 service, and then whatever is received on my Mac on port 8081, I want to send it to this cluster IP port, that is 80. So I'll press enter, and this has started the forwarding. So let me go back to my browser and let me run localhost 8081, and then I'll press enter. Welcome to Cloud with Varjosh, your happy place for cloud and DevOps learning. I hope you understand this demo. That brings us to the end of this lecture. You should now have a clear understanding of how Argo CD works with Helm, why Helm is used only for rendering manifests, and how Argo CD owns deployment, reconciliation, and rollback with Git as the source of truth. We saw how repository server renders Helm charts, how application controller applies and reconciles the output, and why Helm concepts like release history or rollback do not apply here. We validated all of these with a hands-on demo. In the next lecture, we will build on this foundation by introducing the app of apps pattern, moving from single application management to operating multiple applications at scale with Argo CD. If you have any questions, feel free to drop them in the comments. And if the lecture helped you, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi, and welcome to the ninth lecture in our Argo CD Basics to Production course. In this lecture, we will break down the apps of app pattern in Argo CD, starting with why this pattern is needed when managing real world products composed of multiple components. We will then clearly define what apps of apps is and how it helps model a complete product using GitOps without introducing any new or special resources. Finally, we will walk through a hands-on demo end to end where we deploy a front end and back end using a parent application. Observe how child applications are created and managed, and understand the role of sync options in controlling application behaviors. If these terms like parent and child are not making sense to you right now, it's okay. We are here to dissect them step by step. So let's get started. And before I get started, if you see that hype button, do press it. If you are liking the kind of content I am making, then please like the videos, comment on the videos. Even if it is just a hi, please do that. It really helps. And lastly, if you would like to support me further, then do become a member of this channel. So why apps of apps? Now, firstly, if I call our applications that users will be accessing application and also called Argo CD application, then it becomes a little confusing. So what I will do in this lecture is, whenever I want to convey the application, I will be calling that a product or a software. And of course, Argo CD application, I will be calling it application itself. So whenever I say product or software, understand it's the application that our end users will be accessing or our tools will be accessing. And when I talk about Argo CD application, I'm talking about the application construct within Argo CD, that application which connects your source repos to your Kubernetes cluster. With that understanding, let's understand why do we need app of apps. First point is, one product maps to multiple Argo CD applications. Now, product as in, like I told you, it is an application. So one product maps to multiple Argo CD applications. Now, whenever I am talking about modern applications, whenever you see an implementation, it is highly unlikely that you will see a monolith design. What you would typically see is a microservices architecture or a three-tier design. And that three-tier design, do not think that three-tier is only limited to three-tier. In that three-tier design, you can also have helper tiers. Now, helper tiers as in that are helping with authentication or caching and so on. Microservices, an application or a product, can constitute of multiple microservices, 10, 20, 30, 40, depending on the scale of that product. So for example, if I talk about amazon.com, amazon.com could be comprised of hundreds of microservices. So you can get or detect the scale of a product based on what all it is serving to its end users. So bigger the product, bigger the number of microservices it would be using. And now this is not something that is written on stone. There are always corner cases. So whatever I'm saying, take that as what you will typically see, not what is written in stone. Now, one product maps to multiple Argo CD applications, and we have been doing this thus far. We have created a front end, we have created a back end, and then we have had different Argo CD applications created for front end and back end. no single control plane for product deployment. Now imagine if I want to deploy my application, what I will have to do is first I will have to deploy my Argo CD application for backend and then Argo CD application for my front end. So in this scenario, I'm only dealing with two components of my product. So the two components are the front end and the back end. Imagine if you are dealing with a product that has multiple microservices like you see on the right of your screen, then you will have to manage 5 different applications. If I talk about this design, there are 5 microservices, and if you are adhering to the best practices in GitOps, in that scenario, you would have 5 different Argo CD applications. Now, 5 is not a big number, of course, but eventually, gradually, your product might grow. And when it grows, the number of microservices also grow. In that scenario, what you would want is you would want something via which you do not have to manage so many Argo CD applications, because managing different components can become a challenge. Now, I mentioned a statement just now that bigger the product, more number of microservices it will have as it will scale. It is not something that is always true. It depends on your product design. It is not something that is always true. So whatever I say when it comes to best practices or recommendations, always take that with pinch of a salt, because there are always corner cases where you will have to have something different than usual. Third point is product health scattered across multiple Argo CD applications. Now, this is a problem in my opinion. So if you want to check the health of your product, you will have to check different applications, and if all of these Argo CD applications are healthy, then you would say yes, my product is functioning properly. But when you look at it, you will have to look at different Argo CD applications. There is not something that is available to us single, where I say if this single thing is working all right, then all the microservices for my product or all the tiers for my product are healthy. So we don't have that right now. And secondly, if you want to deploy your product onto another cluster, for example, then you will have to deal with whatever number of Argo CD applications you have created for your product. So it is cumbersome. What we want is we want something single which has the complete view of all my Argo CD applications. With whatever we have learned thus far in this course, we do not have that. And let's say this is just for your dev environment. How about staging? How about prod? So right now we just have 5 Argo CD applications for my development environment, and if I want to cater staging and production, then I have 15 Argo CD applications. And trust me, it becomes a pain to manage so many applications. And to answer all of these challenges, all of these limitations, we have something called App of Apps, and the name gives away what it is doing. It is saying if you have multiple applications, I am the application that will manage all those applications. So essentially what you are doing is you are creating an Argo CD application to manage other Argo CD applications. The name of the pattern gives away what it is doing, if you can create that mental picture in your head. So now let's understand what is App of Apps. So let me arrange this first. I will do it 125% zoom. What is Apps of Apps? It is a GitOps pattern. Again, it is a pattern. It is not a feature. You are already using the CRD, which will help you achieve this pattern. So it is a pattern, not a feature, that allows a product And product, as you know, we are talking about an application that your end users access, allows a product composed of multiple Argo CD applications. Like this was the product which was composed of multiple Argo CD applications to be managed as a single declarative unit. And that is what you see if you look at this diagram. So previously, the thing that is sitting here was not there. You had a product, and that product had multiple Argo CD applications. Now what we have is, we have something sitting in between, which we are calling product one root, and a root sits at the very top, and underneath the root you have different branches. That is what we have here. So you have root, and that root has different branches, and these branches are something that you already know. These are your Argo CD applications which are taken care by the root. So we are calling this the parent application, and then that parent application has multiple applications, multiple child applications underneath it. It is a very simple concept if you understand it from the foundational level. Now let's read these bullets. One parent Argo CD application represents the product, and that is what we have learned. Parent application manages child Argo CD applications, and it is understood, and we will see this more as we look into these YAMLs. Each child application deploys a product component. So here I have shown different microservices. These could also have been tiers such as front end, back end, DB end, and so on. Then you have product deployment becomes a single sync operation. Now, to understand this point, I want you to concentrate on this. Firstly, this is the YAML for my parent Argo CD application. These are the YAMLs for orders and payment, these two. The rest I have not shown here for simplicity, and of course I didn't have space here. Then kind is application. This is understood. Like I told you, app of app. So this is also application. This is also Argo CD application, and this as well. Now I want you to concentrate on the source part. In the source part, what I am saying is, whatever you must deploy onto my Kubernetes cluster is there in these repositories, and I'm saying the path Argo. So create that mental picture in your head. Now this Argo path must contain these YAMLs. So when you are creating this application, it will create both of these applications in your Kubernetes cluster. And understand, once both of these applications are created in your Kubernetes cluster, what it will do? It will apply all the manifests that are placed in these repositories under this directory. That is what GitOps is doing. What is GitOps? GitOps is saying, go to my repository, and I'm specifying a path here. Go there and deploy whatever you see there onto my Kubernetes cluster. So when Argo CD saw this manifest, this object created, what it did was it deployed whatever was there in these two repositories. And what was there in these two repositories under this Argo path? It was these YAMLs. And when these YAMLs were created, when these Argo CD applications were created, what was defined in these YAMLs? In these YAMLs, it was defined, you go to this repository and go to this path and deploy whatever you find there. And what will we find there? We will find the deployment service and rest of the Kubernetes objects that are required to have the orders microservice up and running. And if you can create that mental picture in your head, you already understood app of apps. Now, if there is any iota of confusion in your brain, do not worry, when we will do the demo, everything will get connected. So for now, I want you to understand what will be the sync order. First, the parent will sync, and when the parent will sync, both of these applications will be created. Argo CD applications will be created, and then the child will sync. When the child will sync, what will happen? Whatever is defined in these repos in this path will be created, and that is our Kubernetes resources. So first the parent application, then the child application, and then finally your Kubernetes resources will be connected. I hope you understand this. If there are any doubts, we will clear that in the demonstration section. So let's scroll down and see what we want to do here. So the demo app of app. So what we will be doing here, we'll be dealing with a product that is called product one, and we all know we could have very well called this application one, but I didn't do that so that you do not confuse this with Argo CD application. Then we will be creating a parent Argo CD application for our product one, and our product one is comprised of two ends. It is comprised of a front end and a back end. These both are child applications, and you can see the YAMLs for both of them here. For this one, the root, the parent, and then also the child. I won't be discussing these YAMLs in detail right now because we will be discussing them in their subsequent steps. I just placed here so that you can create that mental picture in your head. Then this demo, we will be doing 8 steps. First, we will be understanding the directory structure. I have created a directory structure locally, and that directory structure, some parts of it we will be replicating into our GitHub repository. Second is then we will be building and pushing an image. We'll be dealing with custom images so that we understand the process end to end. At this stage, we do not have a CI like Jenkins or GitHub Actions that is orchestrating everything for us. Hence, we'll be doing this manually. But I assure you, once this course is complete, I will be creating a GitOps mega demo where we will be covering everything like you would typically see in production. Then in step 3, we are creating child apps. Child apps like this one and this one. Then step 4, create Git repositories. We will be creating GitHub repositories for whatever we are doing. So we'll be creating a GitHub repository for this because this is a configuration file. This is declarative. Hence, we must be version controlling it. So we will be creating a GitHub repository specifically to save our product one root app, that is our parent Argo CD application. Then step 5 is create and apply the parent app. Understand the difference. Here we just created the child apps. We did not apply it. We only apply the parent app because it is the parent app which will automatically see what is there defined in these, and it will find these YAMLs, find these child applications, and will be deploying that. And rest of the principles that we learned before, like automated sync, pruning, self-healing, all of those apply here as well. And as we progress, we will see how these are leveraged by us. Then step 6 is, once we do that, we'll observe the Argo UI, access the product, the spell error here, we'll access the product. And then step 8 is self-healing. I'll show you what happens when I delete this. This will be auto-created if I manually delete it, and we'll see that in the self-healing section or the chaos engineering section of this lecture. So with this understanding, let's go to Visual Studio Code and understand step 1, which is understanding the directory structure. So I'll go to my Visual Studio Code, and then you will see the same directory structure in the GitHub notes for this lecture. So I'll expand product 1, and in product 1, I will walk you through the structure we have. So we have product 1B, that is backend. This has our code. So it has our app.py and Docker file. I won't be going through the code. It is a very simple two-tier application. So you can go through it yourself, and I'm certain you will understand that because we have discussed the same code previously in this course. And even if you open this now, you will understand what is happening. If you understand basic Python and understand how to write a Docker file. And here we have product one backend config. So this is the directory where we are storing our configuration files. Configuration files for two things. First is our child Argo CD application, and this nomenclature should have been changed. I'm calling this app1 here, but this should be called product1. So let me do that correction with you because I don't want any open ends here. So product1, I'm calling this product1 backend app CRD, and we are calling this product1 backend. And let's see what we are doing here. So we are saying this application CRD belongs to backend. Namespace is Argo CD, and we understand all the custom resource definitions or any custom resource pertaining to Argo CD that we create in the dedicated Argo CD namespace. Spec, we are using the default project here. Source, we are saying the source repository for backend is this one. And in this repository, you go and look at this path to apply the manifest, and manifest-be is what it will find in the root of the repository. So we are saying that here. Understand that I have not yet created this. I will be creating this along with you. Destination is, I'm saying apply this to the kind cluster I have recently created, and the namespace in which the resources that are defined here must be deployed is product1 namespace. As simple as that. Sync policy is automated, so it will automatically sync. Then prune is true. So for example, if I delete any resources from my GitHub repository, then you also delete these resources in the live cluster. Self-heal is true. For example, if I delete something or if I modify something, my source of truth is what is defined in Git. So you revert whatever changes or additions I have done, and my live cluster should depict whatever is defined in my source of truth, that is my GitHub repository. And then these are something that we have not studied in this course yet. So I wanted to introduce the sync options in this lecture itself. Now what we are saying is Argo CD, if you do not find a namespace created as in product1 namespace, if it does not exist, then go ahead and create that namespace. Prune last. So what this implies is whenever you are creating resources, you first create the resources. Whenever you are performing a sync operation, you first create the resources, and once all the resources are created and modified then you start deleting the resources which are no longer there in my Git repository. That is what prune last means. Deletion must take place at the very last. Then I have apply out of sync only. So what this does is, let's say I have YAMLs for 50 resources. I don't want to send all those YAMLs to the API server to apply them and tell me that this is unchanged. What I want is you only send whatever has changed to the API server. Now this is important because this does not overburden your API server unnecessarily. There are more sync options in the references section of the GitHub notes. I have added where you can see more sync options, but I have covered the important ones here. Now let's see what our manifests look like. We have a very simple deploy.yaml, and this has the backend deployment. We are deploying this in the product1 namespace, and again this is pretty simple. The important part is this one. So if you are practicing along with me, which you should be, then ensure you change this to your Docker Hub account name. Then image pull policy is always, I have added this because I was doing some testing, but it was using stale image that was stored in the node. Hence, I added this. You can omit this if you want. Then ports is obvious. This is just for documentation that my application listens on port 5000. And then similarly, I have a service here. Target port is 5000 because my application, my backend tier listens on port 5000. Then similarly, I have both of these, both of product 1B, that product B config. I have similar for front end as well. Now I will just give you a glimpse of it. This is pretty much similar, if not same. I will again rename this. I will have product 1 written here. Product 1 front end application CRD. So we are calling this product 1 front end. And then what I want you to concentrate on is this one. So this is pointing to a different source repo. Rest everything we already understand from our backend YAML. Manifests, these are similar. You see deploy, this is pertaining to front end, and then this service is also pertaining to front end. So our pods, our application, the front end application, the front end tier of our application, of our product listens on port 4000. Now I hope this is understood. And now I also wanted to explain you the last directory in product 1, which is product 1 GitOps, but I think I will cover that later when we discuss the parent Argo CD application. For now, I feel we all are at a very good place to go ahead with step 2. But before I do that, to follow along with this demo, ensure that you have Argo CD installed and Argo CD is up and running. So this is the repository where you will find detailed notes. If you have not yet started this, I would request you to please give this repository a star. So I will go in this repository and then I will go to lecture 9. I will use clickable table of contents to go to demo prerequisites, and prerequisite is simple. If you have installed Argo CD along with me, then you must be port forwarding, and we are. And then secondly, if you don't have Argo CD installed, then you can follow this link. We discussed this in detail in our lecture 2. So you can go to lecture 2 and see how to install Argo CD UI and then forward it. Then step 1 we have already done. Let's move to step 2, and step 2 is build and push container images. So what I will do is I will go to Visual Studio Code. I will go here because here is my build context. My Docker file and app.py is here. I will right click here, open in integrated terminal. So I already have the command with me. I will simply copy that command and then I will paste that command. So what we are doing is we are saying docker build -t tag this image. We are calling this product 1BE, and then version is major version is 1, minor version is 0, patch release is also 0. And then the final dot signifies that the build context is in the present directory. And then second command, we are pushing this to my Docker Hub account, and we do not have to provide credentials. Rather, I do not have to provide credentials for Cloud with Varjosh Docker Hub account, because if you look at here, my Docker desktop, I have already logged in as Cloud with Varjosh. Now, if you are using an Ubuntu machine, in that scenario, you will have to log in there. You can use Docker login and then proceed with the second command, the push command. So I'll press enter. This will both create the image and then push that image. And by the time this works, I will also right click on product 1 front end. I will open this in integrated terminal, and then I will copy the commands that are specific to front end here. So I will paste them. This will create and push the container image for me. So this is, I have stopped the process unknowingly. Just give me a moment. I will run those commands again. And in here, access is denied. I think my Docker login, Docker is running, but sign in did not work. So let me sign in to Docker. Continue. When I was showing you, I noticed that my login is no longer there, but I thought, let's see what happens. Anyway, so I'll close this now. It has logged me in. So now if I run that command again, let me run both of these again, and in this terminal as well, let me run these again, and this should create the container image for me and also push that image for me. So till the time this is going on, let's go here and I will open hub.docker.com, and then I will go to my repositories section, and I don't see both of these repositories yet because they are being created as of now. So I'll go to Visual Studio Code. So this is still creating the image. Let's wait for this to create the image and then push the image, and finally we'll see how this looks. The front end has completed and back end has also completed. So both have finished. So let me go to my browser and then let me refresh this. I see both backend and frontend exist here, and they were pushed just a minute ago. Now let's see what we want to do next. I'll go to my diagrams, and here step 3 is create child apps, backend and frontend. So as part of step 1, we have already seen how these child apps look like. So we are already good there. So let's see what is the next step now. Next step is create Git repository. So let's go to our browser, and then here I will go at the top here, and then I'm going to open this in the new tab. Here I will click on repos, and then I will click on new, and I have to create 3 repos. First one I will call this, and this name should be same because I'm using this name in my child applications. Okay, so I'll mention this here, and then I will click on create repository. I will open this again here, and then I'm going to go here, new, and this time I'm creating this for front end. I will click on create repo. Ensure that you have public here. I'm using public, but if you want to learn more about private repos, then I think we covered that in lecture number 4. You can visit there. So I will need one more repository. I'm creating that repository for my parent application. So I'll go to repos, and then I will click on new, and I will name it product1 GitOps, and then I will click on create repo. Now I want to mention one thing here, that we'll be storing our child applications in our respective repos. So if you look at the structure here, you see that we will be storing our child applications in this repository, and here as well we'll be storing this in our this repository. But you could also see a design where these child applications, the YAMLs for these child applications, are stored in the GitOps repository. So you could also see that design. Now nothing is good or bad. What I have done in here is I have kept the child applications in their respective tiers. Now how this is beneficial is, if let's say there is a junior DevOps admin who is managing these config repos and the respective applications for that, then it is easier role separation for me. So my junior admins will have access to these repos and the respective application, and then my senior admin will just have access to this repo where the parent application resides. Although you could also see a design where there is a small team or small application, there you would also see a single person has access to this repo, and this repo has both your parent application and child applications. Now I want you to clearly understand if that is the scenario. In that scenario, these repo URLs will change. Okay, and then let's do one thing. So we have created the repositories, we have created the 3 repositories. Now the next step is create and apply parent app. So let's go to Visual Studio Code. I will go to product1 GitOps, and then I will show you product1 root.yaml. Now here is our parent application. Now if you look at it, our parent application is an application only, and this application is managing multiple applications for us. So what we are saying is, understand, let me open this side by side for you so that I can explain this to you in a better way. So I will exit this below down, exit this below down, and then what I will do is I will split this to right, and then I will zoom out a little, and then I will go to view and word wrap this. Here is our root YAML, and here is our front end application CRD. Now see the critical differences. This is an application YAML, and this in this application YAML, what I have done is in parent application YAML, what I have done is I have defined two sources, because one source has my front end and second source has my backend. If you were using a microservices design and if you had 10 applications, 10 Argo CD applications, then you would supply 10 different sources here. Now I want you to know one more thing. Here we are discussing app of apps, but if we remove this concept altogether, and let's say you were using a single repository to store the configuration file of both your front end and back end, in that scenario as well you could use an application that had multiple sources, because you wanted that Argo CD application to deploy whatever is defined in that single repo. So in that scenario, you would be using one single Argo CD application to deploy both your front end and back end, and you will also see this design. But whenever you are adhering to proper GitOps practices, in that scenario, you will have a repo per microservice, because this also helps in segregation of duties along with segregation at large and reduces the blast radius as well. So keep that in mind. You can have multiple sources in your application CRDs. Here we have multiple sources because our backend and front end are distributed into different config repository. One is product one fe config, another is product one backend config, which is why we have mentioned both of these here. Now let's come to the critical point. Here I have sync policy automated. So what I'm saying is whatever is defined here and whatever is defined here, you sync that automatically. So once we create this Argo CD, what it is going to do is it is going to create both of these applications for us. Then we are saying prune is equal to true. So if for example I delete any of these applications from my source GitHub repository, then that will also be deleted from my cluster. Self heal is also true here. What we are saying is if someone deletes this application manually from my cluster, then you ensure that that application is recreated, that child application is recreated. Here we have not added this sync option section because we are not dealing with Kubernetes resources such as deployment services, service accounts and so on. So I hope this point is clear. Now that we have this understanding, let me close both of these. I will right click here. I will click on open in integrated terminal. I'll expand this a little and then I will run kubectl apply -f and press enter. And this says that this product one root application is created. So I will go to my browser. I already have Argo CD UI here, and then it says product one root and this is unknown, which is understood. It gives an error that I don't see anything in the repository, which is true because we have just created the repository. We have not uploaded anything there. So now let's do one thing. Let's upload our files. First, I will go to backend and then I will click on upload existing file. I will just decrease the size of this window and then I will go here, backend config. I will copy both of these here. And once these are here, I will click on commit changes and I will go to this one. This one has the front end config. So I will go and click here and then I will go one step back and then I will go in front end config. I will paste both of these here and then I will click on commit changes. And then while we are at it, we can also upload our application YAML here, the parent application YAML here. So I will click here and then I will go here, GitOps 1, and this we can just copy here. Understand that this is something that we are applying manually, but it is still being version controlled. And when you have your CI in place, all of these things will also be automated. But right now we created this manually, understand, but the child applications will be created by Argo CD automatically. So let's go here now and let's go to applications, and this should ideally create both front end and back end applications for us. So if I go here and then I click on refresh, this should now detect that there has been, you see, sync, okay, synced. Let me do it full screen, and you see both of these are created. Now understand, we are in product one root application, what we asked product one root to create. So if I go to my Visual Studio Code, if I go to product one root, we said that create whatever you find here, right? And what was there in this Argo directory, in this repo? There was these files, front end and back end child applications, which is why these are created and it is showing green. Now if we drill down further, if I go to applications, you see you have your backend here. And now what did the backend have? The backend had your service, your deployment, and it has created that. You see how this works. I told you, first there is parent, then there is child application, and then there are Kubernetes resources. That is what the flow is. Now let's do one thing. Let's go here. Now understand, if I want to check the health of my application, if this is healthy, I know my application or my product is all right, and that is what is important. So I just come here, and this might look, Varun, you can look both of these, they are in front of you, but imagine if you have 20-30 microservices, and then you just know that you have to look at this to understand the health of your entire product. It is so cool, and it makes manageability so much easier. So if I click here again, then this shows me this. Now what I can do is I can just go here, and then I can run kubectl get apps -n argo cd. Now press enter, and you see we just created this one, and both of these were created automatically for us, and the status for all of these are synced, which is what we want. And let me run kubectl get all -n product one ns, and we didn't have to create product one namespace manually because we used sync options where we said create namespace if it does not exist. And here you can see this is our front end service which listens on port 80. So let's use port forward and access this application. So I will run kubectl port forward and -n product one ns, then it is services, and then I want to port forward front end, and here I want to send anything that comes on my max host port 81 to cluster IP port 80. So that is what I'm doing. I'm port forwarding now. I'll go to my browser, and then let's run localhost 8081, press enter, and you see our application is accessible. As simple as that. Now I want to show you one more thing. You know that it is our product one root.yaml, this parent application, that is syncing both of these, and here I have said self field is equal to true. Now let's see what happens. Okay, if I come here and let me go to this tab. So if I run kubectl delete apps -n argo cd, and then what I want to delete is, let's delete the front end. Okay, I'll delete my front end. It says deleted. Okay, let me check these again. Sorry, let me run this again. You see it is again created. I just deleted the front end, but it is recreated. Now, why this is recreated? Because I have written self heal is equal to true. And if I go to Chrome and if I go here, then let me go to applications and let me show you one thing. We deleted the front end, right? You see, this was created a few seconds ago. This is how powerful Argo CD is. So understanding these points are important for you. And I feel that is all I wanted to cover. That brings us to the end of this lecture. You should now have a clear understanding of why the app of apps pattern is needed and how a parent application enables product level GitOps orchestration. We saw how the parent application creates and reconciles child applications, how responsibilities are separated, and how sync options influence behavior, all validated through a hands-on demo. In the next lecture, we will build on this foundation by introducing application sets, moving from manually defined applications to generating and managing them dynamically at scale. If you have any questions, feel free to ask them in the comments section and I will reply. And if this lecture helped you, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much. Hi, I am Varun Joshi and I welcome you to the 10th and the final lecture in our Argo CD Basics to Production course. In this lecture, we focus on scaling GitOps. We will start by understanding what multi-cluster really means in Kubernetes and why it introduces new operational challenges. From there, we'll discuss why application sets exist and what an application set actually is. We will then move on to hands-on demos, beginning with a multi-region deployment, followed by a deep dive into generators and templates, which are the core building blocks of application sets. We will walk through multiple real-world patterns using the list, cluster, Git directory, Git file, and matrix generators, and end by discussing how to choose the right generator based on your requirement. By the end of this lecture, you will have a clear framework for designing scalable production grade application sets. So let's get started. What is multi-cluster in Kubernetes? To understand why application sets exist, we must first understand multi-cluster Kubernetes and the operational pressure it creates on GitOps. So firstly, when someone says multi-cluster, I straight away think that okay, this team is dealing with multiple Kubernetes clusters, because multi-cluster is a generic statement. I do not know whether the multiple clusters the person is talking about are maybe logically interconnected or they are independent Kubernetes clusters. For example, if I am dealing with two projects like you see here, and each project has a cluster to its name, and both these projects, project 1 is dealing with application 1, 2, and 3, and project 2 is dealing with application 4, 5, and 6. In this scenario, both these clusters are independent in nature. They do not have a common application, common workload that is living in both of these clusters. Hence, I'm saying both of these clusters are independent. Of course, these are multiple clusters, but they are independent clusters who do not have any relation between them. Then, if I talk about operationally connected clusters, and the example for that you can see here. So here we have a single project, that is project 1, and project 1 has two clusters, cluster 1 and cluster 2. And as you can see, project 1 is catering three applications: application 11, application 12, and application 13. So the key point here is cluster 1 is also hosting application 11, 12, 13, and cluster 2 is also hosting application 11, 12, and 13. And why would you do so? You could be doing this because of multiple reasons. First reason that comes to my mind is failure domain isolation. What if you have your Kubernetes implementation in two regions? You have a Mumbai region and then you have a Northern Virginia region. God forbid, if Mumbai region goes down, then your application will still be accessible to the users because your cluster in Northern Virginia region is still alive. That is one reason why a single application could be using two clusters. Second is environment level separation. Maybe you want the cluster in which the production runs should only run production, not anything else. In that scenario as well, you could have two different clusters. One cluster could be catering to your production workloads, another cluster could be used by, let's say, development and staging workloads. So think like an architect to understand why a single application could be using multiple clusters. Third is geographic and latency requirements, and this is a genuine scenario. Maybe Cloud with Varjosh is a famous website now, and let's say users for this website are predominantly based in the US and in India. In that scenario, what I would want is I would want users who are accessing my application from United States must be addressed by the cluster that is in the United States itself. When I do this, what I as an architect or a design engineer ensure that whichever cluster is nearer to the user, that user is catered by that cluster. And then the last one that I want to discuss is compliance and regulatory needs, and why we are talking about this. Now, this is an important piece when I talk about data localization and data residency. So maybe my application, my government warrants that the data for the users of India should not leave India. In that scenario, I have no other option but to deploy a cluster in Mumbai or Hyderabad region if I'm talking about AWS. So essentially, in that scenario, I'll have to deploy my application in a cluster that resides in India. So for these kind of requirements, your application could be leveraging two different clusters. And here I am saying two clusters, but do not think of this as a hard limit. Your application, if the users exist in, let's say, in Europe and in UK and in Middle East, you may choose to deploy clusters there as well. And this is not something that is written on stone. It is done based on what your requirement is. So why we are talking about multi-cluster here? We are talking about multi-cluster here because when I talk about application sets, they are predominantly used in multi-cluster scenarios. But I want you to understand one thing very clearly, that even when you are dealing with a single cluster, you could be using application sets. And what are application sets? Why do we need it? We will be discussing all these things in detail as we progress with this lecture. So operate more than one Kubernetes cluster, that is multi-cluster design. Clusters may be independent or connected. This lecture focuses on operationally connected clusters, and we have already understood why teams adopt multi-cluster design. With this understanding, let's move to the next section. Why do we need application sets? Now, most of the topics that I teach, I feel understanding the why is extremely critical before we learn what that tool or that service or that functionality is doing. But in this specific lecture, since we have already understood a lot about Argo CD, what I want to do is first I want to tell you in one line what application set do, and then we can discuss why of application set. So understand, up until now what we were doing is we were creating Argo CD applications independently. So if we had a front end and a back end, we were creating an Argo CD application for front end and also for back end. Similarly, if you have an application one, let's say, and that application one consists of 10 microservices, then in a typical design, you would be creating 10 Argo CD applications, one for each microservice. Now understand what application set would be doing for you is when you create an application set will be creating the corresponding applications for you. So you do not have to deal with individual Argo CD applications. What you deal with is an application set YAML alone, and it is the responsibility of that application set resource, custom resource, to create Argo CD applications for you. So in simple terms, Argo CD application set helps you in creating Argo CD applications based on what you have defined in the application set YAML. As simple as that. Now let's understand why application set. Multi-cluster manifest explosion. Same app repeated across clusters and environments. And this is true, right? If I talk about an application for which you are dealing with dev stage and prod at a very high level, all those manifests are same. And if you want to manage that via Argo CD, you would have to create application YAMLs, Argo CD application YAMLs for all of those environments. I don't want that. What I want is I just define a single thing, and based on that single thing, rest of the things are created for me. Now, I would like to contrast this with what a Kubernetes deployment is. So what you do is you create a deployment, and in that deployment you have a template, and in that template section you define how the pods part of this deployment should look like. And then that those pods, inside those pods there are containers. So first you create a deployment YAML, and that deployment YAML will create the pods for you, and then those pods will have containers inside them. Similarly, if I talk about application set, you create an application set, and based on what you have defined, different application YAMLs will be created. And inside those application YAMLs, you would be defining how do you want to deploy the workloads, or where do you want to deploy the workloads. As simple as that. If you contrast this with what you already know, it becomes so much easier. And when I talk about deployments as well, you could create single pods, right? But what you choose to do is you create a deployment object, and in turn the deployment object will be creating pods for you. Similarly, here you create an application set custom resource, and under the hood that application set custom resource will be creating applications for you. Now, how all of this will work, we will understand that step by step. But for now, I hope you understand what is application set at a very high level. Next is manual cluster wiring. Each cluster requires its own application definition, and that's understandable. If you have a cluster in Mumbai and in Northern Virginia, and you have app1 deployed across both the clusters, both of these will require its own application YAMLs. Configuration drift at scale. Now imagine you have a multi-cluster design and you have to manage, let's say, 20, 30, 40 applications. It gets painful at scale to manage so many application YAMLs. What if I had something, and that something could create applications based on whatever I have defined? So that is what application set will do for you. Static by design, and this is understandable, cannot react to clusters being added or removed, because in application YAML you have strictly defined that this is the cluster you want to deploy to, and that's it. But this is a limitation. What if you have a robust environment in which clusters come and go? But Varun, why would clusters come and go? Maybe as part of your CI pipeline, you are bootstrapping a temporary cluster and then deleting that once the CI has completed successfully, or even when the CI has failed. To do those things, you can always have ApplicationSet do that for you, and we'll see how that works. And the last one is operational overhead. And for this point alone, I would suggest you explore ApplicationSet. Multi-cluster GitOps increases YAMLs and human errors. And I have seen this in real environments, that managing so many applications for Argo CD can become a pain. So we want something that sits at the top and orchestrates all my Argo CD applications for me. So now let's move on to what is an application set. First is application generation. Creates multiple Argo CD applications from one definition. Second is lifecycle management. Applications are created and removed automatically based on what you have defined. And we'll see how this works. No workload deployment. This is a critical point. When I talk about deployment doesn't care about the containers that are running in the pod. Deployment is a high level object. There is deployment controller, there is replica set controller, and then there is container runtime that will take care of most of the things. But from a high level, deployment does not care about the containers themselves. They care about the pod, they care about the desired state. I'm talking about the deployment controller. Here also the logic remains the same. Application set does not care about your workloads. It just cares about creating the applications. And then those Argo CD applications in turn are responsible for deploying your workloads onto your Kubernetes cluster. So this distinction is important. So if you have deployed an application set and you don't see your workloads being deployed, in that scenario, the troubleshooting should be first check whether the application set YAML is working correctly, and when it is creating the applications, are those applications behaving as expected. Only then you will be able to troubleshoot why workloads are not being deployed. So understanding this is critical. Last one is multi-cluster scaling. Makes GitOps declarative, consistent, and scalable. And this is true. Again, I want you to imagine that you are dealing with 50 microservices. If there are 50 microservices and I am being liberal as DevOps engineers, you could be dealing with hundreds of microservices. So let's say if you're dealing with 50 microservices, you will have 50 Argo CD applications, and imagine managing 50 YAMLs. It is painful, my friends. Even if you are using app of apps, it is still painful. Hence, we want something that will take care of creation and removal of Argo CD applications for us. And that is exactly what Application Set will do for you. Enough of theory. I know you have had a high level idea of what Application Set is. Now is the time to move to the demo section. And in the demo section, we will learn other concepts. But before I start this demo, I quickly want to do one more thing. I want to create both of these clusters, and then we'll walk through what we are doing in a little while. So what I'll do is I'll quickly go to my terminal, and if I do ls-l, you see I have different directories here, and all of these directories we'll be using in this demo. So what you can always do is, here is my repository, GitHub repository, and if this helps, please do star the repository. So I'll go here, and then I will go to lecture number 10, that is application sets. And here you see I have uploaded all the files that you would need to practice along with me. So I would encourage you to please practice along with me, otherwise these concepts won't stay with you. So let's go to our terminal, and here I have 01 EKS. So I'll cd into 01 EKS. I will press ls, and here I have two configuration files. We'll talk about these configuration files later, because I want the cluster to be created when we move to the actual demo. So I'll explain you what we are going to do in the demo first, and then we will move on to subsequent sections. So I will run eksctl create cluster -f. The configuration file that you should be using to create this cluster is this one, 01 eks Mumbai, and we'll see what we are doing in a little while. Okay, and I'll move to this terminal, and here as well I'm also in 01 eks. I will run here eksctl create cluster -f, and I want to use this configuration file that is for Northern Virginia. If you're not understanding this, it's fine. We'll be discussing this in detail once I move here. So our clusters are getting created. So let's understand what we are going to do in this demo. Multi-region application deployment using Argo CD application sets. What is our goal with this demo? Use one application set to manage applications across regions and clusters. So we have two regions, Mumbai and Northern Virginia, and clusters, and we have two clusters, one in Mumbai and another in Northern Virginia. So we have Mumbai and Northern Virginia. In Mumbai, we'll be creating 3 EC2 instances. I think the diagram has an error here because I think I'm creating only 2 nodes there, 2 worker nodes. Just a moment, folks. Let me quickly verify this. Mumbai 2, yeah. So we are creating 2 here and 1 here. Now, the Mumbai region will be acting as the Argo CD control plane. Control plane as in we'll be deploying Argo CD into the Mumbai region, which is why I have 2 nodes here, 2 worker nodes here, and a single node in Northern Virginia. I would suggest you have the same configuration so that your workloads are also deployed and Argo CD also runs smoothly. So application 1 will be deployed onto both of these clusters. Here, the Mumbai cluster will be serving my India users and Northern Virginia cluster will be serving my US users. Now, why Mumbai and Northern Virginia? We have discussed above. If you are using 2 regions or more than 2 regions, the reason could be regulatory and compliance requirements, and there could also be latency and user experience requirements, basis on which you have chosen to deploy your cluster onto 2 different regions or multiple regions. Now let's see what are we going to do in this demo. Step 1 is we will be provisioning 2 EKS cluster multi-regional. We have already started provisioning them, and we'll be walking through this step again because I want everyone to understand what we are doing. Do not just blindly follow. Step 2 is install Argo CD control plane. Here we'll be configuring Argo CD in our Mumbai cluster. In the third step, we will be onboarding Northern Virginia onto Argo CD. I want you to clearly know that when you install Argo CD in Mumbai region, Argo CD does not have any visibility of our cluster in Northern Virginia. So to make that possible, that is what we'll have to do. We'll have to tell Argo CD that this is a cluster, this is the Northern Virginia cluster that you are also responsible for, that you will be deploying resources onto this cluster as well. That is what we'll be doing in this step. Register Northern Virginia cluster with Argo CD. In step 4, we will be creating a Git repository, and this will be the source of truth for us. Whatever we define in this repository must be running in our EKS clusters, and we'll be doing this understanding the application and creating a repository in step 4. And in step 5, we will define and apply ApplicationSet. Here we'll be understanding the ApplicationSet YAML and will be working with it. In all these 5 demos, this step remains common, and we will be also modifying our Git repo. But all these 3 steps, they are pretty much the same. Now, I want to tell you about the prerequisites for this demo. So I'll go to my repository, and here I want to go to demo 1, and in demo 1 itself I have a demo prerequisite section. So your machine, your thin client must have AWS CLI and EKSCTL installed to follow along with me. Second is you must understand Kubernetes context. Now we will be dealing with two different clusters. Hence, I will be switching between Kubernetes contexts. Now, you can follow along with me because the commands are pretty simple, but I strongly believe you should not be running commands if you do not understand them. So if you don't have the understanding of Kubernetes context, then do watch this lecture. It's a short lecture where I explain how Kubernetes contexts work along with your kubeconfig file. Then third is you must have understanding of Helm. Again, you can follow along with me, but if you understand what you are doing, it makes learning so much fun. Fourth is you must have Argo CD CLI installed in your thin client or your laptop, so you can use this guide to install the same. So let's move to step number one, create an Amazon EKS cluster. So what we have done is, if I go to my Visual Studio Code, here is the configuration file that I am using to create the cluster in Mumbai. I am using an extremely simple configuration file. If you want to look at advanced workflows and how you would design a configuration file, I have two demos in this channel which talk extensively about this. So if I go here, if you go to this Kubernetes project playlist in my channel, then you can watch the stateful set lecture and the Kubernetes ingress lecture. Here we have a complex, not complex, we have simplified that, but you have a configuration file that uses a lot more parameters than what we have here. So it's a very simple configuration file. What we are saying here is you create a cluster with name this, and in this region you add these tags to the cluster resources, and then the CIDR for the VPC we are defining 10.10.00/16. Managed node group, we are asking it to create a node group which should have two worker nodes of type t3.small. So if you are using AWS credits, t3.small falls under that category. And similarly, we are creating a Northern Virginia cluster. Here, instead of 10.10, we are using 10.20/16, and then only one worker node is created, and rest of the things are based on the region that we are deploying this cluster. So this cluster will reside in Northern Virginia region, and we have already ran the command that will be creating the cluster for us. So the cluster creation is ongoing. So let's wait for this to complete, and I'll come back once this is complete. Now both my clusters are created. Here is my Mumbai cluster, and you see this prompt, we have the Northern Virginia cluster ready. Now let's see what we want to do next. So if I go to my diagrams, the second step is install Argo CD control plane, and we'll be doing that in the Mumbai cluster. Now I want you to know that when you run, when you create clusters, the current context will be pointing to the cluster that was created second. So that is the recently created cluster, which is Northern Virginia for us. So if I run, let's say, kubectl config get context and I press enter, you see there is an asterisk marked against the Northern Virginia cluster, which says that if I run commands right now, the commands will be running in the Northern Virginia cluster. But what we want is we want to run commands in the Mumbai cluster, because that is where we'll be installing Argo CD. So I'll quickly clear my screen first, and then I will run kubectl config use context, and I'll press tab, and this will be giving me two options because these are the options that are available in my kubeconfig file. So what I want to do is I want to go into the Mumbai cluster. So I'll press enter now. Now it says that the context is switched. So if I run kubectl get nodes now, I should see two nodes because I added two nodes in the Mumbai cluster. So this is understandable and this is pretty basic. Now I want to install Argo CD here. How will I install Argo CD? I will be using Helm for that. So let's go to the browser and let's Google Argo Helm repo. And the first link will suffice. And if I scroll down, here is the official repo. So this is saying that you can add this repo, then you can install Argo CD. So I'll copy this and I will add this repo in my local machine. So you should also have Helm installed, so ensure you have that. So if I now run Helm repo list, I will see that there is Argo repo added here. Now what I want to do is I want to run Helm repo update. So this will update all the chart versions, although we have just added, so the chart versions would already be the latest ones, but I have a habit of running this. So now we have run this. What I can now do is Helm repo. I want to search a repo, Helm search repo, and I want to search the repo Argo. And it will give me whatever is there in this repo. Now understand, there are multiple products by Argo CD that can be installed using this repo. So you see Argo, Argo CD, Argo rollouts, Argo workflows. What we want to install is we want to install Argo CD first. So what I will do is I will first run the same command again, but I will say in Argo, in the Argo repo, what I want to check is Argo CD. And in Argo CD as well, I want you to list down the versions that are available at my disposal. And I'll also add a less here so that we can see line by line. So here we are saying that within this repo, Argo CD has these many versions. Which version do you want to install? Now I want you to clearly know that when you are dealing with production environments, you would rarely see the latest version installed, and latest version is typically denoted by n. So you don't want n, you go with either n-1 or n-2. So in this demo as well, we will be installing the n-1 version, which is 9.4.0. I'll press enter space, and these are all the versions that are available and you can use them. I'll press quit to quit that screen. And now let's first create a namespace, because I want you to know that whatever Argo CD resources that we will be creating in the Argo CD namespace. Now do not think of all the resources that are created also implies application or workloads resources. I am talking about the custom resources that are available with Argo CD, such as applications, ApplicationSet, and so on. For them, we are creating a namespace that is called Argo CD. So I will run kubectl create namespace Argo CD. Now understand, all of these commands are running in the Mumbai region cluster itself. Now I will run Helm install. Let's call this my Argo CD. This is the release name. And I want to use the Argo repo, and within the Argo repo, I want to install the product called Argo CD. And for that product, I want a version, and that version is 9.4.0 like we checked. And most importantly, I want to add -n Argo CD here so that this gets installed in the Argo CD namespace. I'll press enter, and this should ideally deploy Argo CD pods onto our Mumbai cluster. So let's wait for this to finish, and then we'll be accessing the Argo CD UI. And most of this we have already done in our third or fourth lecture, I believe, where we installed Argo CD. I wanted to do this along with you in Amazon EKS cluster. Now to fetch the password, I'll just copy this and I will paste this here. It will give me the password, and this is the password I can use. I don't have to copy the %sign, but I also want to port forward so that we can access the Argo CD UI. So I will run kubectl port forward -n Argo CD, and then in that I have a service, and that service is called my Argo CD server. That's the name of the service. And then I want to send anything that comes on my port 8080 on my local host's port 8080 to port 80, or you can also use 443, because that service that gets created, if I run here kubectl get svc -n Argo CD, that service listens on 443 and 80. So this is the service. So here I will do this and press enter, and the port forwarding has started. So now what I can do is I can go to my browser and I can run here localhost 8080, press enter, advanced, proceed, and voila, here we are, admin. And then the password, let's copy that again. I don't think I copied that, so I'll copy this and then I will paste this password here. And I don't want to fetch the password again and again, so what I'll do is I'll also change the password here. Update password, current password is this, new password is this, new password is this, and I will save new password and it will log me out, and then I'll have to log in again. So if I click on application, this has logged me out. I will write admin, my password is this, and then I will log in into this. So our Argo CD is now accessible. So the second step is also done. Let's go to our diagram and see what is that we want to do next. Step 3 is register Northern Virginia cluster with Argo CD. So let's do that. I'll go to my terminal. I will clear my screen and let's use Argo CD CLI now. So let's run Argo CD cluster list. Now this command has failed. It is saying unauthenticated. See, understand, we are port forwarding, but my Argo CLI does not know to which Argo CD instance I want to connect to, because there could be multiple Argo CD instances that are there in my multiple clusters. Maybe I have 5 different Argo CD installations. In which Argo CD installation you are running this command? So what I will have to now do is I will have to first log in into the Argo CD instance where I want to run these commands. So I will run Argo CD and I will Argo CD login localhost 8080. I'm saying login in here. So yes, and it is asking for the username and then it is asking for the password. So I will enter these details and it says login has been successful. Now if I run Argo CD cluster list, now we see there is a cluster and the name is in cluster, and this is an important piece to understand. Once we attach Northern Virginia cluster, that cluster will also come here, but it will be identifying that cluster with a different name. In cluster implies this is the cluster where I am running, where the Argo CD control plane is running, which is why you see in cluster here. Now let's run the command to add the Northern Virginia cluster. I will run kubectl config get contexts, because it is the contexts that we would be using to add that cluster. So I will run Argo CD cluster add, and let's run -h here. And there are so many options that you could be using, but I want you to concentrate on an option which will help you add labels. So you can also label your clusters based on your requirement, and how powerful these labels are we will see in a future demo in this lecture itself. But for now, just understand you have the option to label your cluster. Now here what I will do is I will run Argo CD cluster add, and then let me just copy the context of the Northern Virginia cluster. So this is the context there. This is, I'll copy this and then I will scroll down and I will paste this here, and then I will press enter. So this is asking, this will create a service account Argo CD manager on the cluster referenced by this context with full cluster level privileges. Do you want to continue? And this is the most important piece. Someone is right now thinking, Varun, your Argo CD is accessing the Northern Virginia cluster, but how does it authenticate to the Northern Virginia cluster? The truth is it does not. Right now what is happening is the authentication information that is being used is picked from the kubeconfig file, and I am the one who created the cluster right now, and I have full authorization in the Amazon EKS cluster that is in Northern Virginia, which is why I have the privilege of creating a service account Argo CD manager. And if you check the logs of the Northern Virginia cluster, you will see that this service account was created by Varun.Joshi, because that is the user that is running the commands in that AWS account where this cluster resides, the Northern Virginia cluster resides. So hence I will press Y. So the important piece I want you to know, this command is reading the authentication details from my local kubeconfig file, then connects to the Northern Virginia cluster and creates the required service accounts. Now after that, how it works, we will see that later, but for now I want you to understand this point very clearly. So I'll press enter and you read what all it is creating, and finally it says the cluster is added. Now if I run Argo CD cluster list, you will see that you have another cluster added. Now I want you to know very thing very clearly. Application set is of course the topic we are discussing in this lecture, but if you want to deploy to different clusters using your Argo CD control plane that is in Mumbai cluster, you will follow the same steps. You will have to add a cluster where you want to deploy the resources, and only then your application YAML will be able to deploy the resources onto that cluster. So first the cluster must be known to Argo CD to deploy resources onto that cluster, which is what we are doing right now. Our demo is application set, so we'll be concentrating on that part. But if you want to deploy onto different clusters, even when you are using plain application YAMLs, Argo CD application YAMLs, you will adhere to the same process. Now that the cluster is added and it is also visible, see this cluster has a different name. And again, when we ran the -help command, you also saw that you can also give a name to your cluster, but here we will leave it to the default. So if I now also go to the Argo CD UI, I go to settings and I go to clusters here, you will see that both of these clusters are added. And if I click here, you see this cluster, if I click on edit, does not right now have any labels. Now this is important because we are going to use this in a future demo. Now the cluster is onboarded. Let's see what we want to do next. So I'll go to my diagrams, and then step 4 is create the Git repository. So I'll go to my browser now. I will go here, and then let's go to the very top. From here I will open link in new tab. I will go to repositories. I will click on new, and I'm going to call this app1 config, and I would encourage you to do the same because all the YAMLs that I have uploaded, they are deploying onto this repository. And of course you must also change the GitHub username. For me it is cloud with Varjosh, so you will have to make modifications in the ApplicationSet YAML. We'll just see that after we create this. So this must be public, and if you want to know how we deploy onto private repositories, I've already covered that as part of this course somewhere else, so watch that. App1 config, for simplicity we are using a public repo here. I'll click on create repository, and this has created a repository named app1 config. Now let's see what we want to upload in this app1 config. So I'll go to my Visual Studio Code, and here I will minimize this 01 EKS. I will go to 02 app1 config -repo. I'll expand this. Let me also close this. You see we have two directories here and one ApplicationSet YAML. I don't want you to worry about ApplicationSet YAML right now. I want you to know that we'll be uploading this Mumbai and Northern Virginia, both of these directories, onto our app1 config repo that we just created. So if I expand this, Mumbai has a directory manifest, and in turn that manifest has 3 Kubernetes object YAMLs. It is a config map which just displays this is Mumbai because we are in Mumbai directory. There is a cluster IP service, and then there is a simple deployment YAML which is using this config map to display the regional message that we have added. Then we are using Nginx image. Extremely simple, no rocket science, is basic Kubernetes concept. And similarly, Northern Virginia has stuff related to Northern Virginia. The config map there will say region is Northern Virginia. The deployment serves user in the United States. So let's go to our browser and I will click on upload an existing file. So what I'll do is I will quickly reduce the screen size here, and then I will go here and I am in 10 application sets. From here, what I will do is I'll go to app1 config repo and I will just move these here, and this will start the upload, and then I will commit my changes. So let's wait for this to finish. This has finished. I'll click on commit changes. So our repository now has all the files that are needed for this demo. I want you to concentrate that the root of the repo has Mumbai and Northern Virginia, and then both of these have manifests, and only then the respective object YAML exists. So now let's go back to our Visual Studio Code, and let me just full screen this. And now let's go to diagrams and see what we want to do next. So step number 5 is define and apply application set. So let's go to Visual Studio Code and I will minimize this, and then let's go to app1 application set YAML. So this is the application set YAML. Again, I want to go to terminal and want to show you something. I will run kubectl API resources, and here what I will grab is anything that is related to Argo, and you see application sets are there at our disposal. So when we installed Argo CD into this cluster, applications, application sets, and app projects, these custom resource definitions were already added, and we are creating a custom resource called application set using this custom resource definition. So that is the reason you are able to create this YAML. Whatever is defined here, the kind, the API version, all of these you can fetch from here as well. Now let's see what we are doing. We are calling this application set app1 multi-region. Namespace is Argo CD. Under the spec section, we have this template, and I'll explain what this is in a little while. But for now, I want you to concentrate on these two blocks. There are generators and there are templates. In simple terms, generator define how many applications should be created and for whom. I told you that application set is responsible for creating Argo CD applications. But how many Argo CD applications? For whom are we creating Argo CD applications? Those things are defined in generators. Now, based on whatever is defined here, so for now, we are using a generator that is of type list. So we are saying that we have two clusters right now, and you must be creating Argo CD applications for both of these. So in crisp summary, it is defining how many applications must be created and for whom, that is generators. Then the second part is template, and I want you to contrast this with something that you already know. So let me do one thing. I'm bringing a normal Argo CD application YAML here, and I will split this to right. I will close this. I will minimize this so that we can see line by line. I will go to view and I will also word wrap this. And I also want to word wrap this. Now see, whatever is inside the template section is what you earlier used to define when you were creating plain applications. Nothing has changed. You still have a source, you still have a destination, you still have your sync policies and all of those options that we have discussed in the past. You still give a name to your application, you still define a project. It is the same thing. And now what I explained before about the Kubernetes deployment creating pods and pods creating containers, that analogy will make much more sense now. When you are dealing with deployment YAML, inside the template section of that, what do you define? You define how the pod should look like. In application set, what you are defining inside template is how the application, the Argo CD application should look like. As simple as that. So template in essence describes the Argo CD application that will be generated, and how many applications will be generated depends on what you have defined in generators. And my dear friends, if you have understood this point, you have understood the entire application set. And I am not joking 1%. This is all there is to application set. Now let's see what all are we doing here. I will close this one so that we have more real estate, and I'll bring this because this alone was looking a little awkward. Now we have understood what generators and what templates are. Now let's see what we are defining here. So we are dealing with a generator that is of type list, and there are multiple other generators. For first, what I want to do is I want to deploy end to end using this single generator, which is the simplest one but extremely powerful. You would see this used in production when you have small environments and you want to use application sets. And after this demo is complete, I would encourage you to propose using application set in your project if you are not already using them. It's very powerful, trust me. If there is a use case, then do propose that, but do not introduce unnecessary complexity. You should only have something if it eases your job, not another thing to manage. It should have a real use case, and if there is, then I would encourage you to do that. Now let's come back to list generators. Now what is here is we have elements. Now elements has two items. The first item defines region is Mumbai, and this could be anything. These are just variables that you are calling here. These are key value pairs, and you are calling them from the template section. So you can call this region as well, as long as the subsequent template is calling the right thing. So for now, let's call this region. I'm saying the region is Mumbai. Destination name is in cluster. This is important. This should not be messed up. This could be anything, but this must be defined properly. This must be defined properly, because when you run kubectl describe, what you see should make sense to you, which is why I have proper nomenclature always. So if I go to my terminal, you see here are my two clusters, and one is in cluster and one is this, and which is why here there are two destinations. First destination is in cluster and the second destination is this one. And then I'm also defining the namespace. I'm saying the namespace for this would be app1 Mumbai NS, namespace for this would be app1 Northern Virginia NS. Now let's see what magic is happening in the template section. Metadata name is, I want to call the application that gets generated app1 hyphen dot region. And what is dot region? Dot region is Mumbai. So first app1 Mumbai, and then it will go here. What is the path? This is the repository that we just created. You have to change this name if you are following along with me. And then target revision is main. That's fine. Path, I'm saying where are my manifests? My manifests are located in dot region, that is Mumbai, and inside that there is a directory called manifests, and that is the structure we have in our git repo. So you have Mumbai, you have manifest, and then you have destination. Destination is what is the name of the destination, and you just correlate it with this one. Okay, if I move this here and I again split this to right, you had the destination here as well, and you provided this destination like this. And here what I'm saying is the destination is pick up from the destination name. So it is in cluster, and then it is Northern Virginia, this one. And lastly, namespace is you pick from the namespace itself, and here it will pick. Now I want you to know one more thing. It works as a for each loop. If you are programmers, you would know for each loop. It will run, this template will be applied for whatever is defined here. So the first application that will be generated will be for using these details, and the second application that will be generated using these details. So once these application YAMLs are created, your resources will be deployed onto our clusters accordingly. And again, I will just give you a one liner about this. Sync policy is automated, so sync automatically if you see that the desired state has something new, has been modified. Then you have prune says if something is deleted from the desired state, you ensure that our cluster also has that deleted. Then there is self-heal. If some modifications are done in your live cluster, then those changes must be reverted based on what is defined in Git. Now prune true is not just applicable if you are deleting any resources. If you are modifying any resources, those things will also be applied onto the live cluster. Then I have sync options. Here I'm saying if the namespace does not exist, you must also create that namespace. I hope you have a clear understanding of application set YAML now. Based on this understanding, we will be applying this manifest. So let's go to our terminal. I could have opened an integrated terminal too, but let's go to iterm itself. So I will just come one step back. ls, I'll cd into 0 2, and if I run ls, I want to apply this application set manifest. So I will run kubectl apply -f app1. This I'll press enter, and this says app multi region created. So if I now run kubectl describe app set, that's the short name for application set -n argo cd. What's the name? It is app1 multi region. You can see that these are the status messages which are what we should be seeing. All applications have been generated successfully generated parameters for all applications and so on. And this is whatever we have defined. And if I run a simple get command, then it will list out all the application sets that exist in our cluster. And this one oh sorry, it should be get, and you see there is one. Now if I run kubectl get apps, and apps is the short name for applications, you will see app1 Mumbai and app1 Northern Virginia, and that is what I told you. So if I go to my Visual Studio Code, here what did we say? We said that the application must be called app1 hyphen dot region, and what is defined in dot region? Mumbai, Northern Virginia. So it ran 2 times because I told you it works like a for each loop. So this template was applied first to this part and then to this part, and then 2 applications were created, and these are the 2 applications that were created, and the sync status is also synced. So if I run kubectl get pods hyphen a, because I want to see all the pods, then what you see here, there is a namespace app1 Mumbai NS, and you see there are 2 pods here because in our deployment manifest we said that we want 2 replicas. See, it is so simple. And now let's see the interesting part. So if I go to my browser and then I go to my Argo CD, you see app1 Mumbai, app1 Northern Virginia, and you see how powerful that is. We did not deal with 2 different application YAMLs. We just had to deal with the application set, and that application set created the resulting applications for us. So this was the Mumbai cluster. So let's do one more thing here. If I run kubectl get svc, I'm doing this only in the first demo. Rest, I mean, I hope you will build that understanding yourself. So svc hyphen n app1 Mumbai. We are in the Mumbai context right now. The commands are running in the Mumbai region. So if I do this, I can run kubectl port forward and -n. I want to deal with the Mumbai namespace, and then I want to services. What is the service that I just created? App1 Mumbai svc, and then let's 8081, and this is 80, I believe, and let me press enter. So if I now go to my browser and I run localhost 8081, then I should see whatever was displayed in our config map. Application sets demo, region is Mumbai AP South 1, this deployment serves users in India. Now let's do one more thing. I will exit this and now I will switch my context. kubectl config use context, and I want to use the Northern Virginia context, and I'll press enter. And then I will run kubectl get pods -a first so that I can show you that in Northern Virginia as well, 2 pods were created. And that is so cool. So if I now run kubectl port forward -n app1 Northern Virginia, that's the namespace, and then I can add services, and there is one service that is named this, and then I will run 8081, and whatever comes to 8081 on my local host, you send it to that cluster IP service that we have defined on port 80, and then it will send it to the respective pod. So I will go to my browser again, and this time I am forwarding it to 8081. So if I hit refresh, you see ApplicationSets demo, region Northern Virginia. This deployment serves users in the United States. I hope you have understood this. Now that we have this understanding, let me just switch back to our Mumbai context, because now we'll be seeing what is happening in that cluster often. So kubectl config use context. I want to use the Mumbai context now, and press enter. I'll clear my screen. kubectl get nodes, and this should show me 2 nodes. This is fine. I hope you have understood how list generators work and how application sets work in general. Now that we have this understanding, let's go to demo 2. So I will go to my Visual Studio Code now, rather my browser, and here I want to go to the repository for this lecture, and then I will go to, so this demo we have already done. Now I want to go to cluster generator, that is demo 2. So what will cluster generator do? Cluster generator creates Argo CD applications by iterating over Kubernetes clusters already registered in Argo CD. Clusters are selected using labels, and one application is generated per matching cluster. So imagine with list generator, we had to define 2 items in that list, correct? One, our Mumbai cluster, and second was our Northern Virginia cluster. What if I could add a label, let's say app is equal to app1, and then let application set deploy applications, create applications for the clusters that have app is equal to app1 label? Wouldn't that have been simpler in our demo, right? Because here we defined with list generators, we defined 2 items within the list. Imagine if you had 10 clusters, you would have to have 10 items in the list generator. And then based on that, Argo CD applications would have been created for you. But what if I can just say any clusters that have app is equal to app1 label, you create an Argo CD application for that cluster. And that is exactly what we are going to do, my friends. So first, let's do one thing. I'll go to my Visual Studio Code. I will minimize this thing. I will straight away go to cluster generator. And here our architecture, when I talk about the GitHub repo architecture, that remains just the same. It is that right now with list generator, we were defining 2 things, but with that we'll only define 1 thing, and let's see what that 1 thing is. This is the YAML. Everything else remains the same, and I just remembered I did not explain you this. So go template implies that it is true, so that implies you can use these curly braces like we have used in Helm, so it adheres to the go templating syntax. And then this is an important piece. Go template options missing key is equal to error. So what this implies is, if someone is using a variable that is not defined in the generator section, then fail that, because we want that. So for example, if I go here, if I show you this application set, If we would have not defined any region here and we were calling the region here, that wouldn't have worked. So what this is saying is, if user has any variables that have not been defined and they are used here in the template section, then you just fail. So that is what this section is doing. It's pretty simple to understand. So I'll go here. Now see the magic. I'm saying you run this template, you create the Argo CD applications for any clusters that have app is equal to app1 label. So let's now add labels and do this. So I'll go to first my terminal, and here what I will do is I will run kubectl delete app set and -n argo cd, and there is only one app1 multi-region. I'll press enter and this will delete it. If I go to the browser, you see how easy the manageability is. I just delete one object and all the applications are gone. Boom. It's so simple, right? So now I go here. Let's do one thing. I'll first come one step back, ls cd into 03 cluster generator. And from here, I will run argo cd cluster add, and here I will have to add the context. So this is the same command that we used before, if you remember. Okay, so if I run that again, kubectl, hold on, kubectl config get contexts. Now if I run argo cd cluster add, I'm adding the label in the Northern Virginia cluster first. So I'll copy this, I will paste this here, and then I will add hyphen label. What is the label that you want to add, my friend? I want to add app is equal to app1, and then I want to add one more label, and this label I will call region is equal to n Virginia. Now understand that these labels will be stored somewhere with the identity of the cluster, and we'll see where these are stored. But for now, I also have to add one more flag, hyphen absurd, because this will say this cluster is already added. So this is kind of an force update. So if I just have it removed and then press enter, this will fail, saying that you will have to use absurd if you want to add it. So we'll add absurd. So you already exist in namespace. This is fine. Service account, this exists because this cluster was already onboarded. That is why it exists. But here in this step, we just wanted to add labels. Yeah. Error, invalid argument, use absurd flag to force update. So that is what we have to do. So I'll write absurd. Yes. I press enter, and yes, and this will add the labels, and you can verify that the labels are indeed added if you go to the UI as well. So I'll go to the UI and I'll also show how you can verify that using CLI. So I'll go to my browser, and here is the Argo CD UI. If I go to settings, I go to clusters, I go to this cluster Northern Virginia, I see labels are added here. Now I will use the UI to add the labels in our Mumbai cluster. So I'll come here. So I'll click on add. So I'll app is app1, and then region here is Mumbai. Perfect. And then I will scroll up and I'll save this. So now we have labels associated with both of our clusters. So ideally what should happen is, once we apply that application set, our Argo CD applications should be created for both these regions, for both these clusters, and then we should also see resources deployed onto these clusters. So I will go to our Visual Studio Code to show you one more thing. So here I'm saying app1 metadata dot labels dot region. Where is metadata? Where is labels? Where is region? How is this working? So let's understand this. So I'll go to my terminal again. I will clear my screen. I will run kubectl get secret -n argo cd. And you see these two secrets are of interest. These two secrets are the ones that are responsible for storing that information. So let me run one thing. Kubectl describe secret -n argo cd, and here I will name this cluster, let's say Kubernetes, this one. And if I press enter, you see This is the information we are calling there. Okay, and this is the secret that is referenced by application set when you define like this. So what we are saying, name is app1. What should be filled here? You take the value, go to metadata, go to labels, and check the region. Go to metadata. Let me just get a YAML for this so that it is more easier. -o YAML. I'll come here. I will add a get here because this won't show that metadata to us. So I'll add get here. I'll press enter. So now you see what we are saying. Metadata labels region. Metadata labels region. The application that will be created for Mumbai will have name app1-Mumbai. And then here we are saying what is the path? Path is metadata labels region. What is the region? Is Mumbai /manifest. And if I go to this repository, that is exactly where my manifests are. We have two directories there, Mumbai and Northern Virginia. It will first go to Mumbai and manifest, and it will create an application based on that. And here as well we are saying what is the destination. Destination is just name. It will be creating an application based on whatever you have defined in the template. I hope these things make sense to you. So now let's go to our terminal and apply this manifest. So ls, this is yes, just let me quickly verify. It is yes, cluster generator.yaml. So kubectl apply -f cluster generator.yaml. So if I go to my browser, I go to applications, you see app1 Mumbai, app1 Virginia, they are synced and healthy. And if I go to my terminal, if I run kubectl get app -n Argo CD, you will see both of these applications are synced and healthy. App1 Mumbai, app1 Virginia. That is what we named our applications here. Now let's move on to the third demo. I'll go to my browser and I'll go to my GitHub notes, and then I will go to top, and then from here I will move on to Git generator. So what we have learned thus far is list generators and cluster generators. Cluster generators work on the premise of labels. List generators work on the premise of items that are defined in the list. Then I want to discuss Git generators. Now read the definition and you will understand what this is doing. The Git directory generators. Now Git generators are of two types, directories and files. We'll first discuss directories and then we'll move on to files. The Git directory generator creates Argo CD applications by discovering directories in a Git repository. By discovering directories in a Git repository and deploying the manifests contained within them. So, for example, if I have a repository and let's say I have created three directories there, dev, stage, and prod, then create that mental picture. It will create Argo CD applications based on those three directories. Each matching directory represents a deployment unit, and one Argo CD application is generated per directory using a shared template, and that shared template is defined in the application set YAML. So without wasting any time, I directly want to take you to the application set manifest. And with this example, we are going to change the directory structure as well. So what I will first do is I'll go to item. I will run kubectl delete app set -n Argo CD. I only have one application set. I want to delete this. And then I want to verify that it is indeed deleted. I should not see any applications here. I don't see them. I'll go to my Git repo here and I want to delete these directories. So I'm first in Mumbai and then I will go here, delete directory, commit changes, and then I want to go to Northern Virginia. I want to do the same here, delete directory, commit changes. I want to reduce the size here. I want to go to app1 config and then I want to go to add files, upload files, and I'll go here, and now we are in Git directory generator. So I am copying this Mumbai directory. I'll show you the structure for this in a little while. Just be patient with me. I'm copying this here. Let it copy, and then I will commit the changes. Okay. Now I will again do full screen here, and then I will go to Visual Studio Code. So now see what the structure is. Cluster we have discussed, Git directory generator. I will close this one. So we have a directory, and then we have the application set YAML for Git directory generator. So we have Mumbai here. Mumbai has three different directories: dev, prod, and stage. Important to understand, there is first Mumbai that resides in the root, then there is dev, then there is prod, then there is stage. And then dev has another directory called manifest, and inside that we just have a deployment YAML, and it's a simple deployment YAML that says app1 dev. Prod will say app1 prod, and so on. And prod and stage have two replicas, and this one just has one replica. That's the only difference, but that is not what we are going to discuss here. We are more concerned about Argo CD application set here. So I'll close this one, and then what I want to now show you is the application set YAML, and this is what changes things for you. Name is app1 git directories, that's fine, but in the generator section, what I am saying is you go to this repository. Okay, the revision is main, and then I am defining a path here. So what I am saying is you generate Argo CD applications for anything that you see inside Mumbai. And what do I see inside Mumbai? Inside Mumbai, I see dev, prod, and stage. So essentially, there will be three Argo CD applications created. Understand, if I would have just marked a slash here on or an asterisk here, it would have just created one Argo CD application, and that would also not work fine. And why one? Can anyone answer it? Because I just have Mumbai at the root. So I told you in this discussion here that each matching directory represents a deployment unit, and one Argo CD application is generated per directory using a shared template. So if you only had Mumbai, then it would just create one Argo CD application. But we have said that your path is in the Mumbai directory, which is available at the root. You have multiple directories inside Mumbai, and for all those directories I wanted to create an Argo CD application, and that is exactly what ApplicationSet will do. It will create three Argo CD applications for dev, prod, and stage. This is the generator part. Now let's see the template part as well. Now template, we are saying name is fine, but what is path dot base name? What is dot path here? What is dot path dot base name here? What is base name to begin with? So let's understand that part. So I'll go to my browser and I will scroll down. I'll scroll further down. Yeah. So when you are saying this thing, so dot path is an object, and that path has path Mumbai / dev. So this is the path. So understand, it is three. Okay, we have inside Mumbai, we have dev, stage, we have prod. Here I am only discussing dev. So what is, if I go here, what is the path? Path is Mumbai / dev / stage / prod, right? So here we are saying first is path is Mumbai / dev. What is the base name? The base name is dev, the name of the directory. So for stage, it will be stage. For prod, it will be prod. Segments is Mumbai and dev, different directory structure. So first is Mumbai, and then there is dev. So this segments is defining that. So inside path, you have all these available at your disposal. So when I say dot path dot base name, what is dot path dot base name? Dot path dot base name will result in dev or in stage or in prod, because dot path is this. What is base name? What is the value here? The value here is dev. which is why, as you know, it will run 3 times because there are 3 Argo CD applications. There are 3 directories in this path. First, it will run for dev. This will be filled with dev, app1 dev. Then it will come here. Dot path, dot path. What is dot path, dot path? In dot path, what is path? Path is Mumbai /dev. Hence, this will be filled by Mumbai/dev/manifest. And my dear friends, that is our directory structure. Inside manifest, we have the deployment.yaml. And this entire process will repeat for stage and prod as well. So the source is this, the destination is this. We have templatized, and based on our template, our Argo CD applications will be created for 3 things: dev, stage, and prod. So simple. Once the basics are clear, everything becomes a breeze. So let's go back to our terminal. And here we have already deleted the cluster generator. So I'll go one step back. I will cd into 04 git directory generator, and I will run kubectl apply -f. I have git directory generator here. Press enter, and it says app1 git directories created. But I want you to notice one thing, okay? We are not deploying to both the clusters. We are only deploying to the Mumbai cluster here, because if I go here, we have just supplied one repo here. Now we will be working on a scenario where we will be deploying dev, stage, and prod in both Mumbai and Northern Virginia. But for now, we are only deploying onto a single cluster. That is why I said usage of ApplicationSet is not just limited to multi-cluster designs. You can also use this with a single cluster, and that is exactly what we have done. Now here we just had dev, stage, and prod. Imagine 50 microservices. This would have been a perfect solution for that, even if you are dealing with a single cluster. Anyway, with that said, let's go to our browser, and if I go to applications here, you see there are 3 versions deployed: app1 dev, app1 prod, app1 stage. And if I go to my terminal, if I run kubectl get pods -a, you will see there are 3 namespaces: dev namespace, prod namespace, and stage namespace. And dev namespace, you see 1 pod there, and prod and stage will have two pods, because that is what we defined in our deployment manifest. Another thing to understand is, if I go here, you already know this ran 3 times for whatever was there in this directory, Mumbai directory. We have 3 subdirectories there, which is why ApplicationSet created 3 applications, and all these names have been defined via our template. So app1 path base name, that is why our applications is called based on this: app1 dev, app1 prod, and app1 stage. I hope this makes sense. Now let's move to the next generator type I want to discuss. So I'll go back here, I'll go to top again, and then let's look at git generator files. Now see, the git file generator creates Argo CD applications by reading structured data from files stored in git. Now with list, what were you doing? You were defining everything as items, right? But with git file generator, what you can do is you can make your ApplicationSet YAML a little neater by defining whatever you want to do in a separate file, and then version control that file. Cool, right? So each entry in the file represents a logical application definition. One Argo CD application is generated per entry using a shared template. So in this model, git configuration files are the source of truth. I do not want to read these theory points with you. I will let you read them, but my main motive is you understand the foundations, and then you can do rest of the things yourselves. So I'll go to my Visual Studio Code again so that I can explain you what we are going to do in this one. So 05 git file generator, I'll expand this. First, I'll close this one. So here we will be deploying onto both of our clusters like we did with our list generator. I want you to correlate this with list generator. In list generator, we were defining all those items in the list, right? Here we will be defining those as a version controlled YAML. So this is our YAML, which is just saying name is this, region is this, cluster is this, namespace is this. So we could have any keys here as long as we are calling these keys appropriately in our application set manifest. So let's open our application set manifest as well alongside this, and I will move this here. Then I will split this to right. And then first let's do one thing. Let's upload these files into the repository. Again, we have Mumbai has manifest, and then we have deployment. Here we have Northern Virginia has manifest, and then you have the deployment there. So I will have to version control clusters.yaml as well, because that is what my application set is referencing in the generator section, as you can see here. So let me first do this upload, and then we'll understand the application set YAML. Okay, I'll go here. I will go to Mumbai. I just have to delete this one. I'll go here and I will delete directory and then commit changes. Okay, I understand what I'm doing. And then let me reduce the screen size. I'll come here and then I will go to add file, upload files. I'll go here, come one step back, 05 git file generator, Northern Virginia, Mumbai, and then clusters.yaml. So in actual production implementations, of course, you will also version control your application set YAMLs. I hope you already know this because you have been following my course since day one of Argo CD basics to production. I'll again full screen this, and then what I'll do is I'll just commit changes, and yeah, so Mumbai manifest and clusters.yaml is also here. So now let's go to Visual Studio Code and understand the YAML first. So here I will just quickly view, I will word wrap this. So rest is the same. Okay, so here you have repo URL. I'm saying go to this repo, revision is main, files, the path is cluster.yaml. Now if this was there in a subdirectory, let's say, then you would have specified that path, but cluster.yaml in our case resides in the root of the repository, which is why we have just mentioned refer to cluster.yaml. And cluster.yaml in our scenario has these two things defined based on which the applications will be created. So what we are saying here is in the template section, we are saying name is just name. So app1 Mumbai and app1 Virginia. And then in the path, we are saying in the source, this is the source repo. Target revision is main. Path is you go to region and then you look at manifest. What is dot region? Dot region is Mumbai. Inside Mumbai, you have manifest, and that is what we have defined here. So you have Mumbai, you have Northern Virginia. Inside that, you have manifest. It is extremely simple, and the same thing we are doing here. So and dot cluster, again we have defined what the name of the cluster is, that where we want to deploy our resources, the destination, and the namespace is also specified here. So very simple. Okay, so if I come here now in my terminal, I can just go one step back, and before I do that, let me also delete the application set that we created for git directory. Okay, so kubectl delete app set -n argo cd, and we only have one, right? This one. So now we can run kubectl apply -f, and then I want to go to 05, and here I want to deal with git file. I'll press enter, and this says it is created. So now let's go to our browser, and if I go here, previous was deleted, app1 Mumbai, app1 Virginia, and that is what we defined in our YAMLs, app1 Mumbai, app1 Virginia, and this was referencing this for the name of the Argo CD applications, which is why we see app1 Mumbai and app1 Virginia created for us. And both of these are synced and in healthy state. Extremely simple. So once you build the foundations from the very root, everything just clicks. Okay. So now let's go back to our browser and see what I want to discuss next. So here git generator files we have already discussed. And now let's go and talk about the last one that I want to discuss in this lecture, that is matrix generator. So this is our demo 5. Firstly, what is matrix generator? One thing very clearly, matrix generator does not create any intent. Okay, matrix only combines intent that already exists elsewhere. Varun, what are you saying? See, the matrix generator creates Argo CD application by combining multiple generators and generating an application for every valid combination of their output. So matrix is essentially combining different generator types to produce your applications. So first, let's do one thing. I will quickly delete what we have in these directories in my repo. Delete directory, commit changes, Northern Virginia as well. Maybe it would have been simpler if I did this using, CLI. Anyway, commit changes. This is done. So our repository is now empty. So first, let me tell you what we are going to do. So in this, I'll go to Visual Studio Code. I'll close this. I'll close this. I'll close this. And then I will go to 06 matrix generator. And here what we are doing is we have 3 directories: dev, prod, and stage. And all 3 are sitting at the very root. In matrix generator, we are combining 2 different generators. So first generator that we are combining is your git directory generator we have just discussed. So what it will do is it will check, okay, dev, prod, and stage. There are 3 things that are defined in the path. You see the path here is asterisk. So anything that you see at the root, so at the root, what it will see: dev, prod, and stage. So it will be creating 3 applications based on this: dev, prod, and stage. Now the second one that I am using is the list generator. Here what I am saying is, I'm saying do this for 2 regions that I'm defining here. Do it for Mumbai and also do it for Northern Virginia. So understand what will happen. Here we will see 6 Argo CD applications created: 3 for the Mumbai cluster, dev, prod, and stage; 3 for the Northern Virginia cluster, dev, prod, and stage. This was the use case that we were discussing before. And here, what would be the name of those Argo CD applications? app1.path.basename.region. What is .path.basename? Can anyone answer that? .path.basename is dev, prod, stage. What is .region? .region is defined here. Region is Mumbai. Here region is Northern Virginia. So it will first create app1 dev Mumbai, app1 stage Mumbai, app1 prod Mumbai, and then it will create app1 dev Northern Virginia, app1 stage Northern Virginia, app1 prod Northern Virginia. So 6 total Argo CD applications will be created. So this is how we are combining. And again, .path.basename will result in dev, stage, and prod. I hope all of these things are making sense to you. So now let's go to our browser. I will go to app1 config, and here I will come here, add file, upload files. I will reduce the screen size. I will go one step back, 06 matrix generator. I will select these 3 directories. I will drag them here, and then I will click on commit changes, and this would commit the changes here. Let me first also delete the Argo kubectl, delete app set -n Argo CD. What is the name of that app? And app1 git files. I'll clear my screen. I will press ls. Let's cd into 06 matrix. I'll go here. kubectl apply -f 06. It's just matrix generator. I'll press enter and this has created. So if I now go to my browser, I'll full screen this. And if I go here, I should see 6 Argo CD applications created for me. I will go there once. I want to see my repository. Did I commit changes or not? I did. We see 3 of these here. And then here, let me just, I don't see any apps here. Let me come here. So kubectl describe -n first app set -n Argo CD. Are they in error state? They say generated successfully, but why don't I see them? Hold on. Let me just kubectl delete -f matrix generator. And then let me kubectl get app set -n Argo CD. There is no. Now let me run kubectl apply -f matrix generator. Let me quickly just refresh this as well, applications, and then let me just create this. I'm not sure what happened. So okay, no clue. So I think we did not delete the application set and we uploaded something new, so maybe there was some confusion within the tool itself. So right now what we see is what we asked for: app1 dev Mumbai, app1 dev Virginia, app1 prod Mumbai, app1. So you will see a total of 6 applications created. Now imagine how powerful this will become when you are dealing with 10 microservices, because those 10 microservices will have dev stage and prod and then different clusters. So it eases your job. You do not have to manage so many YAMLs. Now you would be thinking, Varun, which generator we should be using? Now, which generator you should be using is the question you should ask yourself, because I can only tell you what is available at your disposal based on your experience, based on what is that you want. Will be choosing generators. Whatever generators we have discussed, all these are very popular. And why I'm saying all these, because there are more generators that are available at your disposal. So if I go here or I go to this documentation from Argo CD, you see that there are multiple generators available. So we have already discussed list, cluster generator, git generator, both file and directory, matrix generator. All these merge, SCM, pull request, cluster decision, plugin generator, we have not discussed these. So there are more that you can use, but all of these things depends on your requirement. Now what I also want to do is, along with you itself, I want to delete the clusters that we have created. So I will go one step back and then I'll cd into 01 EKS. What I will write: EKS delete cluster -f01. I want to delete this. I will just also delete the other one. EKSCTL delete cluster -f02. This one. So this will delete the clusters for me. Now I think I have already covered what I wanted, but I would request you to go and go through the GitHub documentation so that if there are any gaps, they are filled. That brings us to the end of this lecture and the end of the Argo CD Basics to Production course. You should now understand how application sets help scale GitOps by turning deployment intent into dynamically managed applications across clusters and environments. More importantly, you should be able to choose the right generator based on who owns intent and how it is exposed. If this course helped you, do consider liking, sharing, and subscribing. It really helps the channel. Thank you for following along through the entire series. I am Varun Joshi and I will see you next time. Thank you very much. If you have made it this far, first of all, respect and huge congratulations to you. Going through 9.5 hours of structured GitOps learning is not casual effort. That shows commitment and discipline. By now, you should not just know how to use Argo CD, you should understand how GitOps works in production, how reconciliation behaves, how scaling patterns work, how to design guardrails, and how to think in declarative systems. That shift in thinking is what matters. If you followed along hands on, cloned the repo, applied the YAMLs, and experimented, you are already ahead of most engineers who only use GitOps without truly understanding it. Now, here is what I suggest next: revisit the sections that felt difficult. Try deploying a small personal project using GitOps. Break things intentionally and observe how Argo CD reacts. That's how confidence is built. If this masterclass helped you, the simplest way to support the channel is by liking the video, subscribing, and leaving a comment. It genuinely helps this reach more serious learners. And if you would like to support the channel further, you can join as a member. I don't lock content behind paywalls. Membership is simply a way to support the free structured DevOps education I aim to build here. Thank you for spending your time with me. Keep building, keep experimenting, and I'll see you in the next course. Thank you very much.